Python is one of the most widely used programming languages today. This easily readable, English-like language has lured many developers and has proven to be the most rewarding contribution to technology. Hi guys, welcome to the complete Python tutorial by Simplilearn. In this video, we will be covering some of the most important topics related to Python. Now let's have a look at them. First, we have Anjali and Richard to take you through the installation process behind Python, followed by a tutorial on Jupyter Notebook.
A very warm welcome to all our viewers. I'm Anjali from Simplilearn, and today I'll be showing you how you can install Python on your Windows system. It's a pretty straightforward method. So let's begin. The first thing you do is open your browser and search Python. Go to the very first link. And this is the official Python page. So if you scroll down here, you can see the most latest version of Python, which as of today is 3.7.1. And we will be installing the most latest version. So go to Downloads right at the top. And since we are installing on Windows, click on Windows. So here you have the various Python releases for Windows. As you can see here, 3.7.1 has a web-based installer. There's an executable installer, embedded, so on. Now we want the executable installer, and since my machine is a 64-bit one, I'll go for this. So of course you need to select the file that is suited for your system. So click here. And the setup file is getting downloaded. So once that's done, we'll open it. And this is your setup page. So now we need to install it, but before that, click Add Python 3.7 to path. So what this does is it ensures that you can access Python from the command line by just entering its name rather than the entire path where it's stored. So this really does make things simpler. And once you have ticked that, click on Install Now. Go for Yes. And the installation process has begun. And with that, our installation process is complete. So before we wind up, let's just test if everything's working fine. So go to your search and type in Python. So as you can see here, Python 3.7, which is the latest version, is installed. And then we also have the IDLE for Python, which is the integrated development environment. So let's test this out first. Now, this is not the typical place where you program, but you can have one-line commands here. So to test this out, I'll just have a print command. And enter. So hello world is printed. This is working fine. Now there's also a command line interpreter for Python, which is Python 3.7 64-bit that opens your command line. This works the same as our IDLE. Of course, it's simpler to write there. It's more convenient and aesthetic. Let's test the command line out too. And that's working perfectly fine. Now the command line and the IDLE for Python are great places to start with Python coding. But when you move on to actual programs, you'd want to opt for, say, Jupyter Notebook or PyCharm, which we will cover later in our videos. For now, that is all. So I hope everything was clear and you were successfully able to install Python.
Welcome to Simplilearn. That's www.simplilearn.com. Get certified, get ahead. Let's go ahead and take a look at the Jupyter Notebook for doing your Python programming in. So we're going to cover the basics of the Jupyter Notebook. I'm showing you how it works and what it looks like. Let's go ahead and start with the install. If you go to jupyter.org, that's jupyter.org, you can click on the install button and then you can run the prerequisites Python and downloads here. And you can see the setup on this. And you'll see the very first thing they suggest is that you install Jupyter using the Anaconda. So we have Jupyter Notebook and then we have the Anaconda setup, and that's www.anaconda.com. You just go up to the downloads. Once you're under the downloads, you'll see in the Anaconda that they have it set for version 3.7 or 2.7. I generally work in the newer version, although I did had to reset my Anaconda to 3.6 for working with Google's TensorFlow, which you can do very easily in Anaconda. This way, I remember the first time someone showed me Jupyter Notebook and Anaconda, I was so excited because of all the cool things you could do with it. So this is your install here. You can download it, open and run that. I happen to be under the Windows setup. It works on Apple, works on Linux. What's nice about Anaconda, with just the cool things you can do, the first one was Jupyter Notebook. Someone showed me the Jupyter Notebook, and you'll see this. Let me just flip back on over here for the Jupyter symbol. And then Anaconda creates environments. So it makes it very easy to create a Python 3.7 environment with the different modules installed. So if you're working with, I referenced Google TensorFlow, I had a little troubles with that and had to go to Python 3.6. You can easily do that. You can create an environment for Python 3.6. And that's all through the Anaconda. So once you've installed this, there's a couple ways to get to your Jupyter Notebook. So you'll go ahead and just download and run the Anaconda install. And then in this case, I go into my Windows and I actually have Anaconda 64-bit. And we can go to Anaconda. Oops, there's Jupyter Notebook. You can directly access it that way. You can do the Anaconda prompt. I can do Jupyter Notebook. I'm going to go back and do this the way I like to do it. But let me just show you what this looks like. When I hit enter on here, it opens up a browser window, and I now am in Jupyter Notebook where I can create new projects. I can go in here and create a new file running. And we'll look at that in just a minute on what that means. But let's go back a step. I'm going to go ahead and close out of this, and we'll open up my Anaconda. And when I run my Anaconda, it'll start up here in just a second. This is the same, by the way, they have a shortcut icon, but it's the same thing as going down here to, let's see where we, Anaconda Navigator. So I'm running out of the Anaconda Navigator, which I just love. I just adore the Anaconda Navigator. And the Anaconda Navigator comes up with all kinds of cool tools. You'll see over here I have applications on, and it says base root. What you find out is if you click on environments on the left hand side, base root is the one that defaults to, but I also have my data science, I have my stock poll, I have another one is called no GPU because I was working with some GPU setup. You can create as many environments as you want. I can go down here and create a new environment. I can tell it what I want in that environment, which version of Python. You can click on one of the environments and clone it. At the very end of environments, this little triangle, if you click on there, you can open a terminal window. You can open it in different ways. The terminal window then allows you to use, usually like if you're used to Python, use pip install. You can use pip or conda install. Conda does the same thing as the pip, except it looks for all the dependencies. So if I'm in a rush, I use conda. If I am working in this and I need to be tracking exactly what I install on here, then I use the pip. When you're in an environment, don't mix and match the two. Stick with conda or stick with pip, because you can run into problems with imports and reliance and stuff like that. So we'll go ahead and go under data science, because that's what I enjoy doing, data science. And so when I go back to my home menu, you'll see my data science opens up and I have my Jupyter Notebook first thing. And there's a lot of tools. You can open up R Studio from in here. I've never really used Spider that much, but Spider is another Python editor. There's the Jupyter Lab, VS Coding. So there's a lot of steps in here. There's even stuff you can add in. Mostly I use Jupyter Notebook, and then occasionally I use R Studio. So I try to wrap everything in here. The first time you open Jupyter Notebook, you'll have this little install, because it doesn't automatically install the Jupyter Notebook underneath this environment until you're ready for it. And then we go ahead and just launch it. And it's going to open it up in whatever my default browser is. So it's going to go underneath my Chrome browser and open that. And once it's in the browser, I'm now in Jupyter Notebook, just like we did the other way. So we did it two different ways to get in here. This is, I've set this to my data science setup. You'll see down here I have folders. It's actually on my D drive. I pointed this to my D drives because that's where I keep everything. And I can go under Simplilearn, and you can see we have different tutorials and different things we've done in here over the years. Actually, over the last year, since this is a fairly new computer, this is over the last couple months. I think my oldest one here, I do have something from 5 months ago, but that was brought it in from earlier, so it's about 2 months old, my computer. And I want you to notice that the extension on these is IPYNB. And this is important because when you create a new Python file to run in here, it's going to create what they call an iron Python file. So in here you'll see IPYNB. We'll just go ahead and zoom in so you can see that a little better. There's our IPYNB. And we'll go up here to on the upper right, And you can upload data and all kinds of things in here, but we're going to start with just creating a new notebook. So I'm going to click on here, and I'm going to click this one. We're going to work in Python 3. So I'm going to click on Python 3. And by default, if you installed 3.7, it's going to be running 3.7. I have to actually set this to 3.6. I went back and changed the environment to make sure it's running 3.6 in here. And we're now actually running Python script. So we can just go right in here and type in print. And everybody does this, the hello world. And then I can go up here and I click on the big run button, and it's going to run it, and it's going to print hello world. And just like any notebook, I can go up here to view a toggle header. So now my header is on. This is untitled at number 4. We can click on here and change this to, we'll call this Jupyter Notebook Basics. And then I'll hit rename. And so now you can see Jupyter Notebook Basics. And if I hit the little save disks, it's now saved my hard drive, so I can go back and open this up at any time. If we go back to this window, Jupyter Notebooks Basics, right there it is. So, and it's running. So these are the files I got up and going, and it's got an open kernel. Now, kernel, it opens up a kernel to execute the program in. And when we're looking at this, it's important to know that it's only setting up one kernel. So everything in your Jupyter Notebook is going to work great except for multiprocessing. Even multi-threading works fine in Jupyter Notebook, but if you get into multiprocessing, you'll start seeing some problems because it's only opening up one kernel to run it in here. And if we go under kernel, you can see how we can restart it. Make sure you want to restart it. So any variables that were saved, let's do this. Or let's just call it hello. Hello equals hello Simplilearn. Hello Simplilearn. We'll just print B over here, or hello. So if I run this, hello is now stored. But if I go up to kernel and I interrupt, if I restart the kernel, hello is no longer stored. So if I print hello and I run it down here, it's going to give me an error because it's not stored. Or if I come up here and I hit run, it's now stored on here, and I hit run on this cell, it still continues in memory. So it continues down there as long as it's not interrupted. And this brings up another interesting point is we run each cell one at a time. So when I hit the run button, it doesn't go through all the cells unless I want it to. And it's so easy to click on the run button when you're doing a lot of editing, but there is shortcuts to that. I can also do Shift Enter, and that's the same as hitting the run button. So it's running this first cell, which is labeled number 4. We have our output from that cell, and then we can go down here and run the second cell, and there's our output from that cell. So it's literally running one section at a time. And when we go up to kernel, we can interrupt the kernel. If you have a long run, you can just stop it, which terminates the program completely. We did the restart, which resets the kernel. I always use restart and clear output, which then clears all your outputs on here so you know that those aren't saved anymore. You can go to restart and run all. So restart and run all will start from the top cell. It'll run it, then it'll go to the next cell and run it, and it goes all the way down. You can also do the same thing under cell. You can do run cells. So it's going to run the top cell and go down, run cells and select below. You can see how that just runs the first cell and then moves down to the next cell. Then you can do run cells and insert below, run all above, run all below. Pretty self-descriptive. So you have a lot of choices to run. The most common is either to click on the run arrow or hit the Shift Enter to run your code. And one of the really great things about this is once you start playing with it, it's so visual. I click on the cell and I'm editing that cell. I come down here and click on the next cell, I'm editing that cell, whether I'm deleting it or whatever I'm doing on here. So you can see it's pretty straightforward as far as the setup. And these are the most basic editings you can do, of course, is just to put your code in. And because it's such an easy input, it's so easy just to keep scrolling down and adding new cells in so that you can go back up and execute different portions of your program. Let's go ahead and do an input, and we'll set up, there we go. Let's add a space on there just so it looks nice. And then we'll put print, hi, comma name, and let's go ahead and run this. And a couple of things to note is there's an asterisk appears here on the left. So this piece of code is running right now. And the enter comes in line. And so I can go ahead and type in my name, Richard, hit enter. It says, hi, Richard. So a real quick short program on there. This inline editing and output makes us great for doing presentations. The first time I did this, we were doing data science, predicting when the huge blowers on the sewage plant go out, these huge aerators. And when they go out, they cost a lot of money to replace. And so we're trying to come up with a code that would look at the different wobbling so they could replace the pieces instead of having to replace a whole aerator. So they could replace the bushing instead of having to go in there and replace the whole fan unit. The fan unit runs about $5,000 to $10,000. The bushing is an hour worth of labor and runs about $10. You know, difference between $5,000 and $10,000 versus $10 is huge. So if you could predict when it starts to wobble too much and something's going wrong, but they did it visually, so we could actually see the plots on here and stuff like that, and the outputs. And we'll show that in just a minute, what it looks like to put a plot on here. But just for a quick rehash, print, let's see, hope to see you in class soon. When you run the cells, they run top to bottom, and it only runs one cell at a time. So whatever cell I click on, that's the cell that's running. And you can see the asterisk appears, it shows I'm running. And once we type in our name, it actually prints whatever the output is down below. In this case, enter your name, Richard, enter. And it won't print, hope to see you in class soon, until I click on this cell and run it. And then you'll see, hope to see you in class soon. So you have a lot of control. You can work on one piece of code. Maybe you're loading your variables up, and then you can start executing the code based on those variables. But you do have to remember, if the problem is in the cell above, you got to fix that. You can't just keep working on the cell below and expect it not to change the answer. Another important thing to notice, this is a title. You know, use your comments to comment something else. But in Jupyter Notebook, I can come in here to the cell, and I can change the cell type to Markdown. And you can see in Markdown it changes the colors and everything, and when I run it, you know, I end up with this is a title, this is a bigger title. So I can create nice titles in here if I'm working with a project and I'm actually doing a demo. I'm actually doing some kind of production, I'm showing the graphs, and I've generated the graphs already in my Jupyter Notebook. Instead of going back out, putting that into a presentation, I can just open up the notebook, scroll down, add my titles in, and I'm ready to go. So you can see right here, it's very useful to be able to tag a box as, in this case, Markdown for our cell. And then I mentioned to you that we can also do our plots in here. So let's go ahead and import Matplotlib as PLT, very commonly used that way. I will do a plot. Let's just keep it simple. 1, 2, 3, 4. And we'll just keep it as a straight line. So we'll do 1, 2, 3, 4, comma 1, 2, 3, 4, XY coordinates. And this is X and Y, if you want to call it that. But it's your first set of coordinates and your second set for the Matplotlib. And we'll simply show this, plt.show. And when we do Shift Enter or hit the Run button, typo there, I forgot to put in the pyplot, since that's what we're using. Matplotlib.pyplot is PLT. And when I run that, we're doing a nice straight line. So it's going to go ahead and do the figure size. It does a basic figure size 640 by 480 with one axis. And you can see it displays it right in line. So we can do a lot of work with this as far as any of your Matplotlib library is going to come in line, and you'll see a nice display here. Again, just a diagonal straight line we're displaying. And if I wanted to, I could do something. Let's do this. I'm going to just change this, double click on it to edit it. Below is a graph of a diagonal line. And so we have our title, below is a graph of a diagonal line, and then we have our nice plot of a diagonal line. And I could even break this up. Let's do this. Insert cell below. So now I've added a cell below this one. I'm going to take our plot show, and I'm going to put it down 2 cells. And I'm going to do this one as a markup. And we'll do cell type, or markdown, I call it markup. And we'll say, welcome to my simple graph. And so when I run this, it makes a nice markup. And then I run this cell, and we get a nice plot show. So we have our plot, and I run it, and you can see welcome to my simple graph. So everything's nice and orderly. This is kind of nice because once you set this up, you can see how you can create a nice presentation while working on your project. You don't have to even get out of your project to generate the information you want to show to the shareholders. And if it takes too long, let's say we're running this script, you know what, let's just kind of overload it here. We'll do a lot of plotting. I'm going to run it, and it happened too fast. If your kernel gets stuck, you can always interrupt the kernel. You can restart it or interrupt it. Usually you restart it because it's loaded data in there and you want to reload the data. But if I restart it here, remember we did that before? Whatever I had that ran up here where I set hello up to hello Simplilearn, that's gone. I have to rerun this cell to reload that data into the variable hello. And of course I can do run cells and selected below or run cells and just run all. I can run all and it goes all the way to the bottom. So it's not a big deal if you forget, but you can easily run all the cells. I do want to point out one thing, since we did a run all, it's still doing some plotting in here and coming down for whatever reason. If you go to the top, you'll see up here in the tab there's an hourglass. That means this kernel is running. We'll go ahead and interrupt this kernel, and I'll take it a moment to interrupt the kernel and stop it. You'll see that shut down in just a minute. There's so many cool things you can do with Jupyter. I get so excited. And it's so simple. There's not like a huge number of hidden commands on the page, although certainly there's all kinds of back-end stuff you can do. One of the things you can do in here is I can go up to File, and if you go under File, you'll see down here, Download As, and I can download it as a notebook, which it automatically saves as. I can download it as a python.py file, so it would remove the non-Python stuff in there and you just have your regular Python file. And I can also download it as an HTML. There's also the JS slice, REST, Markdown, but I love the HTML, my goodness. I click on here in the machine, but I'm going to go ahead and open it. And it opens up in my browser, and I can actually take this code and just put it onto a web page. So now I have my HTML code of what I just did. You know, that's pretty cool. You can flip that over so quick and easy. So we've covered a lot of stuff. We've covered that it runs in a single cell. We've covered going through the kernel, interrupt, restart, clear output, restart, run all. We've discussed cells, where you can run the cells below, run the cells above, run all, most common. We covered cell type. We've gone under File, and we've seen where you can go ahead and download as a different version. There's a lot of other things in here, but those are the main ones. You can save and create a checkpoint. You can rename it. We clicked up here to rename, but if you're under View, let's say I don't want the header on, I can still just go under File and rename. So if I don't want to see the header and I want that extra screen space, which I like, I can toggle that on and off. I can toggle the toolbar off, put that back on with all those shortcuts. And to wrap it up, one more reference. Let me just close these out. If you do Jupyter Notebook repositories on Git, and I just go to Trending Notebook repositories on the GitHub, you'll see all kinds of stuff on here that you can go practice with. You can pull what somebody else is working on. They have Practical AI, Deep Learning, TF2 course, TensorFlow examples. That's the Google TensorFlow I mentioned earlier, which is a neural network. Hands-on machine learning. I don't know what any of these actually are, other than by the name, but you can see they have a lot of stuff that's published on GitHub, which helps you get started. You find something you're interested in, you do a search on GitHub, and you'll find that Jupyter Notebook on there. Gets you some hands-on. And then just regular coding. How do you become a good Python programmer? You write Python code. That's the basics. So thank you for joining us today. We covered Anaconda and Jupyter Notebooks.
Now that that's done, we have Richard and Anjali to teach you about Python variables, numbers, data structures like arrays and lists, conditional statements, functions, objects, classes, threading, and scripting.
I'm Anjali from Simplilearn, and today I'll be taking you through one of the most basic topics in Python, variables. So here's a very simple statement, x equal to 100. A variable's definition is basically an entity of a program that holds a value. So in this case, x would be our variable and 100 would be the value it holds. To better visualize this statement, let's consider a box. Now if this box holds a value, say 100, then the name we give to this box, which in our case is x, would be the variable name. And 100, that is the content within the box or within the variable, would be the value of the variable. Now this is the basics of what a variable is. As we'll go through the various topics today, you'll have a better understanding of why we use variables and how to use them. So let's move on to the next topic, which is the various data types of variables. Before we move on to this, let me explain to you what data types are. If you have dealt with other programming languages before, you probably already know what data type is. But just in case you haven't, data type is basically the type of value that you assign to the variable. So in our previous example where we said x equal to 100, in layman terms 100 is a number. So the data type would be number. But when we come to programming languages, there are two types of numbers. There are integers and there are floats. Integers are basically numbers without decimal point. Floats are numbers with decimal point. Other than this, a very common data type that we have in Python and other languages is string. So string is any word. In technical terms, we call them a collection of characters. Python also has a few of its own data types, as we will see. So let's move on. So I'll move on to my Jupyter Notebook. So the first data type that we'll be looking at is integer. As you saw in our previous example, x equal to 100 is an apt example for this. Let me run this statement. As you can see, there's no error. That means this assignment is proper. Now we'll check the type of this variable. So type, and within bracket, you enter x. Run this, and as you can see, the type is int. So int is the short for integer. Any number without a decimal point comes to int in Python. Now this is not the only way you can assign values to variables. You can also assign values to variables while simultaneously performing arithmetic operations on them. So 654 into 6734, enter. Now let's check out the type of this variable, which would be int again. Now if you print the value of this variable, you'll see that the value x stores is the product of these two numbers. So now let's move on to the next data type, which is float. X equal to 3.14. As you can see, this is a number with a decimal point. If you run this, there won't be any error. So this is a proper assignment statement. You print x and the value is printed. Now you print the type of x, run, and it's float. We'll move on to our next data type, which is strings. So string is any word, it's a collection of characters. So x equal to, and within quotes, so I'll type Simplilearn and run. So no error, print x, and the value of x is printed, which is Simplilearn. So guys, whenever you're assigning strings to a variable, it's important that you do them within quotes. Now you can do them within single or double quotes. I'll show you how it's done within single quotes. And the exact same output. So it does not matter whether you use single or double quotes. Now let's check out the type of this variable. Type x and str, which is a short form for string. So now that we had a look at integers, floats, and strings, let's move on to some of the data types specific to Python. The first one we look at is lists. So a list is basically a collection of values. So far we assigned a single value to a variable. With lists, we can assign multiple values. And this is how it's done. So give the variable name equal to, open square brackets, and within this you type your values. So 14, 67, 9. Run this, no error. Now let's print x and see what this results in. As you see, when you print x, all the values you stored within it is visible. Now let's check out the type of x. And the type is list. Now with list, since there are multiple values stored within a variable, you might be wondering how you can extract a single value. So this is simple. Each value in a list has an index. So you always start with 0. This is the 0th position, first position, second position. So if you want to extract 14, then you type print x0 and that will display 14. If you want to print the last value, print x2, because we start from 0, so this is 1 and this is 2. So that should print 9. Great. Now we'll change the values which are stored within the list. So if I say x2, which right now is 9, but I want to change this to 67. So that is a simple statement how you can do so, and run. Now let's see what x holds. So when you just type x, you're printing every value within x, and when you give a particular number within the square brackets with x, you're printing the value at that particular location. So print of x, run. And as you can see here guys, previously x held 14, 67, 9. Now it holds 14, 67 and 67 again because we changed x of 2 to 67. So now that we are done with lists, we'll move on to another data type in Python. This is called tuple. So with tuple 2, it's about the same thing. You can store multiple values in a single variable. The syntax for doing so though is slightly different with tuples. So instead of square brackets, you now have round brackets. And within that, you type in your values. So I'll just put 4, 8, 6. And let's print x. So all the values within x is printed. Now let's check the type of x. And the type gives tuple. So you might be wondering what is the difference between list and tuple. Now the core difference between list and tuple is that tuples are immutable. So what I mean here is that in case of tuples 2, you access each value within it in the same way you do with lists. So if I want to access the value 8 in x right now, I'll just give x within square brackets 1. Print this. And it outputs 8. But now, if I want to change this value, so the way of doing that, as we saw with list, is x of 1 and the value I want to change it to. So let's say 5. And I run this, we get an error. So you cannot change the values in case of tuples. Once you have stored the value within the variable for a tuple, it remains that way right till the end. And in technical terms, this means that tuples are immutable, while lists, for which you can change the values, they are mutable. So now we have something slightly different. When we deal with files, we need a variable which points to a particular file. So in general, these are called file pointers. The advantage of having file pointers is that when you need to perform various operations on a file, instead of providing the file's entire path name or the file's name every time, we can just assign it to a particular variable and use the variable instead. So this is exactly the advantage variables have with all other values too, but the syntax for doing so with files is slightly different. So I give x equal to open and within brackets, open quotes, enter your file name. So I want to open, say, a file called variable underscore com, and this is IPYNB, so it's my Python notebook, and the mode I'd like to open it in, so R. Let me run this. No error, so it's fine. This kind of an assignment is completely legit. Now we'll check the type of x. So as you see here, the type for x is underscore io.text io wrapper. So in Python, this is the particular type assigned to this variable, but in general terms, you can refer to them as file pointers. Now suppose you want to assign values to multiple variables. What you can do here is, instead of having statements like x equal to 5, enter, y equal to 10, enter, z equal to 7, instead of having 3 such statements, delete, open bracket, x, y, z, within bracket, equal to 5, 10, 7. And this works exactly the same. So now if you print x, y, and z, you'll see that they have been assigned their respective values. Of course, the number of variables and the number of values on either side should match. So if you put x equal to y, so if you give x comma y equal to 5, 10, 7, this would result in an error because you have only 2 variables on your left hand side while you have 3 values on your right hand side. Now suppose you want to assign the same value to multiple variables. In that case, you can do, now suppose you want to assign a value to multiple variables. Say x equal to 1, y equal to 1, z equal to 1. A short form to this, as you saw previously, would be x comma y comma z equal to 1 comma 1 comma 1. But then again, you'll have to type the same value 3 times. Instead, what we can do is x equal to y equal to z equal to 1. and this would work perfectly fine. So if I print the value of x, y, and z now, they all have the value 1 stored within them. So we have covered the various data types in Python and how you can assign values to a variable in multiple ways. We'll next move on to the various rules for naming the variables. Now there are certain rules that you must follow while naming the variables. We'll go through each of these rules, and simultaneously I'll also demonstrate to you in our notebook the validity of each variable. So our first rule is variable name must begin with an alphabet or an underscore. So let's move on to our notebook. So ABC equal to 100. This should be valid because it starts with an alphabet. At the same time, underscore ABC would also be valid. So if the variable starts with an alphabet or an underscore, it's a valid name for the variable. But if we say 3A equal to 10, this would result in an error. Of course, because the variable name starts with a number, and this is invalid. Same way, we cannot start the variable name with a special character other than underscore. So if I say @ABC, this would also result in an error. As you see, the error is invalid syntax because that is the invalid syntax for a variable name. Let's now look at the second rule for naming variables. The first character can be followed by alphabets, numbers, or underscore. So our first character must be an alphabet or an underscore, and after this first character we can have alphabets, we can have numbers, or we can have underscore. So back to our notebook. By the second rule, 100 should be valid as it is, and if we put underscore, which is a valid starting character, 984, so our first character is followed by a letter, 3 digits, and then another underscore. This should also be valid because at the end of the day it only consists of numbers, letters, and an underscore. However, if our variable name is A9967, few digits, and then a $sign, would this work? Well, no, this would result in an error, invalid syntax, because as already mentioned, for variable names, the only special character you can use is underscore. What about XYZ-2? Again, this would be invalid because it includes a special character that is not underscore, can't assign to operator. Let's have a look at our third rule. Variable names are case sensitive. So what case sensitive means is that small letters and capital letters are treated differently. So let's move back to a notebook and say I assign a value 100 to a variable A100, small a, and I assign another value 200 to a different variable, capital A100. So as you see here guys, between these two variables, the only difference is that the first variable has a small a and the second variable has a capital A. Let me just execute this. If I print the value of A100 and capital A100, you'll see that both these variables are recognized as completely different variables. They have their individual values. So now that we established that variables are case sensitive, we can also say that Python itself is a case-sensitive language. Now a final rule is that reserved words cannot be used as variable names. Now if you have gone through any other languages like C, C++, Java, you know this is a common rule among all of them. You cannot use words which have special meaning to the language as variable names. So some of these words are break, class, try. You have other words such as continue, while, which is a loop, or if, which is a statement, a conditional statement. So let's go back to our notebook and see how assigning values to these reserved words can result in errors. So if I give break equal to 10, that would be an error. Similarly, class equal to 5 would result in an error. Try equal to 100 would also result in an error because these words break, class, try have special meaning to Python. And with that, we cover the various rules for naming variables. The next thing we'll check out is the arithmetic operations that you can perform on these variables once you have stored integer values in them. Also perform various arithmetic operations with variables that store integer or float values. So let's have a look at some of these operations that we can perform. We'll start with initializing two variables. So x equal to 20 and y equal to 10. And now we'll perform our operations with these two variables. So first, let's check out how addition works. Result equal to x plus y. So result is a new variable and it should store the value of x plus y. Let's print this out. And as you see, x plus y equal to 30. So now result stores 30. Similarly, we can perform subtraction. We'll print this out too. So 20 minus 10 is 10. We can also perform multiplication. We use asterisks for the multiplication sign. So 20 into 10, that's 200. Next, we'll check out division. So as you can see here, in case of division, the result is not an integer but rather a float. If you want your result in integer, what you can do is instead of putting just one slash, you can apply two slashes. So x slash slash y. And print the result. And there you go. Now you have the result in integer. So in this particular case, since 10 completely divides 20, the requirement of the double slash is not very visible. But if we do division for numbers that do not divide each other completely, for example, if we have result equal to 2 by 3 and we print the result, we get 0.66 and so on. But if we give double slash here and run this, we get the result as 0. So in a lot of cases, the result from double slash makes way more sense than from single slash. So this is an extra benefit you have with Python, which is not present in many other languages. We also have the modulus operator here, which gives the remainder rather than the quotient. So if I say x mod y, it'll give me the remainder of the division from x by y. And the remainder is 0 because 10 completely divides 20. On the other hand, if you do want to see the remainder, you can give numbers such as 3 by 3 mod 2. And then print the result. And as you see, the remainder of this operation would be 1. Now, so far we saw arithmetic operations with integers. All these operations can also be performed with floating point numbers. So if your x value is 3.14 and your y value is 5.7, let's just perform one operation using the new values of x and y to see what it looks like. So let's say result equal to x by y, print result, and there's your quotient. So arithmetic operations work both with integers and floating point numbers. Next, let's check out some of the operations you can perform on string variables. As I mentioned earlier, strings are basically a collection of characters. So let's look at a few string operations. First, we'll initialize a string variable. So var equal to Simplilearn, and we'll perform all our operations on this var variable. Now the first thing we'll do with this string variable is we'll see how we can extract each character in string. So just like in case of list and tuples, every character in your string has an index and it always starts with 0. So the first character is at location 0, second at 1, third at 2 and so on. So if you want to extract the first character of your string, which is s in our case, we just do var of 0. And as you see, s is printed. Similarly, if we want to extract the fifth character of our string, we'll put var of 4. So if you want to extract nth character, your index for it would be n minus 1 because we start our index from 0. And that prints L. So as you can see here, S is 0 and then we have 1, 2, 3, 4 and that is L. So now that we learned how to extract a single character, let's see how we can extract multiple characters from the string. Suppose I want to extract the first 3 characters. In that case, I would say var of the first 3, so my starting character would be at 0. So if I want to extract the first 3 characters of my string, what I'm basically saying is that I want to extract the character at the 0th, 1st and 2nd position. Then I'd say print of var of starting from the 0th location up to the 3rd location. We say 3 and not 2 because the last index is always excluded. So if I put 2 here instead of 3, then only the 0th and the 1st character would be printed. So I want my first 3 characters to be printed. So var of 0 to 3, and I'll run this. And as you see, the first 3 characters have been printed, capital S followed by IM. Now if you want to start from your first character, you can also just ignore the 0. So you can say var of :3. That is, we are not typing the 0 in this case. It's automatically understood that you start extracting from the first character when you miss out the 0. So you run this, and as you see, it's the same result. Now if you want to print the character starting from the 5th location until the end of the string, you can go with print of var of 5th character, so 5, and up to the end. In this case, you do not need to mention the last index. You can just leave it blank and it's automatically understood that you're printing till the very last character of your string. And as you see, from your 5th index to the very last character has been printed. Now suppose you give var of 0 to 20, and it's pretty obvious that you do not have 20 characters in this particular string. So you do not have 20 indexes. So what do you think would happen if I do 0 to 20? Well, the entire string is printed. So although we have only 11 characters in our string and we have given the ending index as 20, this does not result in an error, just our entire string gets printed. Now if you want to find out the length of your string without actually having to count it manually, you can use the function len of var. Len is an inbuilt function in Python. Now run the command, and as you can see, we have 11 characters in our string. And today we look at what numbers in Python are. So I'll be using Jupyter Notebook to explain all the concepts in numbers. So let's move on to this. Now the first thing we look at is the different type of numbers Python supports. So first and foremost, we have our most common type of number, which is int. So here I have a variable num, which is equal to the value 5. Now if I check the type of this variable num, and I run this, as you can see here, num is type int. So int is basically any whole number, that is, it does not have a decimal point or so. Now the thing with numbers in Python is it can be of any length. So this can also be stored in our variable num, and it's stored as an integer itself. So the only restriction you have with size when it comes to Python and integers is the limitation of your system's memory. Now let's look at the second type of number that Python supports, and that is when we have floating points or decimal points. So if I have a value 5.4 which I store in num variable, and then I'll check the type of my variable num, and as you see here, this is a float type variable because now it stores a decimal value. Now just like integers, floats can also be of any size. Now here's something new. You probably remember complex numbers. That is, complex numbers have two parts. There's the real part and there's the imaginary part. Now Python also supports these. So if I have num equal to 2 plus 5 j. So the j represents the complex part. Now often when you write, instead of j you use I. It's basically the same. And I'll check the type of num now. And as you see here, it's complex. Now you can also view the real and the imaginary parts of your variable num separately. And for that, I just need to type out num.real, which displays the real part, that is 2.0. So as you notice here, the real part, although we entered it as an int, that is just 2, once we print this out, that is a complex number is automatically stored in Python in floating points. So once you printed out the real part, it's 2.0 and not 2. So now it's float. And in the similar manner, I can also print out the imaginary part. And there you go. So both the real and the imaginary part for a complex number in Python is stored in floating points irrespective of whether you enter it as an int or a float. Now numbers can also be negative. So you can have num equal to minus 567 point so on. And if I just print this out, so our variable can also hold a negative value, not just positive. Now, when you think about numbers, the obvious thing are the mathematical operations or the arithmetic operations that can be performed on these numbers. So Python 2 supports a number of these operations. So to demonstrate this, I'll create two variables in which I'll store two integer values. Say num1, which has value 10, and num2, which holds 2. Now, the first and the most basic arithmetic operation is, of course, addition. So num1 plus num2. And that's how simple it is to use your arithmetic operations in Python. Just like you write them, the exact same thing, you need to type them out. So 10 plus 2 is, of course, 12. Similarly, we have num1 minus num2. 10 minus 2, which is 8. There's multiplication. 10 into 2, which is 20. Division. 10 by 2, which is 5.0. Now, as you see so far, since num1 and num2 were holding int values, our results were also int. That is for addition, subtraction, and multiplication. But now when we did division, our result is in decimal points. So division always in Python gives out decimal values or floating point values. This is because if we had divided 10 by 3, the answer wouldn't be a whole number. There would be some value after the decimal point. Now, Python gives importance to these numbers, unlike many other languages, so that have minimum accuracy lost. Now, say you do not want the answer to be in floating points. So, although 10 by 3 actually does give 3.333 and so on, you want the result to be just 3. That is, you want to focus only on the whole number part. In that case, you can have division with 2 slashes. So when you put 2 slashes here, the result is an int value. Now suppose you want to raise 10 to the power of 2. That is, you want to raise num1 to the power of num2. In that case, we just use two asterisk symbols. So num1 star star num2. And as you know, 10 to the power of 2 is 100. So in case of division, we saw how to get just the integer value or get the floating value. Now what if you do not want the quotient at all? You want the remainder of the division. In that case, you can use the modulus operator. So you have print of num1 mod num2, and that gives 0 because 10 is completely divisible by 2. The quotient is 5, but the remainder is 0. So if I use this operator for 10 by 3, that's 10 mod 3, now we'll have a remainder which is 1. So that's because 3 into 3 is 9 and you have a remainder of 1. So the next thing we look at is conversions. Now if I say x equal to 192, as we saw earlier, this would mean that x is of type int. But if I just enclose this 192 value within quotes, it makes it a string. So now, although essentially what we are storing is a number 192, because it's enclosed in quotes, it's seen as a string. So now x stores a string value. If I check the value of x, the type of x, you see it's of type str, which is a short for string. Now, often when you take input from the user, it's always in a string format. So Python, irrespective of what the value that is entered by the user, always stores it in a string format. And now if you need this to be of integer type, floating point, complex, or any other type, you need to explicitly convert this. So that is what we look at over here. Now, initially we have stored a string 192 in x, but we want to use this as a number and not a string. So then we need to convert it to integer type. For that we use the int method. You say int and you just pass the variable within the brackets. So when you do that, as you can see here, the value printed out is an integer. But now it just printed out x as an integer. X still holds a string value. So to change this, we say x equal to int of x. Now x is converted to an integer type and then stored back into x. And now if I check the type of x, as you can see here, it's now an int type variable. Now we can also convert this to float. So if I say x float of x, it's converted to float. And now if I print out the value of x, you see it's 192.0. So what we did here is initially we stored 192 as a string into X. We checked the type of X and it was str, that is its string. Then we converted X to an integer type and stored it back into X. So now X is int type. After that, we converted X to a float value and stored it back into X. And that changed the value from 192, which was a string, to 192.0, which is now a float. Now you can also change this to a complex number. So I say X equal to complex of X and then print out X. So as you see here, 192, which was our value stored in X, is the real part. And since we didn't have any imaginary part previously, so J's magnitude is just 0. Now there's also a function to create complex numbers. It's called complex, just that. And within brackets, you can pass your real and imaginary part. So suppose I want my real part to be 2 and my imaginary part to be 6. So I just pass that as parameters to my complex function and I'll print out whatever this function returns. And as you see here, it returned a complex number which was created from the two numbers we passed to complex. Let's now explore some inbuilt functions that work with numbers. So the first one we'll see is absolute, which returns the absolute value of a number. That is, whether your number is negative or positive, the returned value is always positive. So if I have a variable, say x, which is equal to minus 7.5, and I print out the absolute value of x, so the function name is apps, and within the braces I pass x. So as you see, although x held a negative number, the value returned by the apps function would always be positive. Next, we'll check out the exp of function, that is the exponent function. Now the exponent function takes a single parameter and it returns that parameter as the power to e, that is e raised to the power of the parameter that you pass to exp. Now before we use the exp function, we need to import the math library because exp is present within the math library. So if I say x equal to 10 and I want to print out e raised to the power of 10. So math.exp and you pass x. Let me run this. And that is the value of e raised to the power of x. Now if you're wondering what the value of e is, Python holds e as a constant. So if I say math.e, you can see the value of e here. Similarly, Python also has pi stored as a constant, which is 3.14 and so on. Now let's check out another function within the math library, which is the square root function. So you pass some value to this function and it returns the square root of that value. So I'll print out math.sqrt of 9 and that returns 3.0. So it prints out a floating point number, not an integer type. So even if I pass 6, which is not a square number, still returns a pretty accurate value. Now we have another function. Now this is not within the math library. It's present by default and this is the max function. So if you have a large number of values, you can pass all these values to the max function and it will return the maximum out of all of them. So let me just pass a few random values and run this. And it returns the largest of the numbers passed. Just like max, we also have min, which returns the minimum of the values passed. And the minimum is 1, obviously. So numbers have very basic concepts and we have covered most of the important ones here.
Today you'll be learning what lists in Python are. So we'll start with the basic definition of what a list is. We'll then see how you can create the list. We'll then have accessing of the elements in the list, the various operations that can be done on the list, and then methods and built-in functions specifically for lists. And finally, we'll have a short exercise using some of the concepts that we learned today. So what are lists? A list is a collection of data, and this data could be of any data type. In fact, a list could hold data of different data types. As we can see in our example down here, we have a list named X and X holds 1, 89, the single letter A, the string hey, another number 0 and the capital letter B. Now another important factor with lists are its indices. Every element in the list has a position and this position is called an index. The first position in a list is always 0. So 1 is at index 0, 89 at index 1, A at index 2 and so on. So this means that the position of your last element would be the length of your list minus 1. So now that you know what a list is, let's move on to how you can create a list. So this is my Jupyter Notebook, and we'll start by creating the most basic list, which is an integer list. So my list name would be num, and then open square brackets, and within this just put in your numbers separated by commas. So that is my first list. Run this, and there seems to be no error. Let's now print this list out just to see what it looks like. And as you can see, the elements that we inserted in this list are printed, which are 1, 2, 3, and 4. Next, let's create a list with just single characters. So my list name is letter, and the syntax is exactly the same. You open square brackets, and now that we have letters inside, which are characters, you type these within quotes. Let's print this too. And once again, after the run, you can see the letters that we inserted into our list letter. Next, let's create a list of strings. So I'll name my list stg, open square braces, and again strings should always be written within double or single quotes. And that's my list of strings. I'll print this too. Great, so now we have created a list of only integers, only letters, and only strings. Now, as I mentioned before, lists can contain a combination of different data types. So let's try that out. I'll name my list mix because it's going to be a mix of numbers, strings, 2 numbers, and then I'll follow this up with a few strings. And let's run it. So that works perfectly fine. Now lists have another format. If you have worked with any other programming language previously, you would have come across the term matrix. So usually in other programming languages, matrix are associated with arrays. So they are basically 2D arrays. In case of Python's, matrix can also be of lists. So you can have a list containing 2 or more lists. So let's do that. I'll name my list mat, as in short for matrix, open square braces, and since the elements of this list are also lists, put these 2 in square braces. So our first list would be 1, 2, and then comma, because our second list is basically the second element of our list mat. And our second list would be AB. And that's how you create a list containing lists. So our parent list is mat, and this contains 2 lists. The first list is 1, 2, and the second list is A, B. So let's print this out. And there you go. So we also created a list containing lists. So these are the different type of lists you can create. Next, we'll move on to how you can access the elements within this list. So there's no point of creating a list if you cannot access each individual element within the list. Now here, to understand how to access the elements of the list, we'll be using the list mix that we created previously. So before we start, I'll just print out mix so you can have an idea of what is inside. So we have 5 elements within mix. The first 2 are numbers or integers 1, 6. And that's followed up by 3 strings, Simplilearn, get, certified. We previously saw that every element in the list has an index position. So the simplest way of accessing an individual element in the list is by following the list name with square braces, and within the square braces, mention the index number of the particular element. So if I want to access the element get, my index would be 0, 1, 2, 3. So mix of 3. And I'll run this. We got our element get. Now in a similar way, you can also use negative indices to access the elements. So when you put a negative sign, the indices are basically counted from the back of the list. Now if I want to access the same word get, but all I know about this word's position is that it's the second last word in the list. I also do not know the length of the list. In this case, I can just say mix of -2. So 2 as in it's the second last element, and the minus signifies that you count from the end of the list and not from the beginning. So I'll run this and extracted get. Now as you probably would have noticed, in case of indices when counted from the front of the list, it starts with 0. On the other hand, when you count the indices from the end of the list, it starts with -1 and not 0. So now we saw how you can access a single element from the front of the list and from the back of the list. Now what if you want to access a range of elements? Say I want to extract the first 3 elements of the list mix. In that case, I could just type mix, again square braces, and within here I'll put colons followed by 3. So ideally there would be a number on either side of the colon, but in this case we are taking from the beginning of the list. So if the digit before the colon is supposed to be 0, you can just leave it blank and automatically it's interpreted as 0. Also, we know that our third element would be at the index position 2. But here we have written index position 3. This is because our last index position is always excluded. So if you give 2 instead of 3, then the only elements that would be extracted would be the ones at 0th and 1st position. Since we want the element at the second position too, we give the ending index as 3. So let's print this, and we received our first 3 elements of the list mix, which are 1, 6 and the word Simplilearn. Now what if we want to extract all the elements from a certain position of the list, say our third index position of the list up till the end of the list? In that case, again we have mix square braces, and we have the same colons as we used previously. But now, since we want our starting index to be 3, we enter 3 and the element at the third index would be included. But now we want to extract all elements till the end of the list. So you can just leave the last position blank. When you do this, it's automatically interpreted that you're taking all the elements up till the end of the list. Let's run this. And we received get and certified. Now I want to extract the words Simplilearn and get from our list mix. In this case, what would be the parameters within our square braces? So Simplilearn is at the index location 2 and get is at the index location 3. So our starting index would be 2, but as we already mentioned previously, if I put 3 as my ending index, I would not receive the element at the index position 3. Therefore, I'll put my ending index as 4 and run this. And there you go, we received our 2 words Simplilearn and get. Now here's something slightly more fun. So what if I want to extract every second element of my list? In that case, I put 2 double colons followed by 2 because I want every second element of my list, and run this. So as you see here, 1 has been printed, which is followed by 6 in our list mix, but 6 is skipped, and then we have Simplilearn. Again, the word get is skipped, and we have certified. Now there's one more thing you can do with list indices. You can print them in the reverse order. So to do that, just 2 colons and -1. Let's print that. And as you can see, your list mix is printed in the reverse order. So now if we go back to line 16, these 2 double colons are basically positions for your indices. So suppose you want the second element from the first index and not the 0th index, you can write 1 here. And if you want every second element from the first index up to say the 5th index, you can put 5 here, but in our case, we do not have a 5th index. So I'll just leave it at this. You can obviously try that out. In fact, we'll be using a variation of this in our exercise later on. So now that we saw how you can access the various elements of the list, let's look at the various operations you can perform on the list. Suppose you want to create a list of 100 zeros. If we go by the traditional methods, we'd literally have to type in 100 zeros separated by commas within the square braces. And this gets very tedious. So a short way of doing this is type in that one element that you want repeated multiple times within your list, and outside the square braces, follow it up with asterisk, digit, and the number of times you want this element to be repeated. So 0 into 100, and let me print this. And as you see, 100 zeros exist within our list Z. Now we can also create a new list concatenating two or more lists. So let's create a list concatenating the two lists that we previously created, letter and stg. So I'll just print these lists out first. That's our list letter. And that's our list stg. Now we'll create a new list called conc, a short form for concat. And how do you concatenate two lists? Well, you just add an addition sign between them. So letter plus stg. And that's all it takes to join two lists. Let's print out conc. And there you go. So the first four elements in our list conc is from the list letter, and the last four elements is from the list stg. Now there's another operation with list called unpacking. So here you basically give a string as an argument to this function list, and that unpacks each element of the string as a separate element in the list. So I'll show you this with an example. If I name a list var and list of within the brackets, I enter the string, I say hey there, and now I'll print var. So as you can see, every letter of this string hey there has become a single element in the list var. Now let's check out another operation on list using the list num that we created previously. So once again, I'll just print num out so we can recall what was within it. We had the four numbers 1, 2, 3, 4. Now suppose I want the first element of my list num, which is 1, to be in a variable 1, and I want the rest of the elements to be stored in another list called say others. How do I do this? I can just put 1, which is my first variable, a comma, and then star other equal to num. So what happens here is that the star signifies that every element that has not been put into the previous variable or variables is put into this list other. So let's print out the variable 1 and the list other separately and see what they contain. And as expected, 1 contains the value 1, which is the first element of our list num, and the following elements of our list, which are 2, 3, and 4, are stored in the list other. Let's now look at a few methods specific to list. So for the following few examples, we'll be using the list that we created previously called num. I'll print the list out first. So num has the elements 1, 2, 3, and 4. Now the first method that we'll be using is the append method. And the syntax for that is the list name, which is num dot append, followed by brackets. And within these brackets, you basically insert the element that you want to add to the end of your list. So suppose I want my list to be 1, 2, 3, 4, 6. All I do is enter 6 here, and that should ideally add 6 to the end of your list num. So now let's print out num. And there you go. So previously our list contained the numbers 1, 2, 3, 4, and after we executed the num.append method, 6 was added to the end. Now what if we do not want to add a single element to the end of the list but an entire other list? So in this case, we can use the method extend. The syntax for this is num.extend, and within the brackets, you'll enter the name of the list you want to add to your previous list. So here I want to add the list stg that we created previously to the end of my list num. Now before I execute this command, let me just print out stg so we know what's in there. So within stg I have get certified get ahead. I'll just delete this cell and now I'll run the command. So let's print out num. And as you see, num previously had 1, 2, 3, 4, 6 from here. And then we added get certified get ahead to the end of this list num. Now these kind of additions only take place at the end of the list. What if we want to insert an element somewhere in between the list? For this, we use the method insert. And the syntax is your list name num.insert, and within brackets, you first enter the position or the index at which you want to enter the new element. So I want to insert the string Simplilearn just before get. So this is my 5th position. So my first parameter here would be 5, followed by the element I want to enter, which is a string Simplilearn. So I'll type it within quotes. And let me run that. Let's now see what num looks like. And as you see here, we have 1, 2, 3, 4, 6. And then we have the new element that we just inserted, Simplilearn, followed by the elements which were previously in our stg list alone. Now there's another method you might come across regularly, which is the remove method. So this method, as the name suggests, removes an element. It basically removes the first occurrence of that particular element. So the syntax for this is num.remove. And within the brackets, you enter the element that you want to remove. So I'll remove the element Simplilearn and run. Let's now see what num holds. So as you can see, Simplilearn has been removed. Now if there were 2 occurrences of Simplilearn, one here and maybe one after ahead, only this word would be removed and not the one later on, because it removes only the first occurrence of that particular word or that particular element. Okay, so now let's create a new list, say var1, and we'll just insert a few letters in here. Now imagine you receive a list like this where there are few elements but in a jumbled order. You want to sort out this list. One simple method, sort, is all you need to do. var.sortOf, run it. And now let's print out what var1 holds. So all your elements in var1 are now sorted. Python also provides a few built-in functions that can be used with lists. So we'll have a look at the most basic ones. So before we begin, let's create a list, x, and I'll fill my list with just integers. So that's my list, and we'll use this list throughout all our built-in functions. Now the most basic built-in function and the most commonly used is len. What len does is it tells you the length of your list. So len of x, and the length is 6. Our next built-in function that we'll try out is min. Min gives you basically the minimum of all the elements that's present in your list. So min of x, and the minimum element in our list is 4. Similarly, we also have max, which gives you the maximum of the elements present in the list, max of x, which is 90. Now we also have a function sum, which basically gives you the sum of all the elements present in your list. So sum of x, and that's 189. Now in Python, we do not have a function which gives you the average, but it's very simple to calculate this. We do so using the sum function. So you find the sum and then you divide that by the length of the list. So sum of x by len of x would give you the average of x. So with that, we covered the basic built-in functions for Python lists. We also covered the methods in lists, a few operations in lists. we saw how we can access the various elements in list. Today we look into what tuples in Python are. So let's begin. What are tuples? A tuple is a collection of immutable heterogeneous Python objects. So if you have gone through our previous video on lists, you would have noticed that even list is a collection of heterogeneous Python objects. The only difference between tuple and list here. So the extra term that comes in case of tuples are that they're immutable. So over here, we have a tuple that's x, and within x, we'll store various elements, 1, 89, a single letter A, which is a string, also a word, which is again a string in Python, hey, O, and B. So as you can see, this tuple here may not be necessarily completely filled with integers, completely filled with floats or strings. It can be a mixture of all of these data elements. So that is one advantage we have when it comes to tuples and lists as compared to arrays. Because with arrays, you can have only one data type elements within it. Now we look at indices. So every element in a tuple takes up a position. And this position is what we refer to as an index. In plural, that's indices. So tuples positioning, or the indices for tuples and list strings also in case of Python and most other programming languages, starts with 0. So your element 1 is at the 0th position, your element 89 is at the 1st position, and so on, where B is at the 5th position. So in a way you can say that the length of your tuple x is 6, but then the last index of your tuple x is 5 because it starts from 0 onwards. So now that we have a basic idea of what a tuple is, let's begin with creating tuples. Creating tuples. Now the first thing that we are going to do is we'll create an empty tuple. So say my empty tuple's name is EMP. All you have to do to create an empty tuple is give these curved brackets with no elements inside. So this is a lot like lists, but in case of lists, we had square brackets. In this case, we have curved brackets. So that's the only difference. Now, if I print the type of EMP, you'll see it's of class tuple. I can also print out just EMP. And since EMP is an empty tuple, there's no element within it. But then, of course, the brackets are still printed because that's a list, because that is the basic characteristic of a tuple. So even if it's empty, these brackets would still be existing. So we saw how to create empty tuples, but how often do we actually use empty tuples? So let's put some elements into our tuple. So let's start with creating a tuple with just one element. So say my tuple's name is city, and I'll have one element, Pune. If you're creating a tuple with one element, if you're not putting the brackets, it's completely valid as long as you have a comma after that particular element. So with this kind of a syntax, you can create a tuple. So I'll create a tuple, say city, and I'll just have one element within this, which is Pune. Now, if you're not putting this element within these curved brackets, that's very characteristic to tuples, it's completely okay while creating a tuple as long as you have a comma after your element. So although you have no element after this comma, that one single comma is important. So let me run this and just type of city. As you see, city has been stored as a tuple. Now, in the most standard way of creating tuples, you'll say city, and within brackets, you'll pass your element. Also print out city after that. And the same syntax can be used, and then you can also combine these both, although that's completely unnecessary effort, but it's possible. It does not result in an error. So you have your brackets and the comma. Works just fine. Now I want to add more elements to city because clearly Pune is not the only city we know. So Pune, Bangalore, these are some of the cities in India if you're from another country and wondering. So after this demo, you not only know tuples, you also know a few cities in another country. So I have 4 elements in this tuple, and this is how you create it. All the elements separated by commas and within brackets, print out city. Now I can do the same thing without the brackets too. Just the commas indicate that this is a tuple. Now those are the various ways you can create a tuple. Of course, all these ways do not come handy. Usually you use this method to create a tuple with n number of elements. And when it comes to one element, you usually go for this. Just put one element within the brackets. This is also used sometimes. Now another thing we saw while learning what a tuple is, or looking at the definition of a tuple, is the word immutable. So we said lists are mutable, which means that they can be changed, and tuples are immutable as in they cannot be changed. So here we'll see a small example as to what the difference between tuples and lists are when it comes to the execution of these both. So say I have a list 1, and that has elements
1, 2, 3, 4, and then I have a tuple, say tuple 1, which has the same elements 1, 2, 3, and 4. Now with list 1, I'll use this method that you probably have encountered before called append. So I say list dot append of 5. So what this function does is it adds 5 at the end of this list, which is list 1. Now we'll print out list 1. Run this code, and as you can see here, 5 has been concatenated to our list 1. Now let's try the very same thing in tuple. So tuple 1 dot append 5, and I'll run this, and see, you get an error here. So the tuple object has no attribute append. In fact, it has none of the functions which you usually use with lists, because these functions aim at changing the original list and not giving back a new list. In tuples case, you cannot change the original list. Once your tuple is set, that is how it's gonna be as long as it exists. So that is the main difference between lists and tuples. List is mutable, whereas tuple is immutable. And other than that, of course, you must have noticed the syntactic difference, which is lists are with square brackets and tuples may or may not use parentheses or the curved brackets. So every time you print out a tuple or you view a tuple, it's always got those brackets. But as you saw while creating a tuple, sometimes a comma is enough. So now let's access these elements in a tuple. If you want to print out the entire tuple, we already saw, just put it in a print statement, put the tuple list, put the tuple name in a print statement, and you'll have your tuple printed. Now, if you want to access some particular element of the tuple, say I want to take out Bangalore. So in that case, we use the indices as we saw earlier. Indices start from 0 and Bangalore is therefore at the first position. So I have to just say city and within square brackets 1. So this particular line or this syntax is exactly the same as you would use for a list or string. Just run that, and here we go. We have Bangalore. Now we can also extract elements from the end of the string, just like we did in case of list. So if I do not know the length of the string, now suppose I want to access the very last element of my tuple, but I have no clue as to what the length of my tuple is. In that case, what index do I use? Well, I can just go with -1. Now every time you give this minus sign, it starts accessing elements from the end of the tuple. So -1 means the first element from the end of the tuple, which is Mumbai. And that's what we got as our output. Now, although lists are immutable, there are a number of operations you can still perform on them. For example, the very first thing we look at is concatenation. So I already have my tuple city. We'll just print it out once again here to see what it consists of. Now we'll create another tuple, say num, and this will have the elements 1, 2, 3, 4. Now sure, I can't modify tuples, but I can definitely concatenate these two. So how do you do that? Extremely simple, city plus num. The plus sign works perfectly fine for concatenation. So I will print this out. And we have an error here. That is because we have not compiled our num list first. So our num list is not existing right now. I ran my line 19. Now I can run the next line. We have one complete list which has all the elements of city followed by the elements of num. Now you can also nest tuples. That is, you can have one tuple within another tuple. So far we have a tuple city and num. Now I will create another tuple. So first, now we already have our tuple city and num. What I'll do is I'll create a new list, say nest. So this is going to be a list. So we have our brackets here. So what I'm going to do is I'm going to create a tuple within another tuple. So we have a new tuple, I'll call it nest. And since this is a tuple, the basic syntax, I'll have the brackets. Now what will be the elements within this? The elements would be my other two tuples, which are city and num. So I put in both my elements here, and let's see what nest contains now. So nest is a tuple which itself contains of other tuples which are city and num. So that is how you nest tuples. Extremely simple, isn't it? Now here's something else. Say I want to create a tuple rep which has an element Python, but that element is repeated 5 times. So what you would generally go for is type out Python 5 times. But thank God for Python, there's a much simpler way of doing this. Type in Python once and multiply this 5 times. Let's print out rep now. And as you see here, Python exists within this tuple 5 times. 1, 2, 3, 4, 5. Now maybe this is not how you want to create your tuple. You want your tuple to just have that one element Python initially. But later on, while printing, you decide, you know what, I want Python to be printed 10 times within this tuple. Not a problem.
put your tuple name here and then go for it into 10. And as you see here, the tuple has now 10 elements within it. So guys, remember, when you're putting the statement here, it's not actually modifying the tuple, it's just printing it this way. So if I say rep once again and I run this tuple just has one element. So next we look at slicing in tuples. So we created our tuple num previously. I'll just print that out once again. So it has the elements 1, 2, 3, 4. Now suppose I want all the elements from 2 up till the end of this tuple to be printed. In that case, what I do is I go for slicing, where I will mention my beginning and my end index. So my beginning index starting from 2 is of course 1. And my end index is basically the position 4 is at, or till the end of this tuple. Now when I want all the elements up till the end, I do not need to mention my end index. It's by default taken so. So if I just say num of 1 up till blank, run this, your tuple sliced, it gives out the elements at the first, second and third position. Considering 0th is our first position, of course. Now you can also print this num tuple in reverse using these indices. So you say num, I leave my start and end index empty, give 2 colons, and then in the end I have -1. So when you put this -1 here, so it basically prints out the reverse of your tuple. Let's check that out. And as you see, your last element is now your first element, and your first element is now your last element. If you have any doubt regarding how slicing works, please check out our video on Python lists. Over there we have a detailed description on how slicing is, and there will be no confusion since in case of slicing at least, tuples and lists are exactly similar. So let's look at this string that I have here, Simplilearn. Now I want every letter of the string Simplilearn to be an element of a tuple. How do I do this? Well, pass the string as a tuple. So write tuple of, and within this you have your string, which is again within quotes, right? We'll run this command. And as you see here, every character is now a separate element in a tuple. So this procedure is called unpacking. Now I'll just print out my num tuple once again so we can see what's in it. Okay, so I want to put these elements which are inside a tuple into various variables. Now in this case, I know that my tuple has 4 elements. So I can have 4 variables, A, B, C, D, and I'll put this equal to num. Run this, and then I'll print out A, B, C, and D. So every element of the tuple has gone into one of these variables. The first element went into A, second element into B, and so on. Now what if we had no clue how many elements are there in num? In that case, I could say A, I want my first element to go into my first variable A no matter what. And I want my last element to go into this variable C no matter what. Now all the elements in between, I'm not very concerned about where they go. So in that case, I can have another variable B, but this variable will be a list. So the star indicates that B is a list, and then this is equal to num. We print out A, B, and C. So you see what happens here is my first element went into A and my second element went into C because these were clearly indicated. But every other element in between went into my list B. So that is how unpacking works. So since tuples are immutable, it's impossible to delete the elements within it. But that does not mean you cannot delete the tuple entirely. So that is what the del keyword does. We'll implement this. So I'll create a tuple, tuple 1, and put some elements into it, 1, 2, 3, 4. Now I'll use the del keyword. Now I'll just print out this tuple. So we know it exists and what all elements are within it. So great, our tuple is created. It has the elements 1, 2, 3, 4 within it. Now I'll use the del keyword to delete this tuple. So I say del space followed by your tuple name. Run this command. Now let's try printing tuple 1 once again. Of course, since we did it all right, hopefully, this tuple should not exist and this should result in an error. And it is resulting in an error. It says tuple 1 is not defined. So you can completely delete the tuple if not delete elements within the tuple. So as I mentioned previously, most of the methods that you have with lists does not work with tuples because these methods change the original list itself. But there are a few built-in functions which do work with tuples. They return values or new lists and they do not have any impact on the original tuple, so it works just fine. We'll explore some of these built-in functions. I'll continue using the tuple I created before, that's num. So I'll create a new tuple, num1, which has the elements
3, 5, say 4 2s, 6, 5, 8. And now we'll perform our built-in function operations on this num1 tuple. So the first one that we look at is counting the number of occurrences of a particular element. So that is the count function. So you give your tuple name dot count of and the element whose count you wanna know. So I want to know the number of 2s in my tuple num1. Run that, and as you see there are 4 2s. Now you can also find the sum of all the elements within your tuple. So that is sum of num1. You just have your function sum, pass num1 to it. Now this sum function works for tuples, lists, everything. It's not a function particularly for tuples as such. So the sum of all the elements within a tuple is 35. And in a similar way, you also have the len function, which is in fact even used for strings. So len of num1 gives the number of elements within num1, which is 9. We have 9 elements. But remember, our last index is 8, not 9. Our element is 8 too, coincidentally. Now we have the max function for finding out the maximum number in your tuple. So say max of num1, which is 8. And we also have a function for checking the minimum of the numbers within our tuple, which is 2 in this particular case. So now list and tuple are very similar in the sense of what they hold. So what if I have a list, say LST, which holds the elements 1, 2, 3, 4, and I want to convert this list to a tuple. So we'll see how that is done. First, I stored my list 1, 2, 3, 4. So I'll just check the type of the variable LST, ensure that it's a list, which it is. Now we can convert this to a tuple. So to convert this to a tuple, enter your variable name and then pass your list name within these braces for the method tuple. Run this code and now let's print out TPL, and as you see our list LST has been converted to a tuple. We can also check its type. So yeah, our conversion has worked out fine. Now this kind of a situation often arises when you put certain elements into a list. So you create a list that you desire and then you realize that you don't want this to be changed at all throughout the program. So then you can convert the list to a tuple. You cannot convert a tuple to a list though. So we previously saw how we can have nested tuples, that is tuples within tuples. Now we can also have tuples within lists. So we'll check that out now. Say I have a list LST and within this list I'll define my tuples. So 2 of the elements of my list LST will be separate tuples. I have a tuple 1, 2, 3 and I'll have another tuple as the second element of my list as 4, 5, 6. So I'll run this code, print out LST. So LST is created just fine. It's a list which holds 2 tuples. Now tuples are immutable, but lists are mutable. So we can add as many tuples as we want inside this list. So we can make modifications to the list. So I could say list.append and to this I'll pass another list which has 3 elements. Say tuple inside list. Run this code. Now if I print out list, you'll see that the third tuple has also been added to the list. Now we can also remove tuples from the list. Just use the remove function. So lst.remove and within this I'll pass the list that I want removed, which is my first list in this case. So run that code and print out the value of lst to check what's in it right now. So our first list has been removed. Now we just saw how you can nest tuples within lists. Now we'll check out how we can nest lists within tuples. So I'll create a tuple TPL and within this tuple I'll have 2 elements, each of the elements being a list. So they have A, B, C in my first list and D, E, F in my second list. Run this and print out the value of tuple before we proceed. Yeah, so that's our tuple with 2 elements, each element a list. Now we cannot modify tuples. So initially when we had tuples within lists, we could add more tuples to that particular list. But now we have lists within tuples and we cannot add more elements to this already defined tuple. But what we can do is we can modify the list within the tuples. So I can add elements to the first element and the second element of my object tuple. So I'll try that out. If I say tuple 0.append. So when I say tuple 0, it's accessing the first element of the tuple. And the first element of a tuple is a list. So to this, I can use the append function. And I'll append an element z. Run this code and then check out the elements within tuple.
And in the similar manner, we can also remove elements from the list within this tuple. So I can say TPL of 0 dot remove Z and then print out TPL. So you see Z has been removed here. Now just for the sake of it, let's see what happens when we try to add another list to this tuple. So I say TPL dot append and pass a list X, Y, Z and then print out TPL. So we get an error because this time our object was a tuple, not a list, and tuples cannot be changed. So with that, we saw the many concepts that is used with tuple along with what tuple is. And today we'll cover the concepts in strings. So before we begin, let's look at what exactly a string is. Now, just like you have integers, floats, bytes, and so on, string is a data type. Now, what does this data type hold? It holds a collection of characters. And when I say characters, that could include letters, numbers, and even special characters such as space, period, dollar, @ symbol, and so on. Now, the syntax for storing a string is much like that for any other variable. You have the variable name followed by an equal to sign and then the value of your variable. But in case of strings, it's important that you always put your values within double or even single quotes. So that is string at the very basic. Let's start our demos, and I'm sure through the demos you'll have a better understanding of how to use string and where to use strings. So let's start with the most basic demo where we'll store a string within a variable and then print the value of this variable. So my variable name is stg, within which I'll store the string Simplilearn. So I'll enter the string within double quotes as you can see here, or I could also do this within single quotes like that. And then in the very next line, I'll print the value of stg. Let's run the code. And as you can see here, the value is printed. Now let me store a different value in stg. I want to store the string Tim's birthday. So I insert this within single quotes, Tim's birthday. Let me run the program. But here you see there's an error. It says syntax error, which is an invalid syntax. So if you come back to your string, you'll notice this is because our string itself has a single quote. So we tried to enclose our entire string within single quotes. But what happened is when the Python compiler encountered the single quote within the string, it assumed this to be the end of the string. So stg became equal to Tim and the rest of the word, that is the S, space and birthday, was just there for no reason, and this resulted in the syntax error. So in a case like this, what you do, if your string contains within it a single quote, enclose the string in double quotes like this. And now if you run your program, as you see, Tim's birthday is printed. Now in a similar manner, if my string has within it double quotes, then I'll store the entire string within single quotes. So let's say my string is Tim said, I am busy today. So since my string has double quotes within it, I'll store it in single quotes. And our string is printed right. Now suppose Tim said, I'm busy today, that is I apostrophe M. So now in this case, our string has both single and double quote. So here what we can do is, we can simply escape this single quote here. So for that you use the slash. And when you insert the slash, what it does is the character that just follows the slash is taken as simply a part of the string without any special meaning. So the Python compiler in this case sees this apostrophe and ignores it for any special meaning. So if I print the string now, both my double and single quotes are printed correctly. Let's try something else out. What if my string needs to be of multiple lines? So let's say my string is hey there. And on the next line, I'm typing welcome to Simplilearn. So if I try to do this in the similar manner that we did for the other strings, that is insert the entire string within double or single quotes, As you see here, that does not work. Welcome to Simplilearn is just now taken as a part of the string. Even if I try single quotes, let's try that out. Still no difference. Still our second line of the string is not considered a part of the entire string. So here what you do is you start and you begin your string with 3 quotes. Now these 3 quotes can be either 3 single or 3 double quotes. So if I'm going with single quotes, I'll have 3 single quotes here and 3 single quotes at the end. So in this manner, you can have a string with multiple lines. Let's print this out too. So we have our multiple line string. So now that we saw the various ways in which you can store strings in variables, let's try out something new. Now the first thing we look at right now is the length function. So the length function is something that you'll come across very often when you start programming. What the length function does is it returns the length of your string. So if my string is, say, Simplilearn, and I want to print the length of stg variable, you can just say print len of, and within the brackets, enter your variable name. Print that. So Simplilearn is of length 11. What that means is that it has 11 characters within it. So even if you have a space in between, even that will be counted as a character, because as I told you, a string is a collection of characters and this character could be anything. We print that out. As you see, 12 is the new length of your string. Now, just like in case of arrays, even each character of your string can be extracted separately. And again, just like in arrays, this is done through the indices. So if I want the 5th character of my string to be printed, I can just say print stg, and just as the syntax is an array, the exact same way, you have your square brackets within which you have your index number mentioned, and print that. So our 5th character in the string stg is I. Now remember, the indices in string 2 start from 0. Capital S is at the 0th index, I is at the first, M is at the second index, and so on. Now if I want to access every character of my string one by one, I can do this using a for loop, because as we learned previously, for loop is used to iterate over a sequence, and a string 2 is a sequence. It's a sequence of characters. So my counter variable is I for I in stg, and print I. So I will iterate through the string, start from capital S and go all the way up till N. And every time you're printing the value of I, that is the character that it's holding at that particular point of time. So when I print it, as you see, every character is printed in a new line. Now if you want all the characters to be printed in the same line, of course you can have your end attribute here, print that. And so the string is printed in the same line, but again it was printed one by one. That is one character at a time. Now with strings, there's a concept called slicing. So slicing is extracting a part of the string. Right now we saw how you can extract exactly one character from a string. Now what if you want to extract, say, the first 5 characters of your string stg? So this is where slicing comes in, and it's a very simple concept. All you have to do is you give your variable name, your string variable name, and within your square braces, as previously you mentioned that one index, this time you'll mention the 2 indexes and a colon in between. So I want my first 5 characters, so I'll start from 0th index and go up till 5 with a colon in between them. So let's print this, and as you see, I got my first 5 characters of the string stg. Now when you're starting from the beginning of your string, you can avoid giving this first index. What I mean is you can just put in your variable name, and instead of having 0 to 5 here, you can just ignore the 0. So Python assumes that your first index is 0 when you just skip it. When we print this, you see both the results are the same. Now let's say I want to extract all the characters from the 5th index up to the end of the string. In this case, I can just say print of stg, and within the square braces, Since we want all the characters starting from the 5th index, our first index would be 5, colon, and since we want every character till the end of the string to be extracted, we can leave the second index space empty. So when you do this, the interpreter assumes that your end index is basically till the end of the string. So let's run this. And as you see here, all elements from the 5th index up till the end of the string has been extracted. Now suppose you want to extract some elements from in between the string. So in this case, it is compulsory that you must enter both your beginning and your end index. So say print stg of, and suppose I want to extract all characters from the 2nd index up till the 4th index. So in this case, my first index would be 2 because I want to start extracting from my 2nd index position, and my end index would be 5 and not 4. So the reason here is that the element at the end index position is always excluded. So if you put 5 here as your end index, then all the characters till the 4th index position would be extracted. And if I enter 4 here, then all the elements till the 3rd index position would be extracted. Let me print this too. So our last output, it's the elements in the 2nd, 3rd and the 4th index position. Now Python has a number of inbuilt methods which makes it easy and efficient to deal with the string data type. Now there are a large number of such methods, and of course we don't have the time to go through all of them. So we'll go through some of the most commonly used ones. Let's start by creating a string. So my string is welcome to Simplilearn. Now the first method we look at is to print our entire string in uppercase. So print your variable name, period, upper. So all the inbuilt methods, this is how they are called. You have your variable name, your string variable name, followed by a period, and then your method name and the parenthesis. So some of the methods require some parameters to be passed within it, and some of the methods do not. So the upper method prints a string in uppercase. Now you must remember that these methods do not change the value of the original string. They just return a new string. So stg.upper, let's print that. And our entire string is printed in uppercase. In the similar manner, we have a method to print our string in lowercase too. There you go. That's just dot lower. So here our entire string is in lowercase. Entire string is printed in uppercase. Now initially we saw that if you want to extract a particular character at certain location, you can just give the location index and the character is extracted. Now what if you want to find out the index of a particular character? In that case, we have a method called find. Find returns the index of the first occurrence of the character. So the syntax is very similar. Your variable name dot find. Now for this method, you need a parameter passed, and the parameter of course is the character whose index we want to find out. So suppose I want to find the index of the character capital S. So a character capital S is at the 11th position with the positioning or the index starting from 0 onwards. Now there's another function which is exactly similar to find, which is the index function. And the index function too does the same thing. It returns the index of the character that you pass within the brackets. So if I say S here, both of them return the index which is 11. Now these methods, they give the index of the first occurrence of this character. Since we only have one capital S, it's obvious it's giving the index of this particular character. Now if I say L, as you can see our string, it has an L here and one here too. So if I give L in these two places, let's run our program. You see the index return is for this L, that is our very first L. Now let's look at another inbuilt method for strings, which is the split function. So what the split function does is it converts your string to a list, and it does this based on a delimiter that we pass as a parameter to the method. So if I say print of stg.split, and within these brackets, I'll pass the parameter. Now, if you look at our string here, it's a sentence or a phrase where each word is separated by a space. So if we want each word to be a separate element of the list, then what's separating these words is the space, and that would be a delimiter here. So within quotes, I pass space. Let's run this. If you notice the last output that we got here, this is a list, and the elements of this list are the words in our string. So if we observe the return value of these methods, you'll notice that the first two return a string. These two, they return an integer or the index number. And the last one that we executed, that is a split method, that returns a list. Now often this is a very useful method. So what you do is you store the return value of this method in a variable. Say x equal to stg.splitoff. And then you can utilize this list in doing multiple functions. In this case, I have nothing to do with x, so I'm just printing it. But when you start coding, you'll find that the split function comes very handy. Now, what if you want to replace a certain part of your string? For this, we have the replace method. So you have stg.replace. Now, within the brackets, you have two parameters to pass. The first parameter is that part of the string that is to be replaced. So suppose I want to replace the word Simplilearn in my string. So that will be my first parameter. And my second parameter is what I want to replace this particular part of the string by. So I want my string to say welcome to Python tutorial instead of welcome to Simplilearn. So I'll replace Simplilearn with Python tutorial. Let me print that out. So this method too will return a string. It will not change our original string. None of these methods do that. Yeah, so as you can see here, it's returned welcome to Python tutorial instead of welcome to Simplilearn. Now Python has another data type called tuple. If you would have gone through our previous video on variables, we introduced tuples there. So tuples are a lot like lists except they're immutable. Now our next method is the rPartition method. So our rPartition method is a lot like the split method, but here it creates a tuple. So it returns a tuple, and this tuple always has 3 elements. Let's start writing this method and then I'll explain to you how it works. So stg.rPartition, and within the brackets, you enter that one part of the string based on which you'll create this partition. Now if I pass within my brackets the string space to space, what this will do is my tuple always has to have 3 elements. So if you look at the original string, this part here, that is the space to space, forms the middle element of my tuple. That is the second element of my tuple. Everything before this part, that is the entire welcome word, will become the first element of my tuple, and everything after this part, which is the word Simplilearn, becomes the third element of my tuple. So I'll print this out and you can see how it looks like. So as you see here, our partition returned a tuple, and split here, this returned a list. So our tuple's second element is what we passed within our brackets, and the other 2 elements are everything before and after it respectively. So these are some of the basic and commonly used inbuilt methods with strings in Python. Now let's move on to concatenating strings. So string concatenations are pretty simple with Python. Say you have 2 strings, stg1 which holds good and stg2 which holds morning. Now using these 2 strings, you want to create a third string which holds good morning. So what I can do is I'll just have a variable stg, and that will be equal to stg1 plus, now I need a space between these 2 words, so plus space, which will be inserted within quotes because at the end it's all a string, again the plus, and our next variable which is stg2. and then I'll print stg out. So you can see here stg printed out good morning, good from stg1 and morning from stg2. Now if you have no operations to be done with the concatenation of two strings, that is you do not need this third variable at all, you can directly put this concatenation part within our print statement like that. It's exactly the same. Now things get slightly more complicated when you have a number of strings to add. Now let's say I have 3 strings. So stg1 which holds hey, stg2 which holds there, and stg3 which holds all. Now what I want my new string to have is hey there, comma, all, followed by an exclamation. Now this could be done in the previous way. We can have the plus symbol to add the various strings, including the space, the comma and everything inserted within quotes. But that gets a little messy when you have a number of variables to add and other extra strings to be added in between. So here is where we use the format inbuilt function for strings. So what we're going to do here, so we'll have a 4th variable stg. Now I'll just write down the format first and then I'll explain it to you. Okay, so how this works is first you have to give a format for your string. So that is inserted within double quotes. Now these braces here, the curly braces, they are called placeholders. Wherever the curly braces are placed, that is exactly where the respective string from your format function will go to. That is, our first placeholder will be replaced by the value of stg1. Our second placeholder will be replaced by the value of stg2. And our third placeholder here would be replaced by the value of stg3. And everything that is in between is printed exactly the same. So here I have inserted a space. This space will be printed exactly as it is in the same location that I have given. The comma and the space here too will be printed exactly the same way, and the exclamation would be printed the same too. So at first you give a string within which you have placeholders for the strings that already exist, followed by dot and then the format function to which you pass the variables that take the place of these placeholders. So now let's print out stg. And as you see, stg holds exactly what we wanted. Hey, there, comma, space, all, exclamation.
Dictionaries and sets in Python. So first let's have a look at what a dictionary is. By definition, a dictionary is an unordered collection of data stored as a pair of key and value. So dictionary basically is another data type, just like your lists and your tuples, but here they are not exactly a sequence because the order in which you store the elements are not very important in the case of a dictionary. Also, every element is a pair of values. So there's the key and there's the value. The key is basically like your index in a list or a tuple, but here in dictionaries, keys can be not just integers but also strings. So that is the main difference between dictionaries and other sequences such as lists and tuples. Now let's have a look at exactly how this works, but first we look at its syntax. So you have your variable name or the dictionary name equal to, and within curly braces you have your data stored. So each data here is a key value pair, as I mentioned earlier. So our first data would be key 1, and then you have the double colons. So the double colon basically separates the key and the value. So value 1 is assigned to key 1, value 2 is assigned to key 2, and so on. And every pair of value and key is separated by a comma. So now we'll move to Jupyter Notebook to have a look at how dictionaries work. Let's start with creating dictionaries. So first we'll make an empty dictionary. So how is this done? You have your variable name, which will be your dictionary name basically. So I'm taking my variable name as D1. And as we previously saw, dictionary elements are enclosed within curly braces. So you can just put down curly braces here. And since we are creating an empty dictionary, have no element inside. And that is pretty much it. That's how you create an empty dictionary. I'll just print this out, print D1. Also print out its type.
So as you see here guys, this is an empty dictionary. The class is dict, the short for dictionary of course. Now let's create a dictionary with elements. So my dictionary name this time would be D2, again curly braces, and now within these curly braces we'll enter our elements. So my first element key is say 1, and the value assigned to this key would be welcome. My second element key is 2, value assigned to this would be 2, third key and third value, and finally the fourth key and its corresponding fourth value. Now let me print D2 out. So we created our second dictionary successfully. Now here these integers are the keys and these strings are the values. Now I mentioned previously too that in case of dictionaries the keys are like indices, but here these indices / keys do not need to be integers, they can also be strings. So next up, let's create a dictionary with the keys being strings too. So my next dictionary's name is D3, and now within curly braces enter your elements again. So my first element key would be name, the double colon, and then enter the name. Although name is a key, since it's still a string, we need to enter them in double quotes. Do not forget that. The next key would be age, which is 22, and finally the profession, and Sam here is a student. So that's our dictionary D3. I'll print this out too. So we created an empty dictionary. We created a dictionary with its indices as just integers. Now there's another method of creating dictionaries, which is using the dict method. So let's check this out. My dictionary name is D4 and I'll be using the dictionary method. Now I'll pass the dictionary elements within the dictionary method, again using curly braces. Now this kind of creation of a dictionary is not needed. The above methods are so much more simpler, and that's what we usually go with. But just for the sake of your knowledge, we'll check this out too. So again, I'll just put down these elements here, copy paste them inside these curly braces, and then print out D4. So as you see, it's just the same thing. We get the exact same result using this dictionary method too. Now when you're using the dictionary method, make sure that you have not named any variable as dict previously. In that case, if you did name any variable, when you put down this method, it'll give you an error saying method is not callable. So if you did by mistake create a variable or a method saying dict, make sure you delete it before you run this line. Now another syntax for using the method and creating a dictionary. Let's look at that. So now my dictionary is D5 using that method again. So this time we'll pass every key and its corresponding value as a pair within round brackets. So we are basically passing these pairs as elements of a list, or by syntax you can say as tuples within a list. So you have 1 is welcome. Remember to put the quotes always for strings. 2. So as you noticed, in this case, we are not using the double colons. What we are doing is, to the method, we are passing a list of pairs of the elements, and each of these pairs are enclosed within these round brackets here. Now print out D5. So there's an error here. The error is of course that we have double colons in space of comma. So I'll correct that and run the code again. And there you go. So D5 is also created. It's exactly the same as D2 or D4. It's just a different method of creating it. Now the final type of dictionary that we'll be creating are nested dictionaries. So you can have a dictionary within a dictionary, just like you can have a list within a list or a tuple within a tuple. So let's see how this is done and why this would be done too. So if you look at D3 here, we had this key name which had one value Sam. But now what if our key name has two values, that's the first name and the second name. Now in this case, name can be the key to another dictionary, and within this dictionary we can store the first and the second name, again with their corresponding keys. So we look at that. I have my dictionary D6 here, and we'll use a simple method of creating a dictionary. I'll just copy paste this line where I'm storing Sam's details and edit this out. So name is the key to a dictionary, and within this dictionary I'll have two keys. First, which is basically your first name, that is Sam, and last That's Sam's last name, which is Crew, and that's how you create a nested dictionary. Print D6 out. So it's done. As you can see here, name is the key for our dictionary, which is inside our main dictionary. And inside this nested dictionary too, we have two keys, first and last, each of them with values. So now that we learned how to create dictionaries, let's see how you can add more elements to them. So I'll create an empty dictionary first, say D, and now I want to add my first element to this dictionary. So I can say D of 0, just like how you do in case of lists, equal to, and the value. Then I'll print out D. So that's how it's done. 0 becomes your key and welcome is the value. Now I can also add a tuple to this dictionary. So if I want my second element or the value of key 1 to be a tuple, I go like D of 1 equal to, and then just how you would define a tuple, go ahead and create that. And then I'll print out D. So now we have two elements in our dictionary D. The first is the string welcome, followed by a tuple with 3 elements. So I just missed out a comma here and forgot to close my strings. So yeah, our dictionary has 2 elements. The first one is a string welcome, and the second element is a tuple with 3 elements within it, which are how, are, and the string u. So far we use numbers as indices for adding elements, which made the number the key. Now, as we saw previously, dictionaries can also have keys which are strings. So how do you assign these? Well, the same way, but now instead of number, put down a string. And I say D of name equal to Sam, right? And then print out D. So our first 2 elements have the key 0 and 1 integers. Our last element is having the key as name, which is a string, and a value, which is again a string. Now similarly, you can also add dictionary as an element to this already existing dictionary. Now in this particular case, I don't want to add another element. In fact, I want to update the value of a key name. I want the value to be another dictionary, just like we had previously. So I'll again say name, where the index is supposed to be, and then equal to curly braces where I'll create my dictionary. So that'll be the key first, which will have the value Sam, and the key last, which will have the value Crew. Print D out, and there you go. So your value for the key name has been updated now. So we saw how we can add elements or update elements. Now let's have a look at how you can access the elements which are already present in your dictionary. So the syntax we use again here is very similar to that for lists or tuples. Before we move ahead though, I'll just print out D so that we can refresh as to whatever was stored in D. So we have 3 elements here. Key 0 has the value welcome, key 1 with the tuple how are you, and then finally key 3, which is name, which has a dictionary as its value, and the dictionary holds the first and the last name. So now if I want to retrieve the value of the key name, I can just say D of name, and that'll give you the value of the key name. Now if I want the value of just the key first, which is within the key name, I can go ahead with the sort of syntax you'd use for lists and tuples again when they are nested. So D of name, which returns this dictionary here as we saw previously. And now from this dictionary, if I want to extract the value of the key first, then I would just say first within the square brackets. And that is how you retrieve the value within a nested dictionary. Now this is a very simple method. Yet again, we have a method which is specific for retrieving values with dictionaries, which is the get method. So if I say D dot get of, and within the brackets, I pass the key, say 1, run this line here, and that too retrieves the value of the particular key. So we created dictionaries, we inserted elements into it, updated those elements, and even saw how to access these elements. Now let's look at how you can delete the elements. So once again, before we begin, I'll just print out our dictionary on which we'll be operating. So that's D, and these are the elements within D. Now the first method that you can use for deleting elements is the pop method. So I'll say D.pop of, and within the bracket you insert the key whose values you want to delete. So suppose I want to delete welcome, which is at key 0. So I just enter 0 in here, run the code, and the pop method basically deletes the value for the key that's given, and it returns this value. So it's returned welcome. Also, if we check D now, welcome won't exist within it anymore. Now, the other method which is popularly used for deleting elements is pop item. Now, with pop, we specified the element we want to delete. With pop item, we do not specify this element because it's always the last element of the dictionary. So you just say d.pop item, run the code. Again, pop item, just like pop, returns the element while deleting it also. So I'll print out D now. And as you see here, D just has one element left after the two deletions, which is the value of key 1. And that's basically how you delete elements from a dictionary. Now we'll also check out some inbuilt methods or inbuilt functions with dictionaries. Before we move on to that though, we'll put a dictionary back into its previous state. So we'll just run the line where we created our dictionary once more. This line here. Let's check out D now. So our dictionary is back to its original state. And now we can perform the next few operations on them. So there are a number of inbuilt functions used with dictionaries, but here we'll just focus on some of the very important and commonly used ones. So the first one we're going to look at is values. So you say d.values of. Now what this function does, it returns all the values of the dictionary. So it returns just the values, not the keys. Run this. So as you can see here, all the values are returned as a dict values type object. Now there's a slightly different method of creating a dictionary, which is using the from keys function. So what this function does is basically it takes two sequences, one for the keys and one for the value, and then it creates a dictionary using these keys and values. So first I'll create a sequence for my keys. My keys would be A, B, C, D. And then I'll just have one single value here, 1, and I want each of these keys to have the value as 1. So this is where the from keys method comes very handy. Say dict dot from keys, and then you pass on the sequence of keys and the value. Let's run the command. So a dictionary is created here with our keys A, B, C, D. And as I mentioned previously, you can probably notice here the best that dictionaries are unordered. So just because I gave the sequence as A, B, C, D does not mean that this sequence or this order will hold in the dictionary that's created. And now finally, we'll use the clear method to completely remove this dictionary. Now if I try to print D here, it's an empty dictionary. So with that, we come to an end of what dictionaries is. And next we look at sets. So what are sets in Python? By definition, a set is an unordered collection of unique elements. So the terms we must concentrate on here are unordered, just like dictionaries. In sets also, there's no particular order to the elements stored in it. Also unique elements, as in, suppose you have the letter A and you enter this twice while creating the set. Ultimately, when the set is stored or when you print out the set, you'll notice that A only occurs once. So every element of the set is unique. Now set basically brings out the mathematical notion of a set. That means you can easily find out the union of two sets or the intersection of two sets or any such operation that you'd normally do on mathematical sets. Also, sets are iterable and mutable, and they provide a very optimized way of checking if an element is within it or not. Now let's have a look at the syntax of a set. You have the variable name or the set name equal to, and then you use the set method to create the set. You pass to this a list of the elements that you want inside the set. So unlike dictionaries, in sets you don't have key value pairs, it's just the values. Now we'll move back to our Jupyter Notebook to demonstrate sets. So first things first, let's create a set. My set name would be S, and then I'll use the set method, and within this I'll pass 4 elements 1, 2, 3, 4, and that's how I create my set. Very simple, isn't it? I'll just print out my set and also print out its type, so we can confirm that what's stored in S is actually a set. Run the code. So as you see here, we have our set 1, 2, 3, 4 belongs to the class set. Now sets need not have just integers or just strings. It can be mixed, of course. And we look at this while also looking at how you can add elements to a set. So for adding elements, you use the add method. So s.addOf. And then within the brackets, you pass whatever the element is that you want to add. In this particular case, I'm adding A. So I'll run that and then print out S. So yes, A is added to the end of the set, but again, since this is a set, the order does not matter. So now sets are mutable. So I was able to add a new element to the set. Now we have another thing called frozen set. Now frozen sets are just like sets except they are immutable. So here I'll create a frozen set for which we use the function again called frozen set. Pass on the elements here and then I'll print out fs. So the syntax for creating a frozen set is just like that for creating a set. And yeah, we have the elements here. Now I want to add an element to fs. If I say fs add off and pass a here, you'll notice you get an error, and the error says that attribute add is not associated with frozen set. This is simply because add modifies the set and frozen sets do not allow this kind of a modification. Now, as I mentioned before, sets in Python represent the notion of sets in maths. So that means that we can also have operations such as union and intersection on sets. And these are the most common operations that you do perform with sets. So let's have a look at these. So I'll create two sets initially, S1, which will have the elements 1, 3, 7, 2. And then S2 having the elements 3, 2, 8, 9. So these are our two sets. Now first we'll apply the union operation. So you say S1 dot union of, and within the brackets pass S2. Run this. So what union does is it brings all the elements of S1 and S2 together into another set. And of course any kind of repetition is removed because sets have unique elements. So as you can see here, you have 3 in S1 and S2 both, but 3 appears just once in our union set. Now we can also have intersection of S1 and S2. Now we can also subtract a set from another. So S1 dot difference of S2 basically removes all the elements from S1 which are also found in S2. Run this line here and the result is 1 and 7. So we'll go back to our list here and confirm this. Now S1 has 1, 3, 7, 2, but S2 has elements 3 and 2. So when you remove S2 from S1, all you're left with is 1 and 7. If-else statement in Python. So if-else is a decision-making statement and there are various formats of this. So let's begin and one by one we'll look at each of these formats. So the first one and the most primitive form of the if-else statement is the if statement. Here's the syntax for if. So you have the keyword if followed by the condition and then we have the double colons. On the next line you can put in your statements which will be executed if this condition results in true. So all these statements are indented slightly towards the right. This indicates that these statements are within the if block. So how exactly does this if statement work? Let's look at the flowchart to understand this. So at first we have the test expression or the condition. Now if this condition results in true, that means that the statements which are inside the if block, those will be executed. If this condition results in false, then the control of the program will skip to the statements after the if block. And in either case, the program then proceeds to print these statements right after the if block. So we'll better understand this through an example. I'll move on to my Jupyter Notebook where I'll demonstrate a code. Now I'll have a variable a which is equal to the value 20. So I'll write an if statement, the keyword if followed by the condition, and my condition here is if a is greater than 50. So if a is greater than 50, we want to enter the if statement or the if block, and in here I'll print out this is the if body. And if a is not greater than 50, we would skip this entire part and directly move on to the statement which precedes the if block. And here I'll have the statement print this is outside the if block. So I'll run this program now. So in this particular case, the value of a was 20, which is obviously less than 50, which is why we did not enter the if block. We simply skipped the statement after the if block. Now if I make the value of a equal to 60 and then run the program, you see that we have entered the if block. So this print statement here, that is the body. So this print statement which says this is the if body is printed, and then the control moves on to the next statement which is outside the if block, which is this is outside the if block. So both these statements are printed. This is how if works. So the next format for if is the if-else statement. So far we could specify the statements that will be executed if a condition is true. Now in case of if-else, we can specify the statements which will be executed in case the condition is true and a separate set of statements in case the condition is false. So that is the part that comes under else. Now let's look at the syntax here. There's if followed by the condition and then the double colons just as before, under which you have your statements which will be executed, slightly indented to the right. And following the if block, you have the else block. So if your condition results in false, the execution of the program moves on to the else block, and under the else block again you have your statements which will be slightly indented to the right. So here we'll have a look at the flowchart for the if-else statement. If the test expression or the condition results in true, we move on to the body of if, and the statements within this body of if will be executed, after which we'll move on to the statements just below if. If the condition initially is false, then we'll move on to the else block and we'll have a separate set of statements within the else block which will be executed, after which again we'll move back to the statements just below the if. So again we have a demo here to better understand how if-else works, where we'll print out if a number is odd or even. So initially I have a variable I which is equal to 20, and then I'll have the if statement, and then I'll have the if-else statement to check if I is odd or even. So I have I mod 2 equal to 0. So if I mod 2 is equal to 0, that means the number is even because I is completely divisible by 2. So in that case, I'll print out this is the if block and I is an even number. And if I mod 2 is not equal to 0, we need to print out that I is odd. So initially we did not have this capability with just if statement, but when you have the else too, if I mod 2 is not 0, the control goes to the else statement and only the statements which are inside the else block gets printed. So here I have print, this is the else block, and then print I is an odd number. Now let's run our program. So as we know, 20 is an even number, so I mod 2 results in 0. We go inside the if statement and these two statements get printed. This is the if block and I is an even number. Now I'll change the value of I to 23, which is an odd number. So then the statements inside the else block gets printed. Now let's look at the nested if. So nested if is when you have an if statement within an if statement. This kind of a situation often occurs when you have to filter a variable multiple times. So let's look at the syntax for nested if. You have if followed by condition and the double colon just as before. And now within the if statement, indented again to the right, you'll have the second condition. So you'll have if and your second condition, which is condition 2, followed by colons. Now you can have as many levels of nesting as required, but of course the more number of nestings you have, the less optimized the program is. So you should always try to minimize or if possible completely avoid nested ifs. Now we look at a flowchart for nested if. You have your first expression, let's call this expression 1. If this results in true, then the control moves on to the second expression, that is the nested if. Now if this condition results in true, you'll have the execution for the body of if. If this condition results in false, you'll have the execution for the body of else. Now of course this else is not mandatory. You can either have an else statement or completely avoid it altogether. The control, however, after else follows to the statements right after the if block. Now I'll move on to my Jupyter Notebook to show yet another demo for nested if. So here I'll have a number, and first I need to filter this number as to whether it's less than 25 or greater than 25. If this number is greater than 25, then I need to also specify. So here I'll take an integer, and my first filter would be if the integer is less than or greater than 25. If this integer is less than 25, I further need to specify if this number is even or odd. And if the number is greater than 25, I just need to print out that yes, this is greater than 25. So let's begin. I'll have a variable c. And for now, I'll have the value 21 stored in C. Now, if C is less than 25, I'll first check if C is an even number. So if C is less than 25 and then C mod 2 is equal to 0, I'll print out C is an even number less than 25. C is an even number less than 25. Else, that is if C mod 2 is not equal to 0, then I'll print out C is an odd number less than 25. Now if C is not less than 25, that is if C is greater than 25, that would come under the else block, which matches with our parent if statement. So if you notice the indentation here, this else statement which goes with this if statement is indented at the same position. And on the other hand, our parent if statement, which is paired with this else statement here, are indented at 0th or the same location. So now under my parent else statement, I'll just print out C is greater than 25. Let me now run this program, and C is 21. So it gets into this if statement here because it's less than 25. And then C mod 2, which is 21 mod 2, is not equal to 0. So the control moves to this else statement, and C is an odd number less than 25 gets printed. If I had 50 here, run my program again, this if statement would not get executed. Control would transfer to this else statement here, and C is greater than 25 gets printed. Now so far with if and with if else, we had a very binary approach. That is, if this condition results in true, print out the statement A. If this results in false, print out statement B. Now what if we have various other conditions? For example, we have a number A, and we need to check if A is within the range 1 to 10. In which case we need to print out that this variable is within the range 1 to 10. Else, if it's within the range 10 to 20, we need to print that out. Now if it's in the range 20 to 30, we need to print that out. That is, it's in the range 20 to 30. So in this case, we cannot just stick to if-else statement. We need something more. We need something which has more steps. And that is where if-elif-else ladder comes into picture. So here, if we look at the syntax, we have your if condition first, the semicolons followed by your statements, and under this we do not directly have the else statement, but we have another keyword, the elif. So the elif statement lets you provide another condition and not just go with the false of if. So you have elif and then condition 2, under which you have statement. Now you can have any number of elif statements. And finally you'll have your else statement, which will be executed if none of the previous statements have been executed. So we'll have a look at the flowchart to understand basically how the if, elif, else ladder works. You have your first condition, expression 1. If expression 1 results in true, body of if gets executed, and immediately you move on to the statement which is right after the else statement. If your expression 1 results in false, that means any of the preceding elif or else condition could result in true. So the program keeps checking all these conditions. So your next elif condition is checked, which is expression 2. And then if expression 2 results in true, then the body of this elif statement is executed and no further statements are checked in the if, elif, else block. Directly you move on to the statement right after these blocks. If none of the previous elif conditions or the if conditions match, the control moves on to the else statement, and the else statement will definitely get executed. So once the else statement is executed, the control moves to the statements which are right after the if, elif, else block. So that is how the control flows in if, elif, else ladder. We'll have a look at another demo to better understand this. So here I'll have a variable, say var, which stores a single alphabet, which is for now Z. And then I'll have the if, elif, else ladder to check if this variable or if this value stored within the variable is a vowel or a consonant, moreover which specific vowel it is. So first I have if var equal to A, print this is a vowel and print this is the vowel A. Now we have 5 consonants, that's A, E, I, O, U. So we cannot directly go with an else statement here. We need to check the condition for each of these alphabets or these vowels. So now I'll have the elif, var equal to E, print this is the vowel E. Just copy paste this. Elif again, this time for I, then for O, U. And finally, if your variable is not equal to any of these 5 letters, then we just print out that it's a consonant. So that can come in the else part. So if none of these statements on top execute, the control directly comes to else statement and else definitely gets executed. So here we'll print out this is a consonant. Before I run this program, a small correction. It should be double equal to. Single equal to is used for assignment. Okay, now we can run this code and it prints out this is a consonant. So var healthy value Z, which is of course a consonant. I'll put in a vowel now, say O, run the code again and prints out this is a vowel O. So this works perfectly fine.
Loops in Python. So Jake here wants to print his name 10 times. Now there are 2 ways of doing this. One is he can literally give 10 print statements for printing his name.
Or he could use a smarter method and he could have just one print statement and somehow repeat the execution of this one statement. Now this is where loops come in. So a loop is basically an instruction that repeats multiple times as long as some condition is met. So Jake could simply use a loop to execute that one print statement 10 times. Now in Python, we have three main types of loops. There's the while loop, the for loop, and finally the nested loop. Now before we move into these loops, let's look at the flow of a loop. So the dot at the top represents the start of the program. Now all the statements of the program are executed one by one until a condition for the loop is encountered. Now if this condition results in true, the statements within the loop are executed and once again the condition is checked. Now this loop continues as long as the condition is satisfied. The minute the condition fails, the program's control exits out of the loop and all the statements following it are executed. So now that we got a basic idea of what loops are and how they run, let's look into our three basic loops. The first is the while loop. So the while loop is used to repeat a section of code an unknown number of times until a specific condition is met. So suppose Jake did not want his name to be printed exactly 10 times, but until the end of the page. In this case, you can use while loop and the condition would be print until end of page is reached. So what is the syntax of a while loop? You have the keyword while followed by the expression or the condition that is to be met and then colons. And following the colons on the very next line, you can start the statements which will exist within your while block indented slightly to the right. Now let's look at a short demo to better understand how while loop works. So I'll move into PyCharm. So we'll write a very simple program that asks the user to enter a multiple of 7 and the program keeps doing this until a multiple of 7 is correctly entered by the user. So if the user enters say 14 or 21, you simply print yes, this is a multiple of 7. But on the other hand, if the user enters say 10 or 12 or any other number which is not a multiple of 7, you got to take the input again. So let's begin. First, I'll take an input from the user and I'll store this in my variable val. So in Python, every input that you take from the user is automatically taken in the string format and you need to convert this into int. So that is what this int function is for. And within the braces, you take the input. Now we need to make sure that the number entered by the user is a multiple of 7, and if it's not, we need to take the input again. So here's where the while loop comes in. We check the modulus of val against 7, and if this is not equal to 0, that means if val divided by 7 does not give a remainder, that means val is not a multiple of 7. So in this case, again we need to take the input from the user. So we'll repeat our first line once again. Let's have a look at the syntax for while before we move ahead. So we have the first keyword which is while, and then val mod 7 is not equal to 0 is a condition. Now every time this condition results in true, this statement is executed. So this is the only statement within the while loop. Now we need to also take care of the condition where the value is a multiple of 7. So this will come under else. Now if you've gone through other programming languages, this might be something new you're coming across because else is always used with if. You don't use it with while or for or any other loop statement as such. But in case of Python, this can be done. Else colon and next line print. So if the user did finally enter a multiple of 7, we'll just say that this number is a multiple of 7. So when you're printing the value of a variable within a sentence, this is how you do it. Wherever you want the value to appear in the sentence, place the placeholder. Have the placeholder for the variable there. So in our case, val is an integer type of variable. Therefore, we have the placeholder %d. If val was a string type, we'd have %s. And after the quotes, you put the modulus sign followed by your variable name. If you have 2 or more variables, after the modulus sign, within brackets, you can enter your variable names separated by commas, like this. So I just have one variable. And that's it. Now let's run this. Save it first. So your first line, enter a multiple of 7 is printed. Let's enter 18, which is not a multiple of 7, and see what happens. So once again, as we wanted, the input needs to be taken from the user, and this will continue until you do give a multiple of 7. So now if I give 14, there you go, 14 is a multiple of 7, and our program has successfully terminated. Now to better understand the flow of while loop, let's debug this program. So the first thing you do is you keep a breaking point on your first line, and then you go to run and debug the program. So in debugging, we basically see the execution line by line, and to do this, we press F8. So after your breaking point is placed, press F8, and the first line is printed in your console. So let's give in an input, say 87. Let's go back to our debugger. As you can see here, the value of val is now 87. And we have moved to the second line where val mod 7 was checked against 0. And because it was not 0, this means that the while's condition is true and you move into the statements within the while loop. So now we have reached the third line where we are taking the input from the user again. So once again we do F8, and as you see, the user input needs to be taken again. So now I'll give 42, which is a multiple of 7, enter, and it goes back to the while loop because now once again it needs to check if val mod 7 is not equal to 0. And as you can see here, now the value of val is 42. If we press F8, you'll notice how we jumped from line 2 to line 5. This is because this time 42 mod 7 was equal to 0. So the while resulted in false, and the statement right after false, which is your else, is what got executed. So now you have the execution for the last print statement. And if we press F8 once again, you see our program's terminated with the final output 42 is a multiple of 7. So I hope you understood while loop. Let's move on to the next loop, which is the for loop. Now for loop is used to iterate over a sequence. The sequence could be a list, it could be a tuple, it could be an array, a string, or it could even be a range. Basically, if you have certain elements arranged one after the other, a for loop can be used to iterate over these elements. So now let's look at the syntax of for loop. You have the for keyword followed by counter. So counter is basically a variable. Say you want to repeat your name 10 times. What you do is you always keep track of the number of times you've already repeated your names in your fingers. And that is exactly what a counter is to a for loop. A counter keeps track of the position that you're in the sequence. After counter, you have another keyword in, and then you have the sequence. So the sequence, you can literally give your list there, or you can have the variable which stores your list, tuple, array, or string. Now let's move into a demo for the for loop. Once again, I'll open my PyCharm. So now we'll write a program to iterate over a list. Now I'll store my list in the variable x, and my list will have the elements 1, 6, Simplilearn. Now using the for loop, I'll iterate over x. So my counter in this case will be I, in, and my sequence, which is x, always followed by the colon. And now I'll just print I. Let's save this and run it. So as you can see here, the elements of x are printed. There's 1, 6 followed by Simplilearn. So what it does is basically when you give I in X, I assumes the value of the first element in X, prints this value, and every time you go back to the for loop, I is incremented by 1. So the second time you reach the for loop, I is now holding the value 6, and the third time I holds a value Simplilearn. Now the same thing can be done with just a string. So if X is equal to Simplilearn, which is a string, and we run this code now, you see all the letters of the string are printed one by one. So in case of strings, I holds the value of each character in the string right from the beginning up till the end. Now Python also allows nested loops, and by nested loops we mean loops within loops. So now there are various ways that nested loops could be implemented. It could be a for loop within a for loop. It could be a while within a while loop, a for within a while loop, or a while within a for loop. So in our demo for nested loops, we'll see one of the most popular applications for it, which is accessing the elements of a matrix. So first, we'll begin with creating a matrix. Store my matrix in variable X. And my matrix will have two lists. One would contain the elements 1, 2, 3, and the other will be of alphabets ABC. Now with the matrix, as you can see, there are two lists within it. Our first for loop will iterate over the elements of X. So the range is X. So when I say that I iterate over the elements of X, I basically takes the value of the first list in the first iteration and the second list in the second iteration. Now our second for loop, which is nested within our first for loop, will iterate over the values within that list. So for j in I, let me explain this once again. So if I points to your first list, j will be used to iterate over every element in your first list. And in your second iteration, I will point towards your second list and j will iterate over every element in your second list. We'll just print out the elements. And let's run this. I'll just increase the size of my console here. Run it. And as you can see, the elements of your matrix are printed. 1, 2, 3, ABC. Now what if you want 1, 2, 3 to be printed in one line and your next list elements, which are ABC, to be printed in the next line? So every time you print j, you do not want a next line. So put n equal to quotes. What this does is that it removes the new line, which is automatically put by the print function in Python. And once you exit the inner for loop, you're basically moving to the second list. So now you want a change in line. And hence I just put a print statement here. Let's run this. And as you see, 1, 2, 3, ABC. Now nested loops can get a little confusing with the flow. For this purpose, we'll also debug this code. Place your breaking point on the first line and debug. F8. And as you see, X holds the two lists 1, 2, 3, ABC. Now F8 again, and our first for loop is executed and I now holds the value 1, 2, 3 as you can see here. We now have moved into a second for loop and j holds the value 1. So I right now points to our first list in X and j points to the first element in our first list in X. Now once we execute the print statement, your first element gets printed. And once the first element is printed, you go back to your inner for loop. And now 2 gets printed. Once again, you go back to your inner for loop. 3 is printed. And again, you go back to your inner for loop. Now you have reached the end of the ith list. The next time you click the F8, you're basically jumping over to the print statement at the end, which shifts to a new line. And now we are back to our outside for loop. So our outer for loops counter, which is I, now points to the second list in X, which is ABC. So when we are back, so we click F8 again, and j has taken the value of the first element in your second list. which is A. Once again F8, and as you can see, A is printed in the console below. We are back to our inner for loop. Print, press F8 again, B gets printed. Again we are back to our inner for loop and C gets printed. Now we have reached the end of our second list too. So the next time we press F8, the control skips to the last print statement, which is a new line statement, and it goes back to the outer for loop. Now here too, the counter I has reached the end of our matrix X. So once again, when we hit the F8, our program terminates. Now as we saw, loops have a certain flow, and you might come across certain scenarios where you want to break out of this flow. So this is where the loop control statement comes in. We look at the two most popular loop control statements used in Python. The first is the break keyword. Suppose you're executing a loop for say 10 times, but if a certain condition occurs between our first and our 10th iteration, we want to immediately exit out of the loop. In this case, you can use the break statement. So I'll just move back to my PyCharm and show you a simple demo on how break can be used. So the first thing we do is we'll create a string. I'll store this in my variable X. Now to iterate through the string, of course we'll use the for loop for I in X and colon. Now what we want our program to do is that it should print only the first sentence of our string. So it should print just hey there. And as we can see in our string here, hey there is followed by a full stop. So we can say that whenever we encounter the full stop, we'll break out of the loop and print no more. So if I is equal to full stop, we'll break out of the loop. And for every other case, we'll simply print I, which is the character in our string. So let's run this code. And as you can see here, all our characters, hey, there, are printed. And once I is equal to full stop, the if statement results in true. And we encounter the break statement, which breaks the loop. So as you can see here, every character of our string is printed in a new line, which is not what we want. So in our print statement, put end equal to quotes. And this will ensure that you're not going to a new line every time. Let's run break again. And yeah, hey there appears in the single line. So once again, I'll repeat how the flow of this program works. Goes to the for loop. I iterates over every character in the string, hey there, how are you? And every time, I is checked against a full stop. So if I is not equal to the full stop, we come to this print statement, which is a part of our outer for loop, and only the character is printed. We go back to our for loop every time, and I is incremented, so it keeps pointing to the next character. And once I is equal to full stop, we encounter the break statement, which breaks the control to outside the loop, and our program terminates successfully. Now we'll have a look at our second loop control statement, which is continue. So in some cases, when a certain condition occurs within a loop, you do not want to break out of the loop, but you want to skip that particular iteration for the loop. So in this case, you can use continue. Once again, we'll move back to PyCharm so I can show you a short demo on how continue works. Now for our demo for the continue keyword, we want to print all the numbers in a list which are less than 10. So to iterate through a list, we have for I in and our list, which is 1, 13, 56, 4, 6. Now let's see how we write this program without using the continue statement first. So within the for loop, if I is greater than 10, which is basically the number we do not want to print, we have no action to give under if, because there's nothing we want to do if the number is greater than 10. And under else, which is if the number is not greater than 10, we'd want to print it. Now this seems simple, but the problem here is that you cannot leave if without any action. This would result in an error. As you can see here, there's an indent expected, and this is where continue comes in. So if I is greater than 10, you continue. So basically you skip all statements after this continue statement in the for loop. And when you insert your continue statement, the control automatically goes back to the for loop. So in that case, you do not even require your else statement here. And you can just have print under your for loop. So once again, I'll explain how this works. I iterates over our list. So I points to our elements 1, 13, 56, 4 and 6 in each iteration respectively. And every time we check if I is greater than 10. If I is greater than 10, we do not want to print I. We just say continue, so the control goes back to the for loop. And if I is not greater than 10, that is if I is any number between 0 to 9, we simply come here and the number is printed. So I'll save this and let's run this code. So as you can see here, 1 gets printed, 4 and 6 is printed. We can debug this too, just to see how the flow works. So place your breakpoint here and debug continue. As you can see, first time I is pointed to 1. Now I is checked if it's greater than 10. Of course, I is not greater than 10. So the control skips to the print statement. And if you go back to the console, press F8, you can see 1 gets printed. Now the control goes back to the for loop and this time I is 13. Is 13 greater than 10? Yes, 13 is greater than 10. So the if condition is satisfied and we reach the continue statement. So once the continue is executed, as you can see here, the control transfers back to for loop and I moves on to the next iteration. And I currently holds a value of 56. So this way, all your numbers which are less than 10 gets printed one by one. So in our previous video, we went through what loops in Python are. And we briefly went through for loops, while loop and nested loop. Today we'll focus solely on for loop. So let's start from scratch and look at what exactly for loop is. So for loop is used to iterate over a sequence. Now the sequence could be a list, tuple, array, string, or even a range of numbers. So if you have multiple elements stored consecutively, for loop is exactly what you need to access each of those elements. Now here is the syntax for loop. So first you have the keyword for, followed by counter. Counter is just a variable which keeps track of the position of the element that you're accessing right now. And then you have the keyword in, followed by sequence. Now sequence is basically the name of your list, your tuple, array, string, or even a range of integers. And then it's followed by colons. And in the very next line, you can put down your statements which come within the for loop. So to better understand this, we have a series of demos which I'll be showing on PyCharm. So let's move on to that. So our first demo is a classic example of where you use for loop. That is to access the elements of a list. So first we'll create our list. I'll name my list X and we'll have the elements 1, 4.2 and the string Simplilearn. Now this particular list of ours has just 3 elements. So we could print the elements specifying their positions individually. Say x, 0, x, 1 and x of 2. So we could print the elements of our list specifying the indexes individually. So say x of 0, x of 1, x of 2. And if we run this code, save this and run it. As you see here, all the elements are printed correct. But what if our list had 100 elements? This would be quite a tedious approach then, wouldn't it? So here is where you use the for loop. With for, you can have a counter variable, which is I in my case, in, and this is the place where you enter your list name. So x, colon, and I'll just say print of I. So what we are doing here is we have this variable I, which is a counter, and it will iterate over every element of x. So the first iteration, I will hold the value 1. The second iteration, I will hold the value 4.2. And the third, it will hold the value Simplilearn. So let's run this code. And there you go. All our elements are printed. So this is a much simpler way to print the elements of your list. Now for can also be used to print every character in your string separately. So if x is just equal to Simplilearn, and we run this code once again, you see all the elements of your string are printed. Now, if you want all of them to be printed together, that is in one line, in your print statement, just put end equal to braces and then run this code. And your entire string is printed here, but character by character. So we can debug this to see how it's printed. Just place a breaking point on your first line and debug sample. And I'll enlarge my console. Press F8 to move from one line to the other. And our first line's executed. So X holds the value Simplilearn. And now we are on our for loop line. The first time we execute it, I takes the value of the very first character in our string X, which is S. So now when we say print of I, S gets printed. We go back to our console, we can see this here. And next time we press F8, now I will take the value I from X and I gets printed. In this manner, all the characters of your string are printed one by one. And then your program terminates. So that's the very basic example of how you can use for loop. Now let's try another case where we want to print all the even numbers in the range of 0 to 20. So once again, we have for I, which is our counter variable in. Now when you want to specify a range of values, you use the function range and give your starting value and your ending value. So the thing with range is, guys, that if you keep your ending value as 20, it will only consider the numbers from 0 to 19. But we want 20 also to be included. So our ending value is 21 here. Put your colons. And let's just see what this prints first. So print of I, and we'll run this code. So here the for loop printed all the values from 0 up till 20. Now we want only the even values between 0 to 20 to be printed. One way of doing this is that you can check using an if statement if every value that is stored in I is a multiple of 2. Or you can simply modify this range function slightly and put comma 2. So here what this means is that every second element is only printed. So 0 will be printed, 1 would be skipped, and then 2 would be printed. Let's see that. Run it. So as you see here, in just 2 lines of code, we got all our even numbers between 0 to 20 printed. Now say we want to find the sum of all these even numbers. But this time, because we want to use a slightly different approach, we'll use the if statement to know if the value in I is even or not. So the first line would be about the same except you delete the 2 from the range. And then you have if statement. So if I mod 2 is equal to 0, you will have a variable say sum, which is equal to sum plus I. So what we're doing here is I will hold a value between 0 to 21, and then this value is tested to check if it is a multiple of 2. That is, if division by 2 gives any remainder or not in the if statement. And if it does not give any remainder, that is, if the remainder is 0, then we come in and we keep adding this I to another variable, which in our case is sum. So sum is the addition of all the even numbers. Now we have not declared sum as yet, and sum needs to have some initial value. So just outside your for loop, put sum equal to 0. So here we have added all our even numbers. Now once this entire procedure is done, we can print a variable sum. Let's run this code, and the sum of all the even numbers between 0 to 20 is 110. Now let's move on to our next demo where we'll be printing patterns. So patterns are a great way to implement for loops and also to sharpen your programming skills. In a previous video, we had a pattern with asterisk symbols. We printed an inverted triangle using asterisks. So here, this is the pattern we'll be printing with numbers. So for this particular program, we'll be taking input from the user specifying a number. So in this example, the number entered by the user would be 5. And as you can see, the number given by the user is the last digit of the last row. Also, it is the number of rows in the pattern. So let's begin coding this. First, we'll take the input from the user in a variable, say n. So all the inputs given by the users always in string format. In case of Python, we need to convert this into int. So input, enter a number. Now we'll have the first for loop, which is for every row. So for I in range of 1 to n plus 1, because if we give n, then the range will be taken only from n to n minus 1. Now that's an outer for loop. And in case of patterns, as you go through others, you'll notice that there are at least 2 for loops even for the most simple patterns. So here is where we implement nested loops, specifically nested for loops. Now the outer for loop, as I mentioned earlier, is for the number of rows. And we'll have the inner for loop for every element in the row. For j in range of, again, 1 up till I. So when we consider our outer for loop, it goes from 1, then 2, 3, 4, and then 5. And the inner for loop prints from 1 up till the ith number. Now inside our inner for loop, we'll just print j. And we do not want to go to the next line immediately after printing j. So put end equal to quotes. But once we complete printing the entire row, then we want to move on to the next line. So after our inner for loop, that is under our outer for loop, we'll print the new line. So just put a plain print statement here. Now let's run this code. Enter a number. We'll start with 5. And as you can see here, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4 has been printed. But the 5th row is not printed yet. So if you go back to your code, you'll see where the error is. It's in the second for loop. We have run it from 1 to I and not I plus 1. So what happened here is that since we ran it till I, when I was 1, the inner for loop ran 0 number of times. And therefore, it's the first row that was not printed. And our second row printed just 1. Our third row printed just 1, 2, and so on. So we'll make this correction and run it again. Enter 5. And there you go. Our pattern is printed. Let's run it again and try a different number this time. Say 10. So our pattern is printed for any number that you enter. Now another very popular application of nested for loops is accessing the elements of a matrix. So here we'll implement matrix as a list containing lists. And what we'll do is we'll take 2 such lists or 2 such matrices from the user and we'll find their sum. So to add 2 matrices, it's very important that they have the same dimensions. That is, they have the same number of rows and columns. So we'll take the number of rows and columns from the user first. And convert this to int. Next, take the number of columns, my variable c. Now we'll create our list, our first list, which is x. Right now, x is empty. Okay, so our first for loop will be to iterate over the elements in our list x. So for I in R, because R is the number of elements in X and C is the number of elements in the list in X. So for I in R, and now our inner for loop. So our outer for loop are for the lists in X, that is for the elements in X, and our inner for loop will be for the elements within those lists in X. So for J in C. So the approach we'll be taking is that we'll first create those individual lists within X and then we'll add that list to X. So let's name our inside list as val, and to add elements to a list, use the function insert. Now the element would be inserted in the jth position and the value for the element would be again taken from the user. So input, enter the I into jth element. So we'll enter the placeholders to %d element I comma j. So we haven't declared val yet. Let's do that. It's initially an empty list. So all the values within our list val would be inserted within the inner for loop. So once we are out of the inner for loop, our list val would be ready. So now we can add this list val to our list x. So outside here, put x dot insert at position I, we insert val. I'll explain this part once again. So our outer for loop for I in R, where R is the number of elements in X, that is the number of lists within our parent list X, would be counted in I, and our inner for loop, which is for the elements within our child list, would be counted in J, and inside our inner for loop, we'll take the input from the user and insert it into our temporary list val, and then once we exited the inner for loop, we'll add this list val to our parent list X, and we are done with taking the input for the first list. Now in the similar manner, we'll take the input for the second list too. We'll name our second list Y, which is initially empty, and you can just copy paste this code here. Change the X to Y, and that should do it. Now one thing we missed out here is clearing val. We don't necessarily have to do this because every time you go back to the inner for loop and you say input this value at the jth position of val, the previous value will be automatically overwritten, but still we'll clear it every time we exit the inner for loop. Okay, so we are done with taking the input for both our lists containing lists, and now we move on to the part where we find their sum. So first we create a variable sum, which will be an empty list. Now this list will hold the added values from the other two lists. So again, for accessing the elements of a list containing lists, we need nested for loops. So for I in R once again, and for J in C. So just like when we took input, when we are finding the sum 2, we'll first add the elements of the child list. So say find the sum of the first list within X and the first list within Y. And once we find the sum of these two lists, we'll put that into our parent list sum. So we'll use val again for our temporary list, and val.insert at the jth position the sum of the elements in the jth position of our ith list in X and Y. So X of I, J plus Y of I, J. And once we come out of the inner for loop, that means our val list is complete. We can add this list to our parent list sum. So sum dot insert at the ith position, insert val. And every time we exit the inner for loop, we'll also clear val. And that's how you take two lists of lists from the user, find their sum, and finally print it. So just print sum. Let's run this code. Enter the number of rows. Let's start with 2. Number of columns 2. Okay, so we have an error here for I in R. So the error here is R is an integer, and when we want to iterate over a range of numbers, we need to specify the function range. So range of and the indices in lists or matrices start from 0. So 0 up to R. In the similar way, let's make this correction for all our for loops. 0 to C and here too. And here too. Okay, let's run the program once again. And now we got to enter our elements. So our first element, second, third, fourth element. So with that, we completed all the elements of our first list. 0th element is the first element in your first list of X. 1 is the second element in your first list. 1 0 is the first element in your second list, and 1 1 would be the second element in your second list, all in X. Now we start entering the elements for Y, the first element of the first list in Y. So we entered all the elements for both X and Y, and this is our list sum. But then this is not the sum of the elements. what has happened here is that it's just concatenated the elements of the two lists. So our first element in list X, that is 1, and our first element in list Y, which is 2, is just concatenated and it's given 12, whereas we want 3, the sum of them. This is because we took the input from the user, but we forgot to convert it to int. That means all the elements were stored in the list as strings, and when we use just the plus sign on strings, it just concatenates the values. So now we'll convert each of the inputs to integer. And there you go. Our inputs are now converted to integer. Now we can run the program once again. Enter the elements. And this time our sum is printed right. So 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7, which is 10, and 4 plus 8 is 12.
While loops in Python. So previously we briefly went through while, for and nested loops. We saw that for loops are used mainly to iterate over a sequence. While loops are basically used to repeat a section of code an unknown number of times. So if you have a certain code that needs to be repeated, say n number of times, where n will be decided during the runtime, you can definitely opt for a while loop. And every time you move into a while loop, a specific condition is checked. The minute that condition results in false, that's when you exit out of the while loop. So here's the syntax for a while loop. You have the while keyword followed by the expression or the condition. This is what needs to result in true to enter the while loop, and the expression is followed by colons, and in the very next line you can put down the various statements that go into your while loop. So now that we saw what a while loop is typically used for and the basic syntax of a while loop, let's move into a few demos and explore the various applications of while loop. So I'll be performing my demos on PyCharm. Now my first demo is a typical example of any loop statement. Suppose I want to print these strings Simplilearn 10 times. I could do this using the print statement alone and have the statement copy pasted 10 times. That could work, but with loops we have a much simpler way of doing this. Since we are talking about while loops, that's what we'll use. So say while, and I want to print my string 10 times. So I is my counter, and I say I less than equal to 10, colon, and in here I put my print statement just once. Now I is the counter, as I mentioned previously. So this counter needs to be initialized first. We need to give it a starting value. So I starting value will be 1, and I will move from 1 to 10. That means every time you're inside the loop, every time Simplilearn is printed, I needs to be incremented by 1. So I equal to I plus 1. Now a shorthand of doing this is you can have I plus equal to 1. This is exactly the same as I equal to I plus 1, just shorter and simpler. So I'll explain this once again before we run it. We have I equal to 1, where I is something that we're using as a counter. And then we have our while loop. So in our while loop, we are checking if I is less than equal to 10. And since the first time I is equal to 1, we will enter the while loop. Simplilearn will be printed. And in the very next line, we are incrementing I. So every time Simplilearn is printed, I gets incremented. We go back to the while loop and it's checked against this condition whether it's less than equal to 10. So the minute I is equal to 10, you'll have Simplilearn printed one last time. The next time we go back to the while loop, I will be 11 and the while condition would result in false. So we exit out of the loop, and since we have no more statements here, our program terminates. So let's run the code and check if everything works as we expect it to. So here we go. Simplilearn is printed 10 times. Now can you only increment your counter? No, we can also decrement our counter. So if I say I is equal to 10, that is I start my counter from 10 and I want to decrease the counter till 1. So we'll have the while loop executed as long as I is greater than 1.
And now that we're decrementing I every time, we need to change the plus sign to a minus. So it's the exact same thing that we're doing now as we did previously. We're printing Simplilearn the string 10 times, but this time our counter starts from 10 and we go down to 1. So every time we check if I is greater than 1, and the minute I is not greater than 1, that is I is equal to 1, we do not print Simplilearn anymore, we just exit out of the while loop. So let's run this code too. So here, the string Simplilearn is printed only 9 times, whereas we want it to be printed 10 times. This is because in our while condition statement, we put greater than 1. What we need is actually greater than equal to 1, so that even when I is equal to 1, we are printing Simplilearn once. So now if we run it again, we'll see that we'll have Simplilearn printed 10 times. So for our next demo, instead of printing something 10 times, let's find the sum of the first 10 natural numbers. So in that case, I would start from 1 and then we go all the way up till 10. So I is less than equal to 10. And within your while loop, we can remove this print statement. And now every time I needs to be added to some other variable. So we'll call that variable sum, and sum equal to sum plus I. So I starts from 1, and every time you go inside the while loop, you have to check if I is less than equal to 10. So as long as I is less than 10, you move into the while loop, and in the while loop, you keep adding this I to another variable sum. And after it's added, you increment the value of I, so that I goes all the way from 1 up till 10. And once I is 11, the while condition results in false and you break out of the while loop, moving to the next statement after the while loop, which in our case would be the print statement to print the final sum. So let's run this code. So can you guess what the error is in this case? Our variable sum here has not been declared or initialized previously. So outside our while loop, let's have a variable sum, and sum's initial value should be 0. Let's run the code now. And there you go. So the sum of your first 10 natural numbers would be 55. Now let's modify this code slightly so we can find the sum of the even numbers between 1 to 10. So our first few lines would remain the same. I will start from 1, sum will be equal to 0. Our while condition 2 will be the same, but this time inside our while loop, we'll have an if statement. And the if statement will check if I is an even number. So to check if a number is even, the remainder from the division of the number with 2 should be equal to 0. So I mod 2 equal to 0. And if that is the case, we can find the sum of the number. And whether that's the case or not, we still need to increment I every time within the while loop. So sum would come under the if statement, but I plus equal to 1 would remain under the while loop and not within the if statement. So I'll repeat this once again. I, which is our counter variable, will start from 1. Sum will be equal to 0. Every time our while loop will check if I is less than equal to 10. And every time I is less than 10, we can enter the while loop. Now within the while loop, we need to check if I is an even number because we want to find the sum of only the even numbers. So if I mod 2 is 0, that means I is an even number and we can add I to our variable sum. Now whether I is an even number or an odd number, every time we still need to increment I. So our incrementing statement would be outside the if statement and under the while loop. And finally, once we exit the while loop, we'll print our sum. We run the code and the sum of all the even numbers between 1 to 10 is 30. Now let's explore while loop for the very purpose it was made, that is to run a certain code unknown number of times. So for this demo, we'll work on reversing an integer. So the first thing we do is we need to take the input from the user. So the user will give us the integer and I'll store my input in the variable n. We also need to convert the input from the user into integer because it'll be provided in the string format. So we have the int function within which we'll have our input function. Now we'll declare another variable nr, which is basically our reverse n, and this will be initialized to 0. Now suppose n is equal to 5, 6, 7, 8. nr should be equal to 8, 7, 6, 5. So if you look at the values of n and nr, you'll notice that what we basically need to do is we need to remove the last digit from n and we need to add it to the front of nr. So to remove the last digit from a number, we can use the modulus function. That is n mod 10. And we need to keep doing this every time with n. So we'll keep doing this until n mod 10 is equal to 0. That is, until there are no more digits left in n. So this will be the condition for our while loop. So while n mod 10 is not equal to 0, we can continue with our statements. Now within the while loop, let's take a variable c where we'll extract this digit, that is n mod 10, would be stored in c. Now we need to add c to the beginning of nr. But now nr is an integer and so is c. So if we just say nr equal to nr plus c, what this will do is it'll add the two integers and it'll give you the sum. So in our case, if 8 is put into nr the first time and 7 is put into nr the second time, when we come to the statement where nr is equal to nr plus c, what it will potentially do is give you the sum of 7 and 8, which is not what we want. We want 87 to be stored in nr. We want the digits 8 followed by the digit 7 to be stored in nr. But now, if we multiply nr with 10 and then add c to it, our problem is solved. So if the first time we are putting 8 into nr, since nr is 0, it would be 0 into 10 plus 8 and nr would be 8. Now the second time when we extract 7 from n and nr is already 8 and we come to this statement here, it says 8 into 10, which is 80, plus 7, which will give you 87. So this way we can slowly build up nr. Now a small piece of the puzzle that we are missing is that the value of n remains constant throughout the while loop so far. So what happens if the value of n is constant is that every time you do n mod 10, you're extracting the digit 8. You're not moving forward to 7. So what we can do here is that once 8 is extracted, we completely remove the digit 8 from n. So that can be done by dividing n by 10. So now n equal to n by 10. But now in Python again, if we say n divided by 10, it puts a decimal point just before 8. So 8 is still there. But on the other hand, if we say n//10, our result would be an integer and only 567 would be returned to n. Now, since n has reduced from 5678 to 567, the next time you go back to the while loop and do n mod 10, it's 7 that is extracted. And this way, we can extract every digit from n and keep adding it to nr in the reverse order. Now that we are done with our while loop, outside our while loop, we'll print the value of nr. Let's run this code. Enter your number. So I entered 4652 and my output was 2564, which is just as expected. Now we can debug this code too. Here's my debugger. So press F8 to move from one line to the next. Our first line, n, where you need to put the input. So go back to your console, put your input. I'll put a small number since we are just trying to figure out how it works. So 467 should do. Right, now go back to your debugger. So as you can see, the value of n is 467. Press F8 again. Now the value of nr is 0. We have reached our while loop statement. And n mod 10 is not equal to 0. That is, n mod 10 is basically 7 right now. So we move into the while loop and the number at the end of n is extracted and put into c. So c, as you can see here, is 7. Now we have reached the part where we add this number to nr. So nr is now 7 because nr was previously just 0. 0 into 10 is 0 and plus c, which is 7. So nr is 7. Press F8 again, and this time, as you can see down here, the value of n has been changed to 46 because we divided it by 10. So right now C is 7 from our previous iteration, n is 46 and nr is 7. Now once again we go back to our while loop. The while condition is checked and n mod 10 is still not equal to 0. So we go into the while loop. Now C is equal to 6 and nr is now equal to 76 because it was previously equal to 7 into 10 plus 6. And once again the value of n is changed. Now the value of n is just 4. So n mod 10 is still not 0. Go into the while loop. C is extracted. C is 4. nr is calculated, which is now 764. And n is changed. Now n is 0. So now 0 mod 10 is 0. And the while condition results in false. So we exit out of the while loop and we reach the print statement. And now our nr should be printed in the console. As you can see here, it is. Now let's write another program to calculate the length of a list without using the len function. So the first thing we'll do there is we'll create our list. So my list name is X and it has 3 elements, 1, 2.3 and the string Simplilearn. Now let's initialize our variable length, which will hold the length of our list. And we'll be using the while loop to do this. We'll have a counter I which is equal to 0. Now we'll run our while loop as long as x of I has something within it. As long as x, now we'll run our while loop as long as x of I has anything within it. So we can just say x of I. That means if x of I is equal to something, we'll be able to enter this while loop. Now within this while loop, we'll increment our length variable. That is, every time we are entering the while loop, it means that x of I is holding some value. So our length is incremented by 1. So you can say length equal to length plus 1, or as we saw earlier, you can just go with length plus equal to 1. Now x of I holds a value. We incremented the value of length. Now we need to move on to the next element, whether it exists or not. So we increment the value of I. So I plus equal to 1. And that's pretty much it. So the minute we reach the end of our string, that is x of I does not hold any value, while should result in false and we'll exit out of our while loop. So then we'll print the value within length. So let's run this program. But as you can see here, there's an error. While x of I index error list index out of range. This means that the first time we're going through the while loop, when x of I is 1, there's an element. So this means that the first time we're going through a while loop, x of I holds some value. The second time too, x of I is holding some value, and so is it the third time. But the next time when I is equal to 3, that is, we are trying to access the fourth element of our list x, there is no value, and this is resulting in the index error. So this is where we use the try block. The block that produces an error is put within the try block, and the try block is written like this with the keyword try followed by colon, and everything within it must be spaced or indented slightly to the right. So a while loop is the one producing the error. So the while loop comes within the try block. Now what happens is, once the error has occurred, try will catch this error and we will write another block which will handle this error. So this is our except block, and this is how it's written. You have your keyword except followed by the error that this block will be handling. So in our case, this is the name of our error, index error. So put that down here, colon again, and everything within the except block is again indented slightly to the right. And there you go. So our error, which was occurring previously, that is the index error, will be caught within the try block, and our except block will handle this error. Let's now run our code. And as you see here, this time our error is handled perfectly and it's just ignored, and the value of length gets printed, which is 3. So this is one way you can find the length of a list using while loop and not your len function. Now a while loop can be nested within another while loop. So for our next demo, we'll have a pattern printed using nested while loops. So this is the pattern we're attempting to print here. we'll take a value n from the user, which will be an integer, and that number n would basically be the number of rows in your pattern. So in this particular example here, n is 5 and we start by printing 1. So the digit 1 is printed once, and then in the next line the digit 2 needs to be printed twice, the digit 3 times, digit 4 times, and then finally the digit 5 times. So let's begin coding. First thing, we take the input from the user, store it in our variable n. Now we'll have one while loop which will be to take care of the number of rows. So our number of rows should be till n. So I is less than equal to n, and I of course will start from 1. So I will go from 1 up till n. Okay, so the outer for loop takes care of printing each row. Now within each row, as you can see, elements are printed. So if we are on our first row, then the number 1 is printed just once. If we are on our second row, the number 2 is printed twice, and so on. So we'll have another counter variable within our outer while loop, which is j, and j will be initialized to 1. Now j again has to run all the way from 1 up till I, because I number of times an element is printed on the ith row. Now we'll have our second or our nested while loop here, and the condition for this is j is less than equal to I, because j will go from 1 up till I. And as long as j is less than or equal to I, we enter the second while loop. Now within the second while loop, the only element that is printed in every row is element I. So if you're on the first row, 1 is printed, second row, 2 is printed, third row, 3 is printed, and so on. So what we need to print here is I. And every time we print I, we need to make sure that we are still on the same line. So end equal to quotes and increment j, of course. Now once we exit our inner while loop, we increment the value of I so that we can move on to the next row. So now that we are completed with one row, we can then move on to the next line to print our next row. So here we put in an empty print statement which will shift to the next line. And that's pretty much it. We can now run our program. So enter a number, let's say 5. And as you can see, our pattern's printed here. Let's try out another number, say 7. So our pattern can be printed for any integer. Now let's get on to our final demo. So here we'll try out a simple game. So program will generate a 4-digit number using the random function, and our user needs to guess this number. So for every digit that the user guesses at the correct position, we print that one place is correctly guessed. So suppose say our program generates the number 7632 and our user enters 8931. If you compare these two numbers, you can see that the second last digit here is both 3. So 3 has been entered in the correct position. Therefore, we can output 1 digit entered at the correct position. And in this manner, the user needs to guess all the digits in their correct order. If the user wants to quit this game at any point of time, he or she just needs to enter 10. So let's begin coding. First, as I already mentioned, we'll be generating a 4-digit number using the random function. So let's import our random library. Let's now generate a random number. So I'll store this random number in NumPy because the P is for permanent, as we'll have another variable which stores the same number, but the value in that particular variable will be altered. NumPy variable, on the other hand, will remain constant. So this is our random number generated. And we want a 4-digit number. So our boundaries will be set. Now let's take the input from the user. So I'll store the input in a variable n. Okay, so now let's begin our while loop, and this while loop will run as long as n is not equal to 10, because as I already mentioned, if the user enters 10, basically the user wants to quit the game. Now in here, the first thing we need to do is we'll create another variable num, And into this variable, we'll put the value of NumP because num is going to be altered throughout this program, and yet we want to store the actual value somewhere. So we'll alter num, and NumP, where P stands for permanent, will remain constant. Now we'll have another variable, COR, the short of correct, which will specify how many digits have been guessed in the correct places. So initially the value of correct will be 0. Now to check if a digit is in its correct place, so we need to extract each digit from both n, which is the number entered by the user, and NumP, which is the number generated randomly by our program. So to extract the numbers, as we did in our previous example, we'll use the mod function. So we'll run the while loop as long as num of mod exists. So you can just put num of mod 10. So what this means is that every time you do a number mod 10, it extracts the last digit. So if a number mod 10 does not have anything to return, that means our number is empty, and then we can exit out of our while loop. So now let's begin extracting the numbers. Now we'll have a variable numC, which will store the last digit from the variable num, which is basically the number generated by our program. So num mod 10 would be stored in numC, and we'll have another variable which will hold the digit extracted from the number guessed by the user. So I'll name that variable nC, and that will be equal to n mod 10. Now just like we did in one of our previous demos, every time you extract a digit, you also need to remove that digit from the number itself. So now num should be equal to num divided by 10, and n should be equal to n divided by 10. Okay, so now we have the extracted digits. Now we need to check if numC and nC are equal. So if numC is equal to nC, that means there's this one digit which is held in both numC and nC, which is also present at the correct position. In that case, we increment our correct variable. And if this is not the case, we simply continue with our while loop. Now this process will continue as long as there's any digit left in num, or a variable n basically. Now once we exit out of the while loop, we must check if correct is equal to 4. So if correct is equal to 4, that means all the 4 digits guessed by the user were right and in their correct places. And that means that the user guessed the entire number correctly. So over here we have if correct equal to 4, you print congrats, you guessed it right. And if this is not the case, that is all the digits were not correctly guessed, then we'll print how many digits were actually correctly guessed in their correct positions. So else %d digits were guessed right. Now if all the digits were guessed right, that is the user guessed the number right, we can also break out of our while loop. So you put a break statement there, and we'll come back here where we print how many digits were guessed right. Since all of them weren't, we need to give the user another try where the user again enters a 4-digit number. So once again, we'll just copy paste this input line here so that the user can again guess the number. And this process will continue until all the numbers are guessed right and the control goes into this if statement and breaks out of this while loop. Now once the control flows out of this while loop, the program should be terminated because we have nothing else to print. But if the user does enter 10 instead of a 4-digit number, we need to exit the program immediately. That is, we need to exit this while loop, the outer while loop, immediately. So here we'll have an else statement, that is if n is equal to 10, then we print you quit the game and the program will end right there. Okay, so that is done. Let's now run our program. Enter a 4-digit number. So I'm trying out 5673. Okay, I made a slight mistake here. %d digits were guessed right. But what is this percentile d? Percentile d is just a placeholder. So we need to place the value of our variable COR there. Let's run this program once again. 6748 is my guess. So 0 digits were guessed right. Let's try again. 8256. Again, 0 digits were guessed right. Okay, so there are a number of permutations. To make it simpler, for the purpose of our demo, I'll just put in a print statement here, which will print the value of NumPy, and accordingly, I'll show you how the program flows. Let me run the code again. So our number is 3345. Let's start with a completely incorrect guess. So 6732. 0 digits were guessed right. Now, suppose I guess my first digit is 3 and 976. So 1 digit was guessed right. Now, since I know my number is 3345, it's easy for me to say it was the first digit. It's pretty obvious. Let me try 3545. So 3 digits were guessed right and 3345, and congrats, you guessed it right. Now, if I had to quit the program, 0 guesses, but now I want to quit the program, so I enter just 10 and you quit the game. So as you can see, our program's running just fine. To decrease the complexity of the game, you can change it to like 2-digit numbers. So you can go from 10 to 99. Or so you can put a smaller range too. So with that, we come to an end to while loops in Python.
Today we're going to cover the basic array in Python and some of the functionality around it. And before we jump in, I'd like to please remind you that you can always post something in the notes here on the YouTube videos, or you can go to www.Simplilearn.com and go under our forums and ask questions there. We have a team that monitors these and they'll be happy to answer those questions. Array in Python. Array is a container that holds multiple values of the same type. And this is very key, is that the array has to be of the same type. So the syntax for developing your basic array is going to be your variable, whatever you want to call it, my array or whatever you're working on, equals array, your type code, and then the elements in the array. This is the main types that they have for arrays. And you'll see a quick list here. Character is basically your character as you know it. You have A, B, C, D, E, F, G. They're represented by a number between there's like up to 128 characters. That's how many numbers are in there. So when you have a signed character, that means that they're now using that instead of as a character notation, it's being used as just an actual value, plus or minus. Unsigned character, you don't usually use a lot of these as far as signed and unsigned characters, but it does come up for using them for containing a small amount of space to do something. And then you have your PyUnicode. The PyUnicode is your Unicode characters. So if you remember, if you're in the American set of characters, they use only half the memory, but they don't have all the different characters used in different languages. That's why a lot of times you'll see, especially when you go international, you need to be very aware of whether Unicode or just a regular character. And then there's the regular integer where they have signed short, so it has a smaller amount of values, unsigned short, your signed integer plus or minus, again your unsigned, and then you have your long, your signed long, unsigned long. So if you want to have a long, basically is double that. So each one of these just doubles in size and how much numbers they can hold until you get all the way to float and double. So again, those are just different numbers and just depends on how many significant digits you want to keep on there. That's a brief on type code. Definitely we're not going to go into too much detail, any more detail on that, but we do want to jump in and actually do an array and start showing you how the arrays work and what you can do with them. Now, to do this, you're going to use your favorite Python editor or IDE, your interface. I myself go through Anaconda in Jupyter Notebook. Certainly if you're using any other interface, it'll work just the same. This is very basic code in Python. I use Anaconda because it's a great navigator for following your different modules you install into your Python, and it has different packages. And then Jupyter Notebook sits on there. There's also Spider, which is another Python editor. There's a ton of Python editors out there. But we'll go ahead and launch our Jupyter Notebook. Once I'm in the Jupyter Notebook, it opens up whatever folder it's set to, and I can simply go under New, and I'm going to create a new Python 3, and that'll open up my Python 3 notebook. So now I can start writing code. And we'll start off the bat by importing. So we're going to, from array import, we're going to import all the different functionality that the array offers. And then we're going to create our first array. We'll just call it ARR, or we can call it my array or whatever you'd like. and it is simply array, and then we're going to put in the type, and then we'll go ahead and just put in brackets what we want for an array. And we'll do 1, 2, 3, 4, 5, real simple array. And then let's go ahead and just print that out and see what that looks like. And we get an array of type integer, 1, 2, 3, 4, 5. And then let's flip over and just remember what the I is. Lowercase is signed integer and uppercase is assigned. This is a lowercase, so we have a signed integer. It's actually a short integer when you do the I, and then the H is the unsigned short integer. And to see what that means when we're assigning this, let's go up here and change one of our values to -1. And we have it set to I, and we run it, and it comes out okay. No errors. But what happens when we change this to H, which is the unsigned short integer? When we run this, we're going to get an error. Why? Because we gave it a minus value, and if you remember correctly from the H is an unsigned short integer, so there should be no negative values in there. Then we'll go ahead and go back and just switch this to I and run it. And then there's so many things we can do with this. But let's start by looking at what's going on in the computer. Array buffer underscore info. There we go. And when you do an array buffer info, we're just going to print this out. And we run this. This is going to show us the size of what's going on with our buffer in here. This is our actual operating system address. And then the size is here. It's got a size of 5. So you can actually go in there and you could hard locate this on your computer. Usually we very rarely use something like that, but it's kind of interesting that we can look that up so easily. And when we're manipulating the array, we can simply do print. Here's our array. We'll put our brackets in here, and if we print 2, let me go ahead and run this. And you look at this, we got -1, 2, 3, and it printed 3. And the reason it does that is we always count from 0. So in programming language, you always start 0, 1, 2. And the 2 is going to be the section where it says 3 on there. And if we can print just one object in there, this next one is so basic. The for statement, for I in array. This is a simple iteration. So what this means is we're going to take each value in the array and we're going to do something with it. And in this case, we're going to go ahead and just print it out. So if we want to print out all of the variables, you could go for I in array print I. I want you to notice the difference here is instead of it printing out that this is an array with the values in it, it comes down and just prints each individual value in here. Now this does all of them, but let's say you are looking at this, you say, hey, I don't want to do all of them. We're going to do we'll do pointer instead of I, for pointer in range 5. And instead we're going to print, and here's our array R, and we're going to look up the index pointer. So this is going to print out. Let's just see what this looks like. Here we go. It printed out the same thing. So we have our -1, 2, 3, 4, 5. So it starts at 0, 1, 2, 3, 4, 5 on here. Whoops, 0, 1, 2, 3, 4 on here. That's how this is actually read on here. So if you actually print out the pointer, let's do that. Let's just print out the pointer on here so you can see what's going on. Pointer, comma, R pointer, and let's run that. And you can see that the pointer is 0, 1, 2, 3, 4, so it does not include the 5, and it prints out each value. We can do something like this. We can go 4, and you can see it just drops the bottom one off. And we can even do something like this, range 1 to 4, and it drops the top one off. So by changing your iteration loop, you can change the pointer and pull up any of these values in your array. And another really cool thing we can do, we have our array, we can actually do array reverse. So instead of iterating and creating a new array, we now have functionality in our array just lets us reverse all the different values. And then if we go ahead and print the array, let me go ahead and run that, you'll see that the array is now in reverse 5, 4, 3, 2, -1. And let's just do a quick rehash of what we covered. So we went over here, and we're going to go on more. There's 3 sections to this, or another section or 2. We imported our array, so make sure you always import it. We set our value, so we created array equals array. We have a type, and then we have the values in that type. And if you print it out, you can see that it's an array, type I, -1, 2, 3, 4, and 5. We can look up the buffer info, so we can actually pull out the actual memory location, and then what kind of resources it's using. That's what the 5 represents. And then we came in here, we printed just one value out of it, and we remember that it starts with 0, so we have 0, 1, 2, which prints our 3 position there, our number 3. We learned how to iterate through the whole array for I in ARR, or I in our array, and we just printed the I out. And then we did for pointer in range 1 to 4, we started off with range 5, And you can see here where it goes 1, 2, 3, and it printed out the values that correspond with that pointer. And finally, we went ahead and reversed the array. So we have our r.reverse print r. And then the next step with our array is we want to go ahead and add something onto it. And we do that simply with an append. So here's our append, and we're going to append the value 10. And let's go ahead and print array. And now we have 5, 4, 3, 2, minus 1, 10. So we've added that right onto the end of the array. And we can also, if we're going to append something, we can also remove something. So the simple command is remove. And we're going to remove 2. And then let's go ahead and print that. Print r, run. And you'll see here the value 2 is now missing from the array. So it goes through and it finds number 2 in here. And this leads into an interesting question. What happens if we have 2 values of the same, or 2 2s? There we go. We're going to put in 2 2s. So let's go ahead, and I'm just going to copy this down here and recreate our array. And I'm going to add a second 2 in here. 2, 2. And let's see what happens when we remove the 2 from there. It removes one of the 2. And the way it works is it removes only the first 2 in the list. So when you do the remove value on there, you'd have to rerun this a number of times to get all the different 2s out. Now earlier we did print, here's our r, and we can do position. Let's do position 3. We'll just run that. And position 3 happens to point to 4. What if we wanted to do something in reverse, like print r.index? And I'm going to put the 4 in there, and let's see what happens. It prints 3, which was our pointer. So index does the reverse. And if you remember correctly, when we did, let me go ahead and do, let's just take this whole array and recreate it again. And I'm going to change the index from the 3 to the 2. 3 is actually going to point to one of the 2s, because we have, let's see, 0, 1, 2. So we're going to do index of 2, and let's run that. We have 0, 1, 2, and I did my argument of 2, which is going to come up as 2. But when I did my index, the index is only 1. Why? Because 0, 1. It's going to look at the first 2 in the array. So when you do your index, remember, if there's multiple 2s in that array, it's only going to look at the first 1. And then we'll go ahead and here in front we have our array imported. And let's go ahead and create a new array. This one we're just going to make as an empty array. It's going to be the I. We'll stick with that. And it has no values in it. So that's what this means. And if we print it out, just print our array. We say we just have an array with there's no values in there, nothing coming through. And so we want to go ahead and do on this array is we're going to create an input. And we'll set a variable x equal to, it has to be an integer, so it's going to restrict it. It's going to be an input. And then from our input, we'll give it, let's see, enter size of array. There we go. Enter on this. And then let's do print. What did we do? Let's do it this way. Enter d element x. This is just kind of a fun thing we can set up on here. This has to do with print format on here. So let's take a look at this real quick and see what's going on before we do our print. Let me just take the print out there and let's run this. And of course it helps if I match my brackets correctly. There we go. So we're going to enter the size of array. So this is what this is going to generate. The first one generates our input box. And let's just put a 4 in there just to see what that looks like. And we're going to run that. And so at this point we're not getting anything coming out. Make sure I get all my brackets in the right place there and try it again. So we're going to enter the array 4. I hit the enter key and it's going to print out enter 4 elements. So this is a marker in your print statements for formatting. And it just lets us know we're going to take the x value and we're going to put it in there. And then from here, we're going to do for I in range, in this case x. And this should look familiar from earlier. So we're going to do, if it's in range of x and I enter the number 4 in, it's going to go 0, 1, 2, 3. Always starts at 0 on the range. And we're going to do in equals integer input. There we go. And if you look at this, this is just another input statement. Just like we had integer input, enter size of array. Now I have integer input again. We're not going to do, we can actually do, like have it print something out, but we're just going to leave that blank. I'll show you what that looks like in a second. And we're going to append that new value to our array. And then let's print it out. Let's print out our array. So let's go ahead and take a look and see what this looks like when I run it. Let's create an array of 4, since that seems to be fun, and it says enter 4 elements. So element 1, 2, 3, 4. I hit enter, and we print out our array. We see that I have an array of 1, 2, 3, 4. So I can use a user input just like this, a real simple setup, but allows me to enter the data into the array.
We look into what functions in Python are. So first, let's look at the definition of a function. A function is a set of code that performs some task. So what this essentially means is that you can have a number of instructions which are bundled together in a function that is given a particular name. And now using this name, you can call this function to execute these instructions from anywhere in the program, any number of times. So this is the syntax of a function. You have the keyword def, following which you have the function name and then the double colons. And then in the next line, you can put your statements or your instructions. So that is basically what a function is. We'll go through a number of demos to understand the concepts of functions. So I'll move on to PyCharm. Let's start from the very basic, that is how to create a function. Now, this is called the definition of a function. And as we are creating the definition of the function, the keyword that we begin with is def. That is the short form of definition. And now following def, we have the function name. So here I'm going to have a function called welcome, and always you end your function name with parentheses. Now these parentheses may be empty or may be filled, which we'll look into later. For now, it's empty. And then we have the double colon. So I want this function to just print out good morning. So that is my instruction. And with that, my function welcome is complete. Now this function has no purpose unless it's called. And for that, we write the call statement for our function welcome. So for calling the function, just put in the function name followed by parentheses. Now let's run the code. And as you see here, our call was made to the welcome function and the instruction within it was executed. Thus we have good morning printed out here. So as I said previously, these parentheses here, these could be filled or left empty. We saw what happens when it's left empty. Now let me create another function where I'm taking in values. So sometimes the operation that a function does requires some values to be passed to it. So this is where we have parameters or arguments come in. So now I'm going to write a function called add, which will basically add two numbers. Now these two numbers need to be passed to this function. So the function does not know what these two numbers are until you literally give it the numbers. So these numbers will be stored in variables, say A and B, colon, and within this I'll have a variable, say total, which will hold the sum of A and B. And then we'll just print out the sum. And with that, our add function is also defined. Now we'll make a call to our add function. Add. And now, as you see here, we are accepting two values in this add function. That means we also need to pass two values to this add function. Now suppose I want to add the numbers 10 and 20. I can go ahead and just put the numbers 10 and 20 here. Or I can have two variables, say x, which is equal to 2, and y, which is equal to 3. And then to add, I can just pass x and y. Either of these methods work fine. Now I'll run the program. So as you see here, the add function is called twice. This is our first call to the add function where we pass 10 and 20. So A holds 10 and B holds 20. So the total of this is 30, which is printed out. The sum is 30. Now after this, we have another call to our add function where we are passing x and y, x holding 2 and y holding 3. So over here, when we pass x, we are essentially passing 2, and when we pass y, we are passing 3. Now this 2 and 3 get stored in A and B respectively, and our total is again printed 2 plus 3, which is 5. Now this is one of the main advantages of using function. If I had to write this code total equal to AB twice to add two numbers, that would be a little lengthier procedure than having a function and just making a single line call to the function every time I want to add two numbers. Now as you notice, the values that we are passing to a function are very position dependent. That is, since I'm passing 10 first, 10 goes into my first variable A, and 20, which I'm passing second, goes into my second variable B. Now just to make sure that this is how it works, let me print out the value of A and B separately. So now let me run my program. And as you see here, since 10 was passed first, it's stored in A, and 20, which was passed second, is stored in B. Same here, 2, which was passed first, stored in A, and 3 stored in B. Now what if I don't know whether the function accepts A first or B first? Now in this particular case it does not matter because 10 plus 20 or 20 plus 10 still gives 30. But we still want to ensure that 10 does go into A and 20 does go into B. So let's say our function accepts B and then A. Now we want 10 to go into A, but we don't know that A is the second or the first argument that's accepted in the function. So this is where we have keyword arguments. So with keyword argument, what happens is that since you want 10 to go into A, you can specify here A equal to 10. And you want 20 to go into B, so specify B equal to 20. Now let's run this program. So as you see here, although the function accepts B first and then A, and we passed A first and then B, still the values that are held are correct because we said A should be 10. So 10 went into A and we specify that B should be 20, so 20 went into B. So here we are making our values that we are passing independent of the position of the arguments. So far we passed exactly the number of variables or values that the function is expecting. Now what if, although this function add is expecting 2 values, we only pass 1? I'll just remove this part here and I only pass 10. I run the program and there's an error. Now we don't want this error to happen. So even if we are passing an unknown number of variables, that is we don't know how many variables the function takes, we are just passing values. I want that something happens. It does not result in an error. So in this case what I can do is I can give all the values that I'm accepting a default value. Make this back to A, B. So if the value A is not passed, its default value should be 0. If value B is not passed, the default value should be 0 again. So this is how I set my default values. Now let me run the program. So now as you see, although we only passed 10, it does not result in an error because the first value went into our first argument, A holds 10. And since B has a default value, it's 0 and the sum is 10. Now what if the one who's writing the program does not know how many inputs the user could give, or the user could give variable number of inputs to the function. Now suppose I want this function add to be able to find the sum of 2 numbers or 5 numbers or even 10 numbers. In that case, the argument that the add function would accept could be a list. And as you know, a list can hold any number of values. So now in my call, I can just pass n number of numbers and I'll just delete this line because now we don't have A, B, we have one list A and we want to find the sum of all the elements in this list A. So for this I can use a for loop to iterate through the list. So for I in A and total equal to total plus I, and total needs to have an initial value, so total equal to 0. And let me run this program now. So the sum is 110. So what happens here is we are passing 4 numbers. Now even if I want to pass just one number, that would also be completely acceptable by this function. All these numbers are put into a list and a list can have variable number of values. Now we are using a for loop to iterate through this list and we keep adding each number to our variable total and finally we print out total. So if you are unaware of how many values a function can accept, or you want to provide the function the capability of being able to access variable number of values, you can go for a list. We now move back to a previous version of our program where we are accepting AB, just adding AB and displaying it, and we are passing our values to the add function through our variables x and y. Now we'll make certain modifications here. So x holds 10, y holds 20. We are passing x and y to our function add. Now in add, what if I change the value of a and b? So I say a equal to 2 and b equal to 3. And then I'll also put a print statement here to print out the sum of x and y. Let me run this program now. So the first line of our output, that is the sum is 5, comes from our function add. And add has changed the value of a to 2, b to 3. But now when we are printing the sum outside our function add, it seems like our variables are still holding 10 and 20 and not 2 and 3. That means that the change in the value was reflected on our variables a and b within the function, but then that did not affect our variables x and y. So although we are passing the value of x and y to a function add, and a is holding the value of x initially and b is holding the value of y initially, are a and x essentially different? That is, does a hold a different memory space and x hold a different memory space? So let's find this out. Let's print out their addresses. So here, after we created x and y, let's print out the address of x and y. Then within our function, before we actually change the values of a and b, let's print out the addresses of a and b. And after we change the values, let's again print out the address. I'm running the program. So when you look at the IDs here, our first line of output, which is the ID for x and y, comes from here. Our second IDs come from this line here. And our third line of IDs comes from here. So our first line prints out the ID of x and y, which is exactly the same as our ID for a and b within the function. But then again, after our values of a and b are changed, the ID differs. So the ID here printed out in this line is different from the ID printed out in this line. So what this means is that x and y is actually passed to a and b. A and b and x and y are holding the same memory location. But the minute you change the value of a and b, the location also changes. So this kind of a passing from the call to the definition is called call by reference. So call by reference is when you're actually passing the object and not just a pointer to the object. So you're not passing the value of x and y, you're passing x and y to AB, which is why the ID here, that is the ID of x and y, is exactly the same as the ID of a and b. But once you change the value within the function, this is not reflected back in x. What Python does, it creates two new objects a and b, and the values are then put into these. Now we know that integer strings and most other things in Python are immutable. So this might be why we have new objects being created every time we are trying to change their values. So what if we pass something that is mutable and try to make a change to this? As we know, lists are mutable. So now let's pass a list to our function and try to change the value in the list within our function and see if this is reflected back on the original list. So I'll just delete all of this. Although we won't be using the function to add anything right now, let's leave the name of the function at add. Now I'm passing lst list to my function add, and then I say lst of 2 equal to 0. And outside my function, I'll first create my LST. So that is 0, 1, 2 are my three values. Then I'll call add and I'll pass LST to it. Since we have no print statement, there's no output. So I'll have a print statement here, LST. And I'll also have a print statement before the call. So again, print LST, run the program. So as you see here, the first time we created our list, the values we gave for it are 0, 1, 2. So this is what's printed in this line here. Then we made a call to our add function. And in our add function, we changed the value of the element in the second index position or the third element of the list. We changed that to 0. And when we printed the value of LST even outside our function, this change was reflected in our original list. So it printed 0, 1, 0 and not 0, 1, 2. So with this, we come to a conclusion that with integers, we were creating new objects every time we wanted to change the value because integers are immutable. But with lists, since they are mutable, the changes are reflected back in the original object. So we are back to our basic program of the add function accepting two values a and b, finding their total and printing it out. Now what if we don't want total to be printed within the add function? So the add function's like, sure, I'll do the operations, but I do not want to give the output right here. So in this case, what we want, so the add function should be able to somehow send the value of total back to this line of call, and then we can print out the value of total. So first of all, add will not print the value of total anymore. Add will instead return the value of total to its call. So for this, we use the keyword return followed by the value that it's going to return, which is total in our case. And the line where we are making the call, this is the same line where the value will be returned. So now we need a variable here which will hold the returned value. So let me say sum, which is our variable. So result is a variable which will hold the return value of our function add. And then over here we can print out result. Let's run this code and that worked perfectly fine. So I'll explain this flow once again. Execution starts from this line here. The result equal to add 10, 20. First add of 10, 20 is called. So the add function is called a holds 10, b holds 20 and the total is calculated. Then this function returns this value total to the calling line. So this is our call line and we have a variable here result which will hold the returned value. Then we use this variable, we just print out the value. Today we'll cover what objects and classes in Python are. So previously we saw that Python is an object-oriented programming language. So what this means is that Python is completely focused around the presence of an object. And this is why we will stress more today on what this object actually means and what classes are in relation to objects. So let's begin. First, we look at what an object is. So in the real world, everything tangible is an object. The table, the chair, your mobile phone, your laptop, even you are an object. And in the similar manner, in Python, since you're focusing so much on an object and programming around object, so every instance in Python is an object. Now, if that is what an object is, what is a class? A class is a blueprint of similar objects. So you'll have multiple objects in programming often, and all these objects have some similar features. So a class basically holds all these objects together and gives them a common definition. Now let's better understand this through an example. So here we are considering person as a class. Now if person's a class, every person has certain features, that is name, gender, age. Irrespective of who the person is, the person has to have these features. So this is something common shared by all the people. Now a person also has a behavior. And behavior basically means the functions a person is entitled to perform. So obviously there are a number of things that a person can do. But in this particular case, we look at just two of them, which is talk and vote. Definitely there are some exceptions which we'll not dwell into right now. So now that we saw what features and what behavior are and how person, which is a class, describes these things, let's look at what an object would look like under this class person. So here we have two objects of the class person. Our first object, which is on your left hand side, has the features name, gender, age, and the behavior talk and vote. Now every object has to have these features because these are what's defined under the class person. And in a similar manner, the object that's defined to your right also have the same features and the same behaviors. Now what is it that makes these two objects two separate entities then? It's the value of the features. So our features, name, gender, age, in either case has a different value. For example, our first object has the name Sam. Our second object has the name Mia. Gender is male, and for our second object, gender is female. Age is also a different value for both our objects. Now they could have the same value. That is, there could be some common features, but if all of them have the same value, that wouldn't make sense. They wouldn't make them two separate objects. So to summarize this, person is a class and the class defines the features name, gender and age. It defines behaviors, talk and vote. And then we defined two separate objects and gave value to the features in these objects. Now let's begin to code this example. So I'll move on to PyCharm. First thing first, let's create our class. So our class is created using the keyword class and then put down the name of your class, which in our case is person, followed by colon and enter. So your class is created. Now once that your class is created, the next thing we need to focus on are the features that this class defines. So the person class defines the features name, age and gender. Now in our previous video on oops, we saw that the features or the members of a class are defined using a constructor usually. So let's create our constructor, which is def init. And once you click on init, the self parameter automatically appears. Self basically refers to the object that you're passing to this constructor or the object that is being created when the constructor is called. Now we'll give value to our three features. So our features are name, and that will have the value, say Sam, gender, male, and age 22. Now one thing that we're missing out here is that we need to remember that name, gender, age, all these are features of the class. That means these features are strictly tied to an object. That would be the object that's created when this init function is called for that particular time. So the reference to that object would be stored in self. Therefore, we won't just write name equal to Sam, but instead self.name equal to Sam. And in a similar manner, self.gender and self.age. So we have defined our features of the class person and also given it value. Now next thing is we have to define the behaviors. So behaviors are implemented through functions, or we can say methods. So methods are basically functions, but the functions which are called through an object or tied to an object are called methods. So let's define our methods. Our first behavior is the talk behavior. So if the talk method is called, we just want to print out hi, I am, and the value of the name attribute of the object that's calling talk. Now our next behavior to be implemented is the vote behavior. So for that we'll create a method vote, and here we'll put in a condition. So if the age of the person is less than 18, the person's not eligible to vote. So we'll print this out, and if the person is above 18, then we'll print out that the person is eligible to vote. So if self.age is less than equal to 18, I am not eligible to vote. Actually less than 18. If the person is 18, they are eligible to vote. Else print I am eligible to vote. So the two behaviors of the class person are implemented through methods now. Now all that's left for us to do is to create the actual object. So how do you create the object? If my object name is obj, I'll write obj equal to and then put in the type of the object. And the type of our object is of course the class. Now here's something that you need to understand. Everything that you create in Python is actually an object. So I'll explain this a little more in my console. So if I have a variable say a and I give this variable the value 100. We know that 100 is an integer type value. Therefore that makes a an integer type variable. But then if I check the type of this variable, it shows class int. That means the type of a is the integer class, which makes a an object. In the similar manner, if I have another value to a, say Simplilearn, and now if I check the type of a, we'll see that a is now an object of class string. str is basically the short form of string. Therefore, everything in Python is an object of some class. And that is how our object here, obj, is an object of the type person, where person is our class. So now that we have created an object, during this creation of the object, our constructor will be called and the features of this object will be given some value. Now we can use this object to call its behaviors. So this can be done either in this manner. So you put in person, which is the type of our object, dot the method, and within the brackets as a parameter, you can pass the object. In the similar manner, we'll also call our behavior vote and again pass obj within it. Now let's run this code. Just pull up my console here. Run the program, and as you can see here, so we created an object and the object got its values as mentioned in the constructor that is in it, and then we called the talk behavior or the talk method using our object obj, and this printed our first line, which is hi, I am Sam. And then we call the vote behavior, and in the vote behavior the age of our object was checked. Since our object's age was greater than 18, it says I'm eligible to vote. Now these two lines where we are calling our methods can be done in a different way. Instead of calling it with the type of our object and then passing our object, we can directly call it with our object. So we can have it in this way, obj.talkOf. And over here, obj.voteOf. So we must remember that in this particular case, where we are creating classes and objects and have this kind of a structure, all these methods are actually tied to the object, which is why we cannot just say talkOf. We need an object to call it, or at least pass an object to this method. Let's run the code now. So it's the exact same result, works just fine. Now in this case, we just created one object and the values for this object were predetermined and just put in our constructor. Now what if we want to create two separate objects and the values for these objects vary? So in this case, so to demonstrate this, we'll create two objects just like in our example previously. We'll have our first object, which is obj1. Now both these objects will be, of course, of the type person, which is our class. So put that there. Now every time the object is created, automatically our init method is called. So if our object needs to have separate values, what we can do is instead of putting in predetermined values here, we can pass the values for the features of the object in the brackets. So if I want my name to be Sam, I'll pass Sam, my gender, and the age. So these are the three values for the three features that this object has, which we'll pass into the constructor or the init method. Now in the init method, we need to be able to accept these values. So other than self, we'll have one variable which will store the value of the name when it's passed from here. We'll store it in variable n for name, and the gender we'll store it in variable g, age we'll store in variable a. So what happens here is basically these values that you pass within the parentheses when you're creating your object are sent to your init method. Now in the init method, we are putting down these three variables to accept the values. So these three variables store these three values. So Sam goes to n, male goes to g, and 22 goes into a. Now instead of putting in the strings here, self.name can be equal to n. So the value which n got is now put into self.name. And the value which g received is put into self.gender, and the value which a received will be put into self.age. So that way we created our object and provided a way in which we can actually have unique values for each object. So now if we have another object, say obj2, which is also of the type person, we can put in different values into these parentheses. So say our second object's name is Jessie. She's female and 16 years old. So now these values will go into these variables and will be assigned to these features. So for obj1, if I say obj1.name, the name would be Sam. If I say obj2.name, it would result in Jessie. We'll see that now. Let me just print that out. obj1.name and obj2.name. So as you see, although our feature is the same, we are printing the feature name in both the cases. The object to which this feature is tied is different. So the first time it's printing name related to object 1, and the second time it's printing the name related to object 2. Now this is not what we want to show here. Here what we want to do is after creating our two objects, we'll call the methods using these objects. So obj1.talkOf and obj1.voteOf. Now we'll call the same two methods using obj2. So obj2.talkOf and obj2.voteOf. Run the program and here's our output. So what happened here is obj1 was created and the three features which are name, gender and age were given the respective values for obj1, and in the similar manner obj2 also received the values for its various features. Now we used obj1 to call our two methods talk and vote. At talk, all we did is print our name of the object. So the first time when we called with obj1, it printed hi, I am Sam, because Sam was the name related to our first object. And then we call the vote method using obj1 itself. So our first object's age was 22, which means it's eligible to vote, and that is what's printed here. I am eligible to vote. Then we call the same two methods using obj2 and got different results. So obj2's name was printed here, which is Jessie, and then Jessie is underage, that is she is 16. So it printed out I'm not eligible to vote when obj2.vote was called. So that is the basic crux of what objects and classes are.
In this, we're going to cover a basic understanding of object-oriented programming, and we'll be specifically working in the Python interface, or the Python code. Oops, the basic concept, is not the accident you just had or the mistake you just knocked your coffee cup over off your desk, but it actually stands for object-oriented programming. And whether you're working in Python, which we'll be doing today, or in any scripting language, almost all of them rely on object-oriented programming as their basis. Programming paradigm that focuses on objects. So everything is an object in the coding. Every instance in Python is an object. And again, this is true for any of the main programming languages. If you're working in Java or Scala or any of these, you're going to be looking at object-oriented programming. It just makes a lot of sense and really is one of the cornerstones of today's programming. And when we talk about object in programming, an object has two different things. It has two different things: attributes, which is data describing the object, and behavior, methods on the attributes. So the first one is your actual data, and the second is what are you doing to that data. And if you're a car lover, we're going to use cars as an example. This is kind of easy to see how that might fit into the different objects. And so we're going to start with a BMW, for example. That's an object. And with the BMW, you might have like the year of the manufacturer, maximum speed. Those would be attributes of that car. And then you have the behavior. These are methods on the attributes. For example, you might display the speed or change the speed. So even though you have a maximum speed, you might have current speed also, which changes depending on what you want it to do. Step on the accelerator, go faster. Step on the brakes, go slower. And the primary terminology in programming is usually class, and that's definitely true in Python. So class is a collection of similar objects. And in this example, we have cars are class. So you might have trucks, bicycles, and airplanes. But in cars, we have some very specific things. Cars have 4 wheels that are on the ground, maybe a spare hanging down, headlights, steering wheel, things you would expect in a car. Doors to get in, so it's all inside. And in here we actually have a number in the collection. We have our BMW, our Ford, our Audi. You can guess the guys in the back like the BMW the best. I don't blame them. And so we work with classes or a collection of items. Today I'm going to use the user interface PyCharm. It's one of the very popular Python editor. I myself have never used it, so this is a new experience for me. It's pleasantly fun to use and easy to set up. You can go to jetbrains.com. That's the people behind it. So www.jetbrains.com/PyCharm/. And once you're on the PyCharm, if you go under downloads, you'll have 2 options. Let me just hit the download now button. I'll take you to the 2 options. One is the professional, which you would pay for, which allows integration between teams and company setup and has a bunch of extra cool tools that you need for a business. And then there's a community version, which is the lighter weight one. For the purposes of this demo and most of the work you do, the community one's probably just fine. You can download it. It's open source and it's free. I don't know about you, but I like open source and free on a lot of my stuff. And I've already opened up a project file, but you can create a new project file up here. Put a note down in the YouTube and they can send you some of this code, or go visit Simplilearn. They'll send you the code itself if you need it. There's a lot of different, like I said, functionality in here. We're both mostly going to be underneath just run the demo. In this case, I'm doing Simplilearn, so we'll just be running what I'm working in here. Let's go ahead and start with creating a class in Python. And you simply just tell it it's a class. So the class means this is going to be our Python template, whatever we are working on. I'll call this car. And this is interesting because class itself, let me just highlight that. So when I put up class here, that is a Python object, and then I'm using that to build car, my class, specifically on here. And let me go ahead and just change that font. I have it pretty large already in my editor. Let's go back down here to editor, font, and I put it up all the way to 26. I think we can get it by with 30 so you can really see it. Hopefully that's going to be big enough on there. And so once we have our class, we want it to do something. And so in a class, when you put the words def, that stands for definition, whatever that's called, that is a function. It's going to actually do something on there. And you'll see what I like about this is nice. With PyCharm, it automatically puts self in there. Why? Because self refers to whatever the object is. Now, it doesn't refer to the template class car. It refers to the instance of that. And I'll show you in a minute what that exactly means. But in this case, we're going to do something simple. We're just going to have it print. And you can see it automatically indents it. So Python, if you remember, or if you're new to Python, is based on indentations. You have to indent. So everything under this indent is part of the def. Everything under class that's indented is part of the class. And so we're just going to look down at our speedometer, and we're going to print 155 miles per hour. Maybe it's on the Autobahn in Europe, I don't know, racetrack. Not very often you go 155 miles an hour in a car, at least not in my experience. Maybe in the future we have auto cars that do hundreds of miles per hour and shoot down the freeways. And let's go ahead and create an instance of the class, and we'll simply do BMW equals car. And we'll put brackets on there. And let's also do, let's do a Ford. Ford equals car. So if you remember, car is like a template. It's still an object. So I have BMW equals car, and I have Ford equals car. These are two separate instances. So they're copying, or they're actually putting a pointer to car. So everything under car is part of BMW. And the same thing with Ford. And we can do something like this. We can go car dot get speed, and let's put in the BMW there. Or we could also do car dot get speed Ford. Given the choice, I think I'd go with the BMW. And there's another way you can do this. We can also do BMW dot get, because remember it points back to the original template, so all the functionality is in the original template. And then we could also do Ford dot get speed. These are a little bit more common, more than you'll see the top part. But let's go ahead and run this. And if we go under Run, we find out that Alt-Shift-F10, you can use the hotkeys, which I'll probably start doing. And I just simply hit, make sure I highlight the one I'm working on, and it runs it down here. And so you can see right here we have 155 miles per hour printed out by the BMW, 155 miles out printed by the Ford, car get speed, and then I did it in a different format, BMW.getSpeed and Ford.getSpeed. The thing to notice is the term self. That is a Python term, which means that when we create an instance, whatever comes in here is what's being processed. And so if I call the class or the template directly, in this case I did car get speed, I have to include what that self is. In this case it's a BMW. Or if I'm calling it from the instance BMW, because it includes the car class, it knows that get speed, and it knows automatically that this is self. And that's where the term self comes in. So that's important to note in there. In Python, that's one of the more Pythonic kind of solutions, is that when you see the term self, that refers to that instance that you created. In this case, the BMW instance and the Ford instance. When you're setting up a class, there's a lot of things you can do in here. There is a key term init. What this means is that when I create the new instance, whatever happens in here is going to be set. This sets up your information. Let me show you how that works. And what we're going to do is we're going to pass year and speed in here. And this is really important, is I need to take self, that's going to be the new instance I created. In this example, it'll be our BMW and our Ford. And put a period here, and then year equals year. That's the variable that was passed. And we'll do the same thing with speed. Self.speed equals speed. So when we create this, we now have two different variables in here. And if you remember from our slide, an object has attributes, data describing the object, and a behavior, methods on the object. And so in our class or our template, we're going to initialize it with the year and the speed on here. But if we initialize it here, when we create the instance, we have to send that information so that it knows what the year is and what the speed is for the BMW and the Ford. And that means when we create this instance, let's go ahead and do 2018. Maybe this is the maximum speed that shows up on the speedometer, I don't know. But 2018, and we'll put it at 155 miles per hour. And then we'll take the Ford, a little bit older, runs a little slower. It's a 2016. And this will be the maximum speed. We'll do 140 miles per hour. That's the fastest it can go. And then, so now we've set up some data on our object right here coming through. And so BMW now has a year and a speed, and so does forward. And when we get speed, let's go ahead and change this. And in fact, I'm going to do, let's just get rid of this middle part, because I tend to do the standard bmw.getSpeed. And we'll call this maximum speed. Maximum speed is, and then we'll just put down self speed. So that's our variable. So that's whatever the instance is. So self speed is going to refer to our BMW or our Ford. And if we go ahead and run this, and that was, we can go up here to run and Alt-Shift F10. I'm just going to do Alt-Shift F10. It's already set to the tab I'm on. Hit enter. And we come down here and you can see had an error there. This is a double underline for the init. The code that they sent me had just a single, and I forgot to double check that. So we have a double underline init. It comes in year and speed. The BMW has 2018 with a maximum speed of 155. And when we print that out, BMW get speed, you'll see it right here. The maximum speed is 155. And then it does it for the Ford. Maximum speed is 140. And then we're done processing it. So we stored some data in here. We stored the year, we stored the speed, and then we've had a process on that data, and that is to go ahead and just print it out. Print out the self.speed. And let's go ahead and briefly look at encapsulation. Def set speed self speed. So we're going to send it a new speed value to set the speed. And from here we'll go ahead and do self.speed equals speed. And we'll just work with the BMW on this one. Let's take the Ford out of there for a moment. And we have our Ford get speed. And then we're going to set the speed. And the new speed is going to be, let's make it 143. Just an odd number so it's easy to see. And then we'll go ahead and do bmw.get speed. And when we go ahead and run this, I'll do the Alt-Shift F10 and run it. As you can see here, it comes out and it says 155, because that's what the speed was when we first entered it. And then we went ahead and changed it. bmw.setSpeed, and is now 143. So you can see here how we can alter the information in our template. And if we remember, we had the Ford is completely separate from this. So if we still had Ford down here equals car 2016, 140. If we still had that down here, this 143 isn't going to affect the Ford at all, because this Ford instance is separate from the BMW. So if I do Ford.getSpeed, and we do an Alt-Shift F10 to run it, there we go. Here's our Ford, 140. So it hasn't changed even though we set the speed on the BMW to 143. The first thing we want to look at is inheritance. And so inheritance is a mechanism for a new class to use the features of another class. And if you've ever done like word processing, you might use a template. From that template, you can have all kinds of stuff you put into the template, and you can save it in different instances depending on what you're doing. And then those particular instances you saved could be used as a template for your next thing. I use that all the time. When I was in sales, I'd do some sales on the side as part of my job, working with them to support them and build the software for them. We'd put together a document, and then we'd take that document and that'd become the template for the next 3 documents that are very similar. This is the same way. You have a class, and from that class we can inherit everything from there and then make changes on it. And then we're going to go ahead and cover, let's do this. Ford BMW, just close that up. Take this out of here for now. Okay, let's go ahead and do inheritance. That's where we're going to take the class car, and we're going to bring all these features from class car into a new template or a new class. And let's start with a class sedan. And the sedan is going to inherit from car. So it's going to bring car in, and now we have a sedan coming down. Once we create the sedan, this is now a child class to car coming down. And under this class, I'll just go ahead and we'll just type in a def accelerate. Of course, self. And on here, we're just going to have it print. And let's have it do 150. That seems like very high. Let's go 133, just because. I don't know why I like the 133. Let's change it to 137. There we go. And then let's do another one here. We'll do this class SUV, and it also is going to inherit from car. And this too is a child class of car, so we'll just put a label there so we can remember that. And we'll also give it an accelerate. And when we do an accelerate, keep the self. and we'll print, let's see, this year, whatever production is 180. I don't know why. That seems awfully high for an SUV versus a sedan. Let's do 127. The SUV goes a little bit slower than the sedan. There we go. So let's go ahead and hit enter on there. And let's take a look at what we got going here. I have my BMW. I have my Ford. And let's add a Honda, and we're going to make it equal to the sedan. And just for fun, let's add one more thing. Def, open, trunk, self, and we'll put print, trunk has been opened. There we go. So let's take a look and see what we got going here. I've created my Honda. And if you remember up above, we have our BMW. And I'll just do just the BMW. Get speed. And then I want to do the Honda. Get speed. And when we run this, we can see our BMW is 155. And our maximum speed on our Honda is 150, because that's what we set. Now remember, this inherited it from cars. So this init is now part of the sedan. The open trunk, if we do this, if I go the other way around, let's say, oh, let's do this. Let's do the Honda open trunk. And then we'll do, just to throw an error here. This is going to give us an error. It doesn't even auto type it for me. So we'll do Alt-Shift F10 and run it. And you can see down here is that we had our BMW get speed. Okay, there's our 155. We had our Honda get speed. We had our Honda open the trunk. And because our car, when we go up here to car, does not have open trunk, the BMW does not have that definition. So it gives us an error. So we can't do that unless we add that to the top as part of a car. It just turns out, though, that, let me just take the BMW out. For whatever reason, this BMW doesn't have a trunk. I think they all have trunks, but that's okay. For this example, we'll just leave it like that. So you can see right here, we've inherited, and then we've gone ahead and added new features to our new class. So this child class of sedan has come in here. Now it has both accelerate, open trunk. The SUV, which we're going to look at in just a second, also has open trunk. So we've had a lot of functionality. We have our original car template, so whatever's set up here comes down here. And then we've added both accelerate. Let me just do that right here, our Honda. We can accelerate the Honda. And if we run that, you can see the Honda has their acceleration come in and prints out. In this case, 137 down here. That's why I like to mark it with a weird number like 137, so you can tell the difference where we're going. So we have our accelerate. So we've added features into our sedan. Encapsulation is an important feature, preventing data from direct access. This is what we call encapsulation. We'll discuss that more later on, but what it means in this particular case is that when you create a class from another class, you can't alter the original template. The child class can make all its own changes to that class and do all kinds of things, but it can't make any direct changes to the parent. Let's go ahead and take a look at encapsulation in the code itself so we can have a better idea of what we're talking about. So we have our class car, and we have our definitions. Here's our init. This is from, if you remember from the last slide, we had our init. Maybe we add a couple more functions to it or modules to it, and we have get speed and set speed. All of this under class car is encapsulated. What that means is that if I create an instance of it, in this case I'm going to create a BMW. Wouldn't that be nice if I can just whip out a BMW and make a BMW? When we create our instance BMW, it does not change the class car. This, whatever we do to this instance, does not make changes to our class. And the same thing with the Ford. The BMW does a get speed. It might do something here in the definitions under the class, but the initial class, if I create another car, let's say we take our BMW and we set the speed for 155 like we did here, and we create a Ford, whatever I do with the Ford does not change the class car. And if I create, like we did before with our inheritance, a subclass, that's not going to change the class car. That's what they call encapsulate. It bundles things together, and it really is central to OOPS, object-oriented programming. Is we're basically bundling things together, and then we keep them in a nice safe bundle. And anything we do from that, we either point to it and say, hey, let's use this definition, or we make a copy of it. So we kind of do a combination of there and say, okay, here's our new inheritance. But you can see right here, this is encapsulation. And again, that's like central to OOPS. This is how OOPS was originally discovered, created, and founded, is when they realized, hey, why don't we just bundle things together instead of rewriting the code over and over and over? And then polymorphism. We talked about encapsulation in classes just recently. Like I said, we'll go in this and when we open up the code. Polymorphism is we take the feature in the code and then we can alter that feature. So we can use the same function in multiple ways. That's a lot of fun, a lot of power in that. Let's go ahead and take our polymorphism and take a look at it, what's going on in the actual code when we're writing our Python code. So here we have our parent class, car, and we switch colors. Here we have a sedan, where we inherited the car, and an SUV, also an inheritance. And when we look at this, we have up here our init. So let me just so we have our definition, we're initializing it. The first class, we've added in accelerate. So what that means is with our acceleration, that's not part of the initial car class right now until we add it in. So we have our definition accelerate, which print 150 miles per hour. So all sedans have a print of 150 when you do accelerate. All other cars don't have anything going on in them right now. And then with SUV, we're going to define the accelerate differently. So we have the accelerate down here with self print 180. So we have two different polymorphs going on here. We have one polymorph going on in this example. We've added accelerate to both of these classes. And so it doesn't matter which one I accelerate, it's going to do something. And so if we create, in this case, we're going to create an object down here, an instance of it. Do this in pink. Here's our instances. Oop, that's a little light. Let's do something a little darker than that one. There we go. So we have our instances, and we're going to create one object, which is a sedan, a Camry, and one object, which is an SUV Scorpio. And then we can just go through the objects. We can actually just loop through the objects, one object at a time. And if we do print object name and end, we have our object name. So it's going to print the name. In this case, it'll print Camry and it'll print Scorpio. And then we have object accelerate. And for the sedan, since that's our Camry, it's going to print the 150. And for the SUV, it's going to print 180 for the Scorpio. And so by doing this, we polymorph the same definition to do two different things depending on what our child class is. So we can polymorph all kinds of things, and we'll actually look at a couple more objects in there when you go through the full code later on. There's a couple more examples in this. But this is a polymorphism coming down, and you can see how we're able to leverage the same name for the definition to do different things depending on what our object is.
Today we'll look into threading in Python. So before we jump into what threading is, let's have a look at what a process is, because that is a core concept that you need to understand before you understand threads. So a process is an executable instance of a computer program. That means anything that is running on your computer is actually a process. So a WordPad that's opened, a mail that you're sending, anything that's running, that's working could be a process. Now that we know what a process is, let's look at what a thread is. Now a thread exists within the process. So the definition of a thread is that it's a sequence of instructions in a program that can be executed independently of the remaining program. So if we write a large program, of course there are many small tasks that the program performs. Now each of these small tasks can be a thread as long as their execution is independent of the execution of the other tasks. But then why do we need threads? So consider your system. Now these days we all use multi-core processors. That is, we have multiple cores in our system. Now the point of threading is to make the maximum utilization of these cores. So if one program would run on a single thread, that means it would utilize just that one CPU or that one core. But if we can divide a program into multiple threads and have each of these threads use a different CPU, our program would execute much faster and it would be way more efficient. So this is why we use threads. So now let's look at threading in Python through some demos. So first let's look at the most basic and the simplest way of creating a thread. I have a function here, show, and this function will just print this is a child thread, as we are going to have the child thread execute this function. So first thing, we need to create our thread. Now before we create the thread, let's import the threading package. So we have included everything from the threading package. Now we'll use the thread of method to create our thread, which will be called T. And to this method thread of, we'll pass the target of our thread. That is basically the task that our thread will be performing, which in this particular case is the show of function. So you say target. So we set target's value equal to show, our function show. And now outside here, we'll just print this is the parent thread. So I'll just explain in general how a thread works. Now the minute you write a program and you start running it, there's a thread created. Now this default thread that is created is called the parent thread. So the execution of your program is performed on the parent thread unless you explicitly create a separate thread. So if we had not created this thread here, our entire program would be run on the main thread like every other program is. But now that we created a thread here, this thread, that is T, will run only this show off function because that is the target of this particular thread. And everything else in the program will be run on the parent thread, which is why we have this print statement here saying this is the parent thread, because this print statement is not within the show off function and hence it will be run by the parent thread. Now so far we have only created the thread though. So we need to start this thread, and to start a thread, use the thread name followed by dot and you call the start off method. So the start off method belongs to the thread class, and as you have probably noticed already, our thread here T is an object of the thread class. So once you say t.start, the target function of this particular thread is run, which in our case is show. Now I'll run this program, pull this up here. And as you can see, first we have our child thread executed and then we have the parent thread executed. Now let's look at the second way that you can create a thread, which is by importing the thread class. So you still need your threading package. And I'll create a class, myThread, which is a user-defined class. So I'll be defining this class, and this class will now be a subchild of the thread class. Now the thread class already exists. It's a predefined class, and we're extending this thread class into our class myThread class. What this does is all the properties of the thread class is now present within our myThread class. Now within the myThread class, I'll be creating a function def run, within which I'll just print this is a child class, say 5 times using the for loop. And outside here, I'll create my thread. So now that our class myThread has extended the thread class, we can create an object for myThread, and that by itself would be a thread. So T is my object of myThread, which would also be the thread. Now if you notice here, I'm not passing any target. So this is because when you don't pass any target, by default, your thread will call the run function. So it'll come here and it'll execute this function. So the thread class has a blueprint of the run function, and every thread that is created as an object of the thread class is designed to call this run function by default. So what we do here in our myThread class is we redefine this run function for our purpose. Now, of course, you need to start your thread, and outside here, which is the part that will be executed by my main thread, I'll just print out this is the main thread, and let's run this code. So we'll just add the new lines. So here there's child class, main thread, main thread, main thread, so on, and then we are back to child class. So if you're wondering why this kind of a mix-up is happening, I'll explain that to you. Now our entire program was initially planned to be run on the main thread, but we created a child thread here, which is T, and made the child thread take care of the execution of this def run, of this function run. Now while our thread, our child thread T, was executing this for loop, and between that gap of printing this out and moving to the next iteration, our main thread was completely idle. So the main thread took up this time to start printing out this for loop. And that is why you have this mix up of child class and the main thread printouts. And now we'll have a look at the third way you can create a thread. This time we'll not be extending the thread class. So I'll have a class, say demo, within which I'll have a function show. And within this function, I'll print out this is the child thread 5 times using the for loop. Now outside here, I'll create an object of my class demo. And now I'll create a thread, which is basically an object of the thread class. And to this, I'll pass the target just like we did previously. But this time, because a function exists within a class, we'll refer to the function with an object. So we have a reference now. And once that's done, back to starting our thread. And outside here, I'll print out this is the parent thread 5 times using the for loop. Let me run this code now. So you can see the output here. We have this is a child thread printed 5 times and then 5 times of the parent thread. Now Python can be quite deceiving. So now that we looked at what thread is and how threading works in Python exactly, we can move on to multi-threading. So multi-threading is a model where you have multiple threads within a process and all these threads can execute independent of one another, but they are also sharing all the resources of the process. So by the resources of the process, we could mean the various data that the process holds, the files or the stacks and so on. Now all the threads that are taking care of the execution of this process will share these resources, but they will be independent of each other's execution too. So let's look at multi-threading through an example. Here we'll write a program where we want to print out in the first line a number, say 1, followed by the double of the number and then the square of the number. Now we want these three statements to be printed for every number from 1 to 5. So what we'll be first doing is we'll have a class, and within this class we'll have three functions where each function is responsible for one of the following, which is printing the number, printing the double of the number and printing the square of the number. So let's begin writing our code. Since we'll be using threads here, the first thing we do is we'll import our thread package, name my class demo, and within this I'll start defining my functions. So my first function is def_num, and this function will just be printing out the number. So we want all the numbers from 1 up till 5. So that's all our first function is. Now our second function, which is for printing out the double of the number, 2 into I. And finally our third function where we'll be printing out the square of the number. So now we have the three functions. Now here's our challenge. We want one iteration of every function to happen one by one. So what I mean is for I in range 1 to 6, in our function def_num, we want the number is 1 to be printed, and then immediately after that we need to move on to the first iteration of our function square. Now for this kind of an execution, of course we need three different child threads, and each thread will take the responsibility for execution of one of these functions. So we'll create our threads down here, but before that, first of all we need to create an object of our class demo. And now we'll create our threads, my second thread. And while we are creating our threads, we also need to specify the target. So T1 is responsible for execution of the num function. T2 will take care of the execution of the double, and T3 for square. So we have created our threads. Now we need to run these threads, or we need to start these threads. So for that, we have T1.startOff, T2.startOff, and T3.startOff. Now we need to end these threads, or we need to make sure that the program does not terminate until these threads have completed their work. So for that we use the join function. And out here, which will be run by the main thread, we'll just print out this is the main thread. And that's all it is. That's our program. So everything in this program was initially meant to be run by the main thread, but since we created our child threads, the main thread is responsible for running only this much of the program. Now T1, T2, T3 will take care of the execution of these functions respectively. Now let's run this program. Well, we are not getting what we expected. All these iterations are being completed in blocks. So the first function is completing itself first, followed by the second function. But now in between the second function, the third function also started printing. And this is a complete mix-up. So how do we fix this? Now the first thing we need to see is, as we saw in context switching, we cannot completely predict the order in which these print statements will be carried out, or the order in which the threads would be executing. So what's happening here is while double was printing this, while the thread, that is T2, which is doing the execution of double function, was printing this, there was some time where T2 went into an idle mode, and during this time T3 started printing. So how can we fix this? So first of all, to prevent this kind of an output, where a print statement is printing something out, but then it stops for a while and another thread takes on the execution, and the previous thread was not able to print it correctly. So to prevent this, what we can do is we can have a sleep function on each of these threads. So for that, first I'll import the time package. Now what the sleep function does is it basically puts that particular thread into sleep or an idle mode for the amount of time that we specify in seconds. So if I say time.sleep of 1, it holds this particular thread, which is T1, at sleep for 1 second, and during this time we expect T2 to begin its execution. Now once T2 has finished one iteration, let's put T2 also into sleep for 1 second. And we hope that during this 1 second of hold for T2, T3's first execution will take place. So we put here time.sleep of 1. After the execution of T3, now T3 is put into hold, and again we can start off with T1 second execution or T1 second iteration, followed by T2, then T3, and so on. So this too has not fixed our problem. There's still a mix-up of statements. Now if you see the statements here, you'll notice that this mainly occurred because your second thread started before the completion of the previous thread. So in that case, our problem's not with the child threads, but in fact in the main thread. So what if I put a sleep for the main thread after every thread has started its execution? And even after T2, put a sleep. Now since I'm putting a sleep of 0.2 seconds, during this time we can ensure that the previous thread has completed at least printing out one complete statement, and the printout is not halted or is not interrupted by the second thread's process. Now let's run our program once again. See if it worked this time. And yeah, it did. So once we put sleep on our main thread, we kind of had a control over how our threads are starting. We saw that the output that we wanted is exactly what we got. So this is how threads work and how you can control threads using time.sleep function. And that is pretty much all the basics about threading. Python scripting. So what is scripting? Scripting is writing programs to automate a task. And Python by itself is a scripting language. So what this means is that the lines that you write, the code lines, they are interpreted rather than compiled. So they are executed at runtime. So in this tutorial, we look at a few libraries which demonstrate the scripting feature of Python very clearly. Other than that, we'll also look at a few libraries which demonstrate its runtime behavior. So let's begin. I'll be coding on PyCharm today, and the first library that we look into is the OS library, which stands for operating system. So to use the OS library, first we need to import it. So say import OS. Now in here, I'll have two functions. I'll just demonstrate two of the most common functions that you can utilize from the OS library. First one is to extract the current working directory. Create a function, and I'll have a variable CWD, which stands for current working directory. Now this variable will store the return value from a function which retrieves the current working library. So you say os.getCWD, and that is it. One line, and you have your present directory stored in a variable CWD. So I'll print this out, and that's our first function. So out here, I'll call the function. So now we can run our program. So this is our current directory. You can see the users within the user, my particular username, and PyCharm projects /demo is this particular project under PyCharm. Okay, so that is our first function. Let's have a look at the second one. Now I'll demonstrate how you can retrieve the path of a particular file. So create another function here, and to this function, I'll pass a file name. Now in here, have another variable, I say path, which holds the value of the path that this file is stored in. And to retrieve that, you say os.path.apps_path, which stands for absolute path. Now you know there are two types of paths. There's the absolute and the relative path name. The absolute path name is, it gives the path name right from your C drive or D drive, whichever drive it belongs to. So the relative path name is the path respective to our current working directory. Now I'll have a variable file name out here, which will hold the name of my file whose path I need to find out. So I say sample.txt, and then I'll pass this file name to my function file path. And that's it. Now let's run our code. Okay, so we have not printed the value out. Let's do that. Print path. Run your code again. The first function that we called is to retrieve our current working directory, and the second function is to retrieve the path of this file sample.txt, and this is the right path. This is exactly where I've stored my file. So all's good. So those are the two most common functions that you use with the library or the module OS. There are quite a lot more which you can definitely check out. So next we look into the time module. So as usual, first import the module. Now before I show you a few functions in the time module, you need to understand what epoch is. So 1st January of the year 1970 is the starting point of a certain timeline, and epoch time is basically the number of seconds that's passed since 1st January of 1970. So to get your epoch time, use the function time.timeoff, and I'll store the value of this function returns the epoch time, and I'll store it in a variable epc. Print that out. So that's the number of seconds that has passed as of right now since 1st January 1970. Now obviously this has no meaning to us. So what we do is we'll convert this to a format that means something to us. And for that purpose we use the function local time. So I create a variable local time and use the function local time to which you pass the epc variable. Now print out local time. So as you see here, now we actually have numbers that make sense to us. We are in the year 2019, the 3rd month, which is March, date is 18, 12 hours, 42 minutes, 47 seconds. So this is something we can actually decipher. Now again, this is a structure. It's not in a traditional formatted way. So if you want to extract certain information from this structure, you can easily do it saying local time, that you use the variable, and then just use these keys in here to extract that particular value. For example, I want to extract the year. So I say tm_year, print that, and you see here the year alone is extracted. Now if I want the entire thing to be displayed in a more formatted way, that's exactly what we have the function ctime for. For that you say print and use the function ctime. Again to this you need to pass the epoch value, that's epc, run our program. So now you see we have it in a more formatted way, Monday, March 18th. So we even got the day of the week in here. So those are the basic things you can do with the time module. Let's move on to our next module. So the next module we'll look at is the SMTP module. Now just like HTTP, SMTP is also a protocol. This is a protocol for sending emails. So it stands for Simple Mail Transfer Protocol. So first we'll import SMTP_lib. Now in this demo, what we'll be doing is, of course, we'll be sending out an email. So we'll send an email to someone's email ID through Python. Now obviously Python itself cannot send an email out. What you have to do is you'll be accessing a domain. So you'll give the username and password for this domain and you'll put in commands here such that it automates the process of sending a mail from that particular domain to another email ID. So first we need to set a domain and a port, and for that we use the function smtplib.smtp, and so this takes 2 arguments. The first argument is our domain name. Now the domain name is basically like if you're using Gmail, it'll be smtp.gmail.com. If you're using Hotmail, it would be smtp.hotmail.com and so on. So I'll be using gmail.gmail.com, and the second argument is the port number, which is generally 587. Now 587 is the standard port number according to the standard encryption standard, which is TLS. Now that you have set the domain and the port number, the next thing you need to do is make these servers communicate with one another. That is basically the sender server telling the receiver server, hi, I'm present here, and the receiver server gives an appropriate response. Now in here, we'll be using smtp.ehlo instead of HELLO. That is basically just an extended version of hello. It adds a few additional features to your SMTP. Now before that, we need a variable into which we'll store the object returned by this function. So I'll have SMTP obj. So that SMTP is the object through which we'll be referencing our domain and port number. So now you say SMTP obj.ehlo. Now the next thing we do is we'll put our SMTP in the TLS mode. So for that we use the function start TLS. So as I mentioned before, guys, this port number is the standard port number for TLS. So now it must be clear why we are using this particular port number. It's because we are using the TLS connection. So you say start Okay, so now a connection setup account through which we'll be sending out the email. So you say smtp obj.login, and now you pass two parameters in here. The first is of course the email ID, and that is followed by your password. So to create our file, first we need to import the OS package. And in particular, we need to import path library from the OS package. Now create function, and to this function, I'll be passing the path at which I'll create my new file. So now before you create the file, you actually need to check if the file is already present. So you say if not, path.isFile.dest. So you're passing the destination here to this function .isFile. And if your file is already present, then this portion of the code will be skipped because our entire program is for building, because the entire purpose of our program is to build a file, which we do not need to do if it already exists. Now in here, you say open dest, w. So guys, this function actually returns true only if this file is present and this particular path is actually a file. So suppose this destination, whatever passed to dest, is present, but it's a folder, not a file, we'll still enter this particular block. And so in here, what you do is you open this folder in write mode and say f.write welcome to Python. So let's assume destination was a folder and not a file. You enter this block here. A file is created which is opened in the write mode, and within that file, you enter the content welcome to Python scripting. Now you're ready to close the file. Now outside here, I'll assign the path to destination. So this is the path, guys. I want to create this file sample.txt under this path. So basically, along with the path name where you're creating your file, you also pass the file name. And then you call this function create file, passing dest. And once your file is created, you can just print out file created, right? Okay, now we need to run our code. Well, we don't need an input from the user, so we say print. So we print file created. Now let's run our code. According to the statement here, there's no error. Our program executed completely and created a file. So now let's check if this actually worked. So I go to my desktop. This is the folder where sample should have been created, and yes, it is. We'll open the file, and as you can see, the content too matches. So we were successfully able to automate the creation of a file. So the first argument is the email ID. So you have the email ID within quotes, put it within single quotes, and then your second is the password for this particular ID, and that's my password. So with these credentials, your SMTP will basically log in to your account and then use the services of this account to send an email. Now the next function that will be used, the next function that we'll be using is the one that basically sends your email out. So that's called send mail, and in here you'll put in your to and from email IDs, okay? Next is the ID that we are sending the email to. Next is the from ID. I'll be sending an email to the ID enj2 Simplilearn, again gmail.com. Now the third argument to this function is the message that we'll be actually sending. So I'll be sending a very short message here. The first thing you enter is the subject, and the subject would be SMTP check. And then to move on to the next line, which is basically the body of your message, put in /n. This is a test email, and that's it. That's the body of my message with the subject preceding it. And the last thing we need to do is we will quit the SMT connection. So once your mail sent out, we'll close the connection. This terminates the program. Let's now run this code. So programs run. Now to check if this actually worked, we need to go open our account at ANJ2 Simplilearn and check if this particular message is present in our inbox. So guys, this is the mailbox that I send the email from, and this is the one that I send the email to. As you can see here, ANJ2 Simplilearn, and here is the message which has been sent. So we checked out 3 libraries in Python: the OS library, the SMTP, and the time library. Next, we'll check out a few programs which determine things at runtime. So now I'm going to write a function func1, and this function will receive a few arguments. I'll fill in the space later on. Now all this function does is it prints out the various arguments that it receives. So suppose the arguments are stored in I, and what you pass here is also I. So you pass a number to this function and this function prints out that number. So out here we'll be calling the function and passing a value to it, say 10. Now what if I want to pass varying number of arguments? So say 10, 20, 30 for this particular run, and maybe the next run I want to pass 4 arguments. I want to pass 42. So how do we make this function flexible enough that it accepts any number of arguments and prints these out? That is where we have args come in. So when you put this within the brackets, what happens is that your function will take any number of arguments that you pass to it and store it in the variable args. So now to print out each value that's passed to this function, you take a for loop and you iterate that over args, and then one by one you can print each of these values out. So let's run this program now, and as you see 10, 20, 30, 40, each of them have been printed out in a separate line. And the beauty with this function is you can change the number of values that you print. In fact, you can even give in different types of argument. So I have all integers here followed by a string, and it all works. So that is where you use the variable args. Now, similarly, we have another variable which is used in this argument space, which is called kwargs. So that's KWARGS, and you always precede this with 2 stars, 2 asterisks. So far we looked at how a function can accept variable number of arguments. Now we look into how the function can do this while accepting the arguments as values to labels. So what I mean here is instead of just passing 10, 20, 30, what if I want to pass A equal to 10, B equal to 20, C equal to 30, and again the number of such pairs could vary. So in that case, we have args for the varying part and kwargs for the label part. So what you do here, in the similar manner, you'll have a for loop which will iterate through kwargs, and we want to extract every item in it. So we say items and print out I. Run this code, and as you can see here, so you get all the pairs printed out. So we saw how Python allows a function to determine the number of arguments it receives at runtime instead of it being fixed beforehand itself. Now let's move on to another program which demonstrates automation, and that is creation of a file. So this is one of the most common and the most basic things that you come across when you're learning scripting, not just in Python but any language. So far we saw how a function works. We have a function name, and within it we have some code to perform a certain function. Now functions in Python can also be nested, and that is what we look at now. So I'll first create a function func1, and in here I'll have a variable, say x, which is equal to 10, and within this function I'll create another function. So that will be the nested function func2, and to func2 I'll pass x, and within func2 I'll just increment x by 1 and return this value. So here's the thing, now within function 1 we need to have a call to function 2. So you say func2 and you pass x to it, and out here we'll call function 1. So result equal to func1, print out the value of result. So what happens here is you're calling the function func1, control goes in here, x is assigned the value 10, and over here there's a definition for func2, but right now it's skipped. It moves on to this return line. Now in the return line you're basically returning func2. So what that does is it'll call function 2 along with the argument x, and function 2 returns x plus 1. So where will this value be returned? Of course it will be returned to the statement from where the call is made. So that is still within function 1, and that means function 1 will return the value that function 2 is returning. So what we have in result would be 10 plus 1, which is 11. Let's now run this code. So as you see here, 10 plus 1, 11 is what's passed. So that is how nested functions work. Now, why are nested functions important? They are important to understand the concept of how functions can also be passed as an object in Python and why we would do so. So I'll delete this entire code, create a function func1 once again, and in here I'll print this is first function. So that's func1. Now within function 1, I'll have my second function, the nested function, and within the nested function, I'll print out this is the nested function, and out here, I'll have a third function, which I'll call the outer function, which will print out this is the outer function. Now what I can do here is instead of directly making a call to outer function, so sometimes what happens is you do not want to make a direct call to a particular function. You want to make a direct call to say function A, and through function A, you want to call a function B or C. So for that, what you do is you make a call to func1, and as an argument to func1, you passed another function name as an object. So I pass outer func. So as you see here, guys, outer func is essentially a function, but I'm passing this function as an object to func1. So func1 will receive this function. I'll store that in a variable called func. Maybe called func will also be passed to our nested function, and within the nested function, we'll make a call to this passed function, and of course finally the return statement where we'll be calling our nested function. Let's now run this code. Our outer function was not called, and that's because we did not put these parentheses here, which does not really make it a call statement. Let's run this code now, and as you see, all our three functions were called, but through a call statement for just one. So we just called our outer function func1, passed the other outer function as an argument to this, and that took care of executing all the three functions that we have. This kind of a situation does not come handy very often, but in certain applications where you need to decide which function needs to be executed at runtime, then having the capability of passing a function name as an object comes really helpful. So we saw how you can create functions at runtime. Now Python also allows you to create classes at runtime. So let's check that out. Now the term for creating class at runtime is called factory. So what you do here is you have to basically create the skeleton or just write down the basic description for all your possible classes. So you'll mention the class that it inherits from and the attributes associated with this classes, but you do not create it. You just give that sort of definition, and then later you'll have certain expressions to evaluate which class is to be created depending on certain situations. So let's begin creating the definition for our classes. So my first class would be a base class, of course. So you say type base class, and this will inherit from the mother of all classes, which is the objects class, and following this you'll have list of all the attributes associated with this class. So I have no attributes associated with my base class. Now the second class I create, C1, will inherit from my base class, which is B, and with this class C1 we'll have an attribute named val associated to it, to which we'll assign the value 5. Now my third class C2 will be about the same thing as C1, just that this time my attribute val will have a different value, 10, just so we can differentiate between the two, and of course our class name would be C2. Now we'll have a function, say def class creator, and to this I'll pass a variable, say bool. Now if the variable is true, you say return C1, and that will essentially create your class C1. Else return C2, which will create class C2. Now outside here, I'll call the class creator function, and I'll call it with both the values true and false so we can see the difference. Now of course this just creates a class, so to extract an attribute value, which is how we'll be able to differentiate between the creation of the both classes, say dot attribute name, which is val in our case, and in a similar manner we'll call class creator again, but this time with false, extract the value. So let's run the code now. So as you can see here, guys, first time we pass true to class creator, and if it is true, it's creating class C1, which is this, and that has the value 5 associated with attribute val. Similarly, when we pass false, it creates C2, which has the value 10 associated with the attribute val. So that's how Python allows you to create classes even during runtime. So now that we looked into that, we are back to our nested functions or program in which we call functions as objects. Now suppose I want to call this outer function alone. Now the question is this the only way of calling the outer function within the func1? What I mean is func1 is basically your wrapper function right now, and every function that's called through func1 comes inside this. So I want to call all the functions in the same manner, in the same serial as before, but is there an easy way to do this? Well, yes, there is. This is where decorators come handy. So just on top of outer func, if I say at func1, that way this allows me to call outer object through func1, but just with this one statement in this format. So I just say outer func, but now that I have added a decorator of func1, although I'm calling outer func, it'll be called through func1 just as before. Let's run this code, and as you see here, your func1 has been called first and outer func has just been passed as an argument to func1. So that is what decorators basically do. They allow you to change the operation or the functionality of a function.
Thanks guys. Now we have Apeksha to teach you about 5 important libraries used in Python.
Python is the most widely used programming language today. When it comes to solving data science tasks and challenges, Python never ceases to surprise its audience. Most data scientists out there are already leveraging the power of Python every day. Hi, I'm Apeksha from Simplilearn, and well, after some thought and a bit more research, I was finally able to narrow down my choice of top Python libraries for data science. What are they? Let's find out. So let's talk about this amazing library, TensorFlow, which is also one of my favorites. So TensorFlow is a library for high performance numerical computations with around 35,000 GitHub commits and a vibrant community of around 1,500 contributors, and it's used across various scientific domains. It's basically a framework where we can define and run computations which involves tensors. And tensors, we can say, are partially defined computational objects again, where they will eventually produce a value. That was about TensorFlow. Let's talk about the features of TensorFlow. So TensorFlow is majorly used in deep learning models and neural networks, where we have other libraries like Torch and Theano also. But TensorFlow has hands down better computational graphical visualizations when compared to them. Also, TensorFlow reduces the error largely by 50 to 60% in neural machine translations. It's highly parallel in a way where it can train multiple neural networks and multiple GPUs for highly efficient and scalable models. This parallel computing feature of TensorFlow is also called pipelining. Also, TensorFlow has the advantage of seamless performance. As it's backed by Google, it has quicker updates, frequent new releases with the latest of features. Now, let's look at some applications. TensorFlow is extensively used in speech and image recognition, text-based applications, time series analysis and forecasting, and various other applications involving video detection. So, favorite thing about TensorFlow that it's already popular among the machine learning community, and most are open to trying it, and some of us are already using it. Now, let's look at an example of a TensorFlow model. In this example, we will not dive deep into the explanation of the model as it is beyond the scope of this video. So here we're using Amnest dataset, which consists of images of handwritten digits. Handwritten digits can be easily recognized by building a simple TensorFlow model. Let's see how. When we visualize our data using Matplotlib library, the inputs will look something like this. Then we create our TensorFlow model. To create a basic TensorFlow model, we need to initialize the variables and start a session. Then after training the model, we can validate the data and then predict the accuracy. This model has predicted 92% accuracy. Let's see, which is pretty well for this model. So that's all for TensorFlow. If you need to understand this tutorial in detail, then you can go ahead and watch our deep learning tutorial from Simplilearn as shown in the right corner. Interesting, right? Let's move on to the next library. Now let's talk about a common yet a very powerful Python library called NumPy. NumPy is a fundamental package for numerical computation in Python. It stands for Numerical Python as the name suggests. It has around 18,000 commits on GitHub with an active community of 700 contributors. It's a general purpose array processing package in a way that it provides high performance multi-dimensional objects called arrays and tools for working with them. Also, NumPy addresses the slowness problem partly by providing these multi-dimensional arrays that we talked about, and then functions and operators that operate efficiently on these arrays. Interesting, right? Now let's talk about the features of NumPy. It's very easy to work with large arrays and matrices using NumPy. NumPy fully supports object-oriented approach. For example, coming back to NdArray once again, it's a class possessing numerous methods and attributes. NdArray provides for larger and repeated computations. NumPy offers vectorization. It's more faster and compact than traditional methods. I always wanted to get rid of loops, and vectorization of NumPy clearly helps me with that. Now let's talk about the applications of NumPy. NumPy, along with Pandas, is extensively used in data analysis, which forms the basis of data science. It helps in creating the powerful n-dimensional array. Whenever we talk about NumPy, the mention of the array, we cannot do it without the mention of the powerful n-dimensional array. Also, NumPy is extensively used in machine learning when we are creating machine learning models, as in where it forms the base of other libraries like SciPy, Scikit-Learn, etc. When you start creating the machine learning models in data science, you will realize that all the models will have their base as NumPy or Pandas. Also, when NumPy is used with SciPy and Matplotlib, it can be used as a replacement of MATLAB. Now let's look at a simple example of an array in NumPy. As you can see here, there are multiple array manipulation routines. Like there are basic examples where we can copy the values from one array to another. We can give a new shape to an array from maybe one-dimensional to we can make it as a two-dimensional array. We can return a copy of the array collapsed into one dimension. Now let's look at an example where this is a Jupyter Notebook, and we will just create a basic array, and for detailed explanation, you can watch our other videos which targets on these explanations of each libraries. So first of all, whenever we are using any library in Python, we have to import it. So now this np is the alias which we will be using. Let's create a simple array. Let's look what is the type of this array. So this is an NdArray type of array. Also, let's look what's the shape of this array. So this is a shape of the array. Now here we saw that we can expand the shape of the array. So this is where you can change the shape of the array using all those functions. Now let's create an array using arrange functions. If I give arrange 12, it will give me a 1D array of 12 numbers like this. Now we can reshape this array to 3, 4, or we can write it here itself. So this is how arrange function and the reshape function works for NumPy. Now let's discuss the next library, which is SciPy. So this is another free and open source Python library extensively used in data science for high-level computations. So this library, as the name suggests, stands for Scientific Python, and it has around 19,000 commits on GitHub with an active community of 600 contributors. It is extensively used for scientific and technical computations. Also, as it extends NumPy, it provides many user-friendly and efficient routines for scientific calculations. Now, let's discuss about some features of SciPy. So SciPy has this collection of algorithms and functions which is built on the NumPy extension of Python. Secondly, it has various high-level commands for data manipulation and visualization. Also, the NdImage function of SciPy is very useful in multi-dimensional image processing, and it includes built-in functions for solving differential equations, linear algebra, and many more. So that was about the features of SciPy. Now let's discuss its applications. So SciPy is used in multi-dimensional image operations. It has functions to read images from disk into NumPy arrays, to write arrays to disk as images, resize images, etc., solving differential equations, Fourier transforms, then optimization algorithms, linear algebra, etc. Let's look at a simple example to learn what kind of functions are there in SciPy. Here I'm importing the constants package of SciPy library. So in this package, it has all the constants. So here I'm just mentioning C or H or NA and this library already knows what it has to fetch, like speed of light, Planck's constant, etc. So this can be used in further calculations. Data analysis is an integral part of data science. Data scientists spend most of the day in data munging and then cleaning the data also. Hence, mention of Pandas is a must in data science lifecycle. Yes, Pandas is the most popular and widely used Python library for data science, along with NumPy and Matplotlib. The name itself stands for Python data analysis, with around 17,000 commits on GitHub and an active community of 1,200 contributors. It is heavily used for data analysis and cleaning as it provides fast, flexible data structures like data frames, series, which are designed to work with structured data very easily and intuitively. Now let's talk about some features of Pandas. So Pandas offers this eloquent syntax and rich functionalities. Like there are various methods in Pandas like drop NA, fill NA, which gives you the freedom to deal with missing data. Also, Pandas provides a powerful apply function, which lets you create your own function and run it across a series of data. Now forget about writing those for loops while using Pandas. Also, this library's high-level abstraction over low-level NumPy, which is written in pure C. Then it also contains these high-level data structures and manipulation tools, which makes it very easy to work with Pandas. Like there are data structures and series. Now let's discuss the applications of Pandas. So Pandas is extensively used in general data wrangling and data cleaning. Then Pandas also finds its usage in ETL jobs for data transformation and data storage, as it has excellent support for loading CSV files into its data frame format. Then Pandas is used in a variety of academic and commercial domains, including statistics, finance, neuroscience, economics, web analytics, etc. Then Pandas is also very useful in time series specific functionality like date range generation, moving window linear regression, date shifting, etc. Now let's look at a very simple example of how to create a data frame. So data frame is a very useful data structure in Pandas and it has very powerful functionalities. So here I'm only enlisting important libraries in data science. You can explore more of our videos to learn about these libraries in detail. So let's just go ahead and create a data frame. I'm using Jupyter Notebook again, and in this, before using Pandas, here I'm importing the Pandas library. Let me go and run this. So in data frame, we can import a file, a CSV file, Excel files. There are many functions doing these things, and we can also create our own data and put it into data frame. So here I am taking random data and putting in a data frame. Also I'm creating an index and then also giving the column names. So PD is the alias we've given for Pandas, random data of 6x4, index which is taking a range of 6 numbers, and column name I'm giving as ABCD. Now let's go ahead and look at it. So here it has created a data frame with my column names ABCD, my list as 6 numbers 0 to 5, and a random data of 6x4. So data frame is just another table with rows and columns where you can do various functions over it. Also, I can go ahead and describe this data frame to see. So it's giving me all these functionalities where count and mean and standard deviation, etc. Okay, so that was about Pandas. Now let's talk about next library and the last one. So Matplotlib for me is the most fun library out of all of them. Why? Because it has such powerful yet beautiful visualizations. We'll see in the coming slides. Plot and Matplotlib suggests that it's a plotting library for Python. It has around 26,000 commits on GitHub and a very vibrant community of 700 contributors. And because of such graphs and plots that it produces, it's majorly used for data visualization. And also because it provides an object-oriented API which can be used to embed those plots into our applications. Let's talk about the features of Matplotlib. The PyPlot module of Matplotlib provides MATLAB-like interface. So Matplotlib is designed to be as usable as MATLAB with an advantage of being free and open source. Also, it supports dozens of backends and output types, which means you can use it regardless of which operating system you're using or which output format you wish. Pandas itself can be used as wrappers around Matplotlib's API so as to drive Matplotlib via cleaner and more modern APIs. Also, when you start using this library, you will realize that it has a very little memory consumption and a very good runtime behavior. Now let's talk about the applications of Matplotlib. It's important to discover the unknown relationship between the variables in your dataset. So this library helps to visualize the correlation analysis of variables. Also in machine learning, we can visualize 95% confidence interval of the model just to communicate how well our model fits the data. Then Matplotlib finds its application in outlier detection using scatter plot, etc. and to visualize the distribution of data to gain instant insights. Now let's make a very simple plot to get a basic idea. I've already imported the libraries here. So this function Matplotlib inline will help you show the plots in the Jupyter Notebook. This is also called a magic function. I won't be able to display my plots in the Jupyter Notebook if I don't use this function. I'm using this function in NumPy to fix random state for reproducibility. Now I'll take my n as 30 and will assign random values to my variables. So this function is generating 30 random numbers. Here I'm trying to create a scatter plot. So I want to decide the area. Let's put this. So it's just multiplying 30 with random numbers to the power 2 so that we get the area of the plot, which we will see in just a minute. So using the scatter function and the alias of Matplotlib as PLT, I've created this. If I don't use this, then I have very small circles as my scatter plot. It's colorful, it's nice. So that's one very easy plot. I suggest that you explore more of Matplotlib and I'm sure you will enjoy it. Let's create a histogram. So I'm using the style as ggplot and assigning some values to these variables, any random values. Now we are assigning bars and colors and alignment to the plot. And here we get the graph. So we can create different type of visualizations and plots and then work upon them using Matplotlib, and it's just that simple. So that was about the leading Python libraries in the field of data science. But along with these libraries, data scientists are also leveraging the power of some other useful libraries. For example, like TensorFlow, Keras is another popular library which is extensively used for deep learning and neural network modules. Keras wraps both TensorFlow and Theano backends, so it is a good option if you don't want to dive into details of TensorFlow. Then Scikit-Learn is a machine learning library. It provides almost all the machine learning algorithms that you need, and it is designed to interpolate with NumPy and SciPy. Then we have Seaborn, which is another library for data visualization. We can say that Seaborn is an enhancement of Matplotlib as it introduces additional plot types.
Now, Richard will focus on libraries like NumPy, Pandas, Matplotlib, and Scikit-Learn. Following this, Richard will also focus on helping you understand web scraping better.
Welcome to NumPy. What's in it for you? Well, today we're going to do part 1 of NumPy in a 2-part series. Now we're going to go over what is NumPy, installing and importing NumPy array versus Python list, basics of NumPy, finding size and shape of any array, range and arrange functions, NumPy string functions. And then in part 2, I'll move on to cover axes, array manipulation, and much more. So let's start with what is NumPy. NumPy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on NumPy. So the fundamentals of NumPy are so important to latch onto for the Python, so that you can understand the other modules and what they're doing. NumPy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In NumPy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that NumPy's array class is called NDArray for NumPy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to Jupyter.org, that's Jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda notebook. But this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython. And you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice. I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull-down menu you'll see Python 3. And this will open up a new window. And now we're in Jupyter Python. So this is a Python window, and we'll just do a print. And this, of course, let's go hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our NumPy array versus Python list. Python list being the basic list in your Python. Why should we use NumPy array when we have Python list? Well, first, it's fast. The NumPy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import NumPy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our NumPy module inside our Python. And then the most common thing, of course, is to go ahead and create a NumPy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the NumPy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0, and when we set on there. So let's take a look why we're using NumPy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do b equals range of 1,000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in NumPy. And we'll go c equals np. And this is a range. So that's the NumPy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of c for np.arange, let's go ahead and print. And we can do that by doing c.size times c.item size. And that's very similar to what we did before. We did get the size of, so the c size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and c size. And let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y. And we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because it's in milliseconds, so times 1000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. We'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using NumPy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the NumPy list, or NumPy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the NumPy. That's why a lot of people base so many other modules on NumPy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals, in this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for NumPy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different NumPy data types. Shorthand, complex, we have complex 64, complex 128. Complex number represented by 2 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your NumPy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a NumPy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape. Probably one of the more used. I use a shape all the time, very commonly used. And then down here you can see where we actually created a NumPy complex data type. So let's look at some other features in NumPy. One of them is you could do NumPy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a NumPy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do NumPy1s, and we'll do the same thing, 3, 4, we'll run that. And you can see I've created an array of NumPy1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do lrange5, and we'll print the L, so that's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array, 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in NumPy arange, remember that from before, and if we do NumPy arange 5, and let's do L equals, or we can just leave it as NumPy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the NumPy arange 5. It generates the actual array. And for part one, we're going to do just one more section on basic setup. And we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an NP character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. And this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in NumPy, it takes the two different arrays that we set up in there and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3. And we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper, opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So NumPy just makes it simple, and we like that. And so in this case we did Python data, it's all uppercase, Python is easy, like shouting in your messenger, Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split, are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces? And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, How are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from the 1920s and has gotten old. So there we go. We've covered a lot of the basics in NumPy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shaping in there and the setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in NumPy. And you saw how easy it was to add 2 arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have 2 different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Today we're going to do the Pandas tutorial. Really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about Pandas, and there is some connections. There's like an interface going on with that, so there is availability. But you really should know your Pandas, because if you're working in big data, you'll know there's data frames. Well, Pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into Pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said it that it's a data frame. So the data structures in Pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a Pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in Pandas. In Pandas we can do a lot more. And Pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just 2 columns, and we have a nice index label and a column label for the data. And then a data frame is a 2-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this would look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows, so you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org. And then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas, and usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it, take pieces of it, so query it, delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list, and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for Pandas, there we go, switching my anachronisms. So we have PD.series of N, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing. Most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output. So it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. Well, we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1, it's just viewing S1. So a simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here, a CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. So let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this. There's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add S5.add S6, and likewise we can do S5.add Sub for subtract, S6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's null values where it can't subtract the two because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this. And you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting, because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date, for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6,4. You can look at this as rows and columns as we move it into the Pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame. And we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns. And you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. And remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You could sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. We have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas data frame. And then we have our data, just like we did before. And then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. And again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head. And if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of one because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. I'm looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it. And then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then, of course, we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up D-type. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note, these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75%, and your maximum value. So this should look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2 and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun. Because remember, this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go to have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age, let's see, what was we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null, making a copy. Here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age. Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. You could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, A, B, A, C, A. Popped in a null value. Cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D. And it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we're going to use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC. And baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have A, C, D, A, baka. Everything's capitalized except for the null value, which is still null. All right, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was. It's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4. I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone, and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you the folders going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, and then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet 1. And then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet 1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here. And we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's make this, no, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel and one of these is a CSV on here. And so there's our 2 file types on there. And they have other formats. These are just the 2 most common ones used. And I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. Today we're going to study the Matplotlib and the Python code. So let's start with what is Matplotlib. Matplotlib is an open source drawing library which supports rich drawing types. It is used to draw 2D and 3D graphics. And there are so many packages in the Matplotlib, we're going to cover the basics. And there are so many packages that sit on top of the Matplotlib that we can't even cover them all today. But we'll hit the main ones so that you have a good understanding of what the Matplotlib is and what the basics can do. You can understand your data easily by visualizing it with the help of Matplotlib. You can generate plots, histograms, bar charts, and many other charts with just a few lines of code. And here we have some basic types of plots that you can see here that we'll go into. We have the bar chart, the histogram. Boy, I use a lot of histograms in my stuff. A scatter plot, line chart, pie chart, and area graph. Let's start plotting them. And to do this, I'm going to be using Jupyter Notebook. You can use any of your Python interfaces for programming or scripting and running it. Of course, we here really like the Jupyter Notebook for doing a lot of basic stuff because it's so visual. And in our Jupyter Notebook, which opens up in this case I'm using Google Chrome, you can go up here to New, and we'll create a new Python 3 and set that up. If you're not familiar with Jupyter Notebook, we do have a tutorial that covers some of the basics of that. And you'll look at any of our tutorials, I usually cover a number of them showing how to set up Jupyter and Anaconda. I myself use Jupyter through Anaconda. In fact, let's go ahead and open that up and just take a look at see what that looks like. You can see your Anaconda navigator. If you install it, it will automatically install the Jupyter Notebook. And that also installs a lot of other things. I know some people like the Qt console for doing Python or Spider. I've never used them. I actually use Notepad++ as one of my editors. And then I use the Jupyter Notebook a lot because it's so easy to have a visual while I'm programming. And even simple script in Python, I'll take it from the Jupyter Notebook and then do a save as. You can always go under File, and you can download as a Python program. So that will download it as an actual Python versus the IPython that this saves it as. So let's go ahead and dive in and see what we got going here. And let's go ahead and put Matplotlib tutorial, and I'm going to turn this cell into a markdown so it doesn't actually run it. But you can see it has a nice little title there. That's all Jupyter Notebook. And then from Matplotlib, let's import PyLab. Get that back one. And then let's go ahead and just print. We'll go PyLab and the version. Let's go ahead and run this. So we're going to import our PyLab module from the Matplotlib. And we find out that we're in version 1.15.1. Always important to note the version you're in. Probably I was reading an article that said the number one thing that Python programmers struggle with is remembering what version they're working in and making sure that they're going from one platform to the other with the same version. And if we're going to graph things, I think we need some data to graph. So we're going to import NumPy as NP. Now, if you're not familiar with NumPy, definitely go back and check out our NumPy tutorial. There's so many different things you can do with it, dealing with reshaping the data and creating the data. We're just going to use it to create some data for us. And there is a lot of ways to create data, but we're going to use the np.linespace. So we're going to create a NumPy array. And the way you read this is we're going to create numbers between 0 and 10. And we're going to create 25 of these numbers. So we're just going to divide that equally up between 0 and 10. And if we have x coordinates, we should probably have some y coordinates. And we'll do something simple like x times x plus 2. And let's just take a look. We're going to print x and print y. Let me go ahead and run this. And let's see what we got going on here. So we have our x coordinates, which is 0, 0.4, 0.83, etc. And you can look at this as an xy plot. So where we have 0, we have 2. Where we have 0.416, we have 2.17. And just as a quick reminder, we're going to do print np array x comma y dot reshape 25 comma 2. And the reason I want to do this is I want to show you something here. A lot of times a program returns x comma y, and it's an array of x comma y, x comma y, x comma y. And so when you're working with the pyplot, you have to separate it out and reshape it. So if I start off with pairs like this, I can reshape them. If I know there's 25 pairs in there, I can switch the 2 and the 25. And this is kind of goofy, but we'll do it anyways. Reshape. So I'm going to reshape my 25 by 2 back to 2 by 25. And if I run that, you'll see I end up with the same output as the XY, the two different arrays in here. And this is important that we want X and Y separate. Again, that's all NumPy stuff, but it's important to understand that this is a format that Matplotlib works with. It works with an array of X's, and they should match your array of Y's. So each one has 25 different entities in it. And then for our basic plotting of this data, it only takes one command to draw a graph of this data. And so we use our, from up here where we imported PyLab, we take our PyLab, and the key under there is plot for plotting a line. And then we want our x coordinates and our y coordinates. And we'll throw in R. And the R simply means red. So we're going to draw the line in red. Let me go ahead and run that. You can actually switch this around if you wanted to do different. There's B for blue. We have a lot of fun. Yellow. Hard to see yellow. There we go. But we'll go ahead and stick with red. Run. And when you're doing presentations with these, try to be consistent. You know, if the business and the shareholders send you a spreadsheet and they have losses in red, use red for losses in your graph. Try to be consistent. Use green for profit, for money. You don't have to necessarily use green, but it's whatever they're using, whatever the company's using. Try to mirror that. That way, people aren't going to be confused if you switch your data around and every time one graph has red for loss and one graph has blue for loss. It gets really confusing, so make sure you're consistent in your graphs and your coloring. And something to know, because we're going to cover this in a minute, this is your canvas size. So we have a canvas here, and what we're going to do next is we're going to look at subgraphs. Okay? So let's take our PyLab and create a subplot. And one of the things also to know when we're working with the Matplotlib library, I'm not setting, when I do this, this is my drawing canvas, the PyLab. So once I've imported the PyLab, I'm drawing my images on there. Very important to know. And with the subplot, we're going to give it some different values. And we're going to represent by rows, columns, and indexes. And let's do 1, 2, 1. So it's going to be the first row, second column, and the index is like you can stack your graphs and things like that. We don't worry too much about indexes, but rows and columns. We want to go ahead and use row 1 and column 2. And if we're going to have one object, we should probably have two, but before we do that, we have to plot data onto the subplot. So the order is very important, and we'll go ahead and stick with our x comma y, and let's do this. We're going to add in a third parameter here. Remember we did red? We're going to add shorthand dash dash for dashed lines. So this plots the data into row 1, column 2. And if we're going to do that, let's do another one, pylab.subplot. And if we're going to do row 1, let's do column 2 and index 2. And this time we're going to add G for green, and this denotes a style. And if we're going to set up our PyLab subplot, there we go, PyLab, we got to go ahead and plot that. PyLab plot. And instead of XY, we want Y comma X. Whoops, I messed up. This is in the wrong spot. There we go. We'll move that down here real quick because that goes in the plot part. So the subplot tells it the row, column, and index, and the pyplot tells it what data. In this case, we switched them, and the color, and then the style shorthand. Now let's go ahead and run that. And you'll see it takes this canvas, splits it in two, and now we have two different graphs. And we have the red one with dashed lines, and we have the green one, which has little stars going up. And if we take this, and let's just for fun, let's change this and run that with an index of 1. It puts them both on the same index. It also gives me a warning because it's a strange way of doing two subplots. It's depreciated. There's another way to do it. But most people just ignore that warning because it's not going to go away anytime soon. Now that's using the same setup. What happens if we do, instead of this, let's change the column on here and find out what happens. And if we do the column, it didn't really like that on the setup, it just disappears. So let's keep our column as 2, and let's change the row on the second one to 2, and run that. And you'll see again it kind of squishes everything together. It can cause us some issues. So let's take the index. So they each need a unique index. And you can see here where I made some changes. I said row 2, and look what happens when I change to column 2. So I now have row 2, column 2, index 2. It squished it up here, so you could put another graph underneath is what that does. And there's all kinds of different things. You really have to just play with these numbers till you get a handle on them, because you have to repeat it 164 times according to Cambridge University if it's completely new to you. And you can see right here where, there we go, 3, run. There we go. But you can see it takes a little bit sometimes to play with these and get the numbers right. Oops, I hit the wrong one, that's why. Let's go 3 there, run. There we go. Now it's overlapping, so I have this doubled over here on the right. For now, we'll just go ahead and leave this with the where we have column and row 2 and the two different indexes so they appear nice and neatly side by side. And then, as we just saw, as we were flashing through them, we can put them on top of each other. And let me just highlight that and copy it down here. Paste it down there. And here we have 1, 2, 1. And then we'll do 1, 2, 1 also for this one, and that puts the two subplots directly on top of each other. It gives us that warning, and you can see we now have two different sets of data graphed on top of each other. And you can also see how it did the indexes. Since one of them is from 0 to 10, that's the green one on the x-axis, and the other one is from 0 to 10 on the y-axis. So it took the greatest value of either one and then used those as a shared value. So let's next, look at operator description. And we'll go ahead and turn this cell into a markdown and run that so it looks nice. So Fig, and you remember I talked about the canvas earlier. I briefly mentioned it. We're going to look a little bit more at the canvas later on. But that's what the figure is. Fig, we're going to add axes. So we're going to initialize a subplot, add the subplot, in rows, in columns, and all kinds of different things with this that you can do. Let's look at that code and see exactly what's going on. And I want you to notice that there's Fig, which is the actual canvas in the Matplotlib library. And AX is commonly used to refer to the subplots. So when we're creating subplots, you'll see AX equals PLT subplot. Earlier, we did the PyLab. So let's go ahead and import PyPlot from Matplotlib library. And we're going to do it as PLT. You'll see that a lot. That's really the standard in the industry, is to call it PLT, just like Pandas is PD and NumPy array is NP. Certainly you could import it as whatever you want, but I would stick to the standards. And we're going to do the same graph as we did above with the PyLab, but with the PLT. So if it looks familiar, there's a reason we're doing this, because we want to show you how the figure part works and working with the canvas goes. But we're going to do the same plot as we did before. And we'll call it Fig, and we're going to set that equal to plot figure. So there's our figure or our canvas on there. And let's create a variable called axes, and we're going to set that equal to fig.addAxes. And in this, we're going to control the left, right, the width, the height of the canvas from 0 to 1. And so we can go ahead and I'm just going to put some stuff in there. I got 0.5, 0.1, 0.8, 0.8. So when you're looking at this, this is a 0 to 1, or you could say 50%, 10%, 80, 80%. But it's a control. It's going to control your left and your right, along with the width and the height. So the width and the height, we're going to use 80%, and we're going to have like a little indent on the left and the right. And this should look familiar from above. Axes.plot, x comma y, and then let's give it a color. How about red? Since we're recreating the same graph, let's keep it uniform. Oops, and it helps if I use AXIS instead of AXES. I don't know where that came from. But this looks identical to the one we had up above. So here's our axes plot, x comma y of red. Same graph, same setup, but this time we've added a variable equal to the figure.addAxes. So our plot figure is our canvas, our axes is what we're working in, and then our axes.plot x comma y. And again, we can draw subgraphs. We put that down here. Just like we did before. And a little different notation here. We're going to have fig comma axes equal plt.subplots. And in here it's going to be the number of rows. We're going to do one row, and columns equals 2. So if you remember before, that's what we did. We had one row with 2 different graphs on it. We're going to do the same thing, but note how we did this. Here's our figure, or our canvas, and our axes. We're going to create actually 2 different axes. We're going to create row 1, column 2. And so axes is an array of information. So we can simply do let's do ax in axes. And this will now look familiar. Ax.plot. We're going to do x comma y. We'll go ahead and make it red. Keep everything looking the same. Remember, nice uniform graph, so everything looks the same. And if we go ahead and run this, you'll see we get 2 nice side-by-side graphs. So just as we had before, the same look, the same setup. And just for fun, let's change in columns to 3. We'll run that. And now you'll see we'll have 3 on there. And let's see if we make it a little bit more interesting. We'll do in rows equals to 2. And you can see down here we're going to get an attribute error because it's trying to scrunch everything together. So it does have a limit how much stuff you can put in one small space. That's important to know. You can fix that by changing the canvas size, which we'll look at in just a minute. And there's other ways to change it on here. But here we go. We can do in rows 2 and columns equals 1. You can see 2 nice images right above each other. We'll go back to the original. 1 row, 2 columns, side by side, left to right. And we can also draw a picture or graph inside another graph. And that's kind of a fun thing to do. It's important to note that we can layer our stuff on top of each other, which makes for a really nice presentation. So let's start by fig. We'll create another figure. So we're going to start over again with our canvas. We set that equal to plt.figure. So there's our new canvas. And let's do axes. We'll call it axes 1 and 2. Axes 1 equals fig.addAxes. Remember this from earlier? And This here, similar numbers we used before, saying how big this axis is, this figure in the axis is. So this is going to be the big axis. And let's do axis 2 equals another figure at axes, and then 0.2, 0.5, 0.4, 0.3. And if we're going to do this, they need data on them. So let's go ahead and plot some data on our axes. So axes1.plot. And we'll make this simply x comma y comma, make it red. And then let's go axes2.plot. And let's reverse them. Y comma x comma green. There we go. Doing what I told you not to do. You shouldn't be swapping axes around and plotting your data in 5 different directions because it's confusing. But let's go ahead and run this and see what this looks like. And then let's talk a little bit about this. We talked about the 0.2, 0.5, 0.4, 0.3. And let me just grab the annotation for that. That's left, right, width, and height. So we have in here that this is going to be left, right. So here's our left is 0.1n, 0.5. And you know what? Let's just play with this a little bit. What happens when I change this to 0.1? Moves it way over to the left. So there's our 0.1. So we can make this 0.4. Run that. There we go. So you can see how you can move it around the branches on here. 0.2, 0.5 is the left, so that's our right. So let's see what happens when we do let's make this 0.1. And that actually is, they had it down as left, right. I thought this was wrong. It's actually how far from the bottom. Let me switch that on here. Bottom. There we go. So we had here on this. We can go ahead and put that back to 0.5 and run that. And this is 0.3. Let's make this 0.3 also. And that is the width. And then, of course, there's the height. We can make that really tiny. Actually, let's do 0.2, and let's run that. And you can see it changes the height on there. We can make it even smaller, 0.2 by 0.2. And as you can see, you can get stuck playing with this to make it look just right. It can sometimes take a little bit. Certainly, once you have the settings, if you're doing a presentation, you try to keep it uniform, unless it doesn't make sense for the graph you're working on. Try to keep the same colors, the same position, and the same look and feel. And I mentioned earlier we can adjust the canvas size. So this is from earlier. I just copied it down below. We're going to replot the same data we've been looking at. And what we can do is we can change the figure size to 16 by 9. And let me run that and show you what that looks like. So it fills the whole screen. And then if you are, normally when you're working on the screen, you don't worry too much about this. But we can set the DPI to 300. Run that. There it goes. This is your dots per inch. And if you are doing an output of this and you're printing a hard copy, you want the higher quality. I would suggest nothing under 300 if it's a professional print. You might get a little less than that, but whenever I'm doing professional graphics and printing them out on something, 300 dots per inch is kind of the minimal on there. You can go a lot higher too, but keep in mind the higher you get, the more memory it takes and the more lag time and the more resources you use. So usually 300 is a good solid number to use in your dots per inch. And you can see it draws a nice large canvas here, which is 16 by 9, and then the DPI is 300 on here, so it's a little higher quality. And just out of curiosity, I wonder how long it takes to draw something double that size, 600. And you can see here where at 600 DPI, it's going to take a while. There it goes, just because it's utilizing a lot more graphics on there. And let me just go back to the 300. Now let's do a 100. You're not going to see a difference on this because it is web-based graphics are pretty low. And up here you saw I did this with the plot figure. This works the same if I do figure axes subplot, figure size, and then we'll go ahead and do axes plot x comma y comma, we'll stick to red. Let's go ahead and run this. And you should get almost the same thing here. Here's our axes on the subplot on here with the fixed size and the DPI. Let me take this all out. Let me just remove all that real quick. Run it again. There we go. Now we're back to our original figure. And let's look at some of the other things you can do with this. One of the things we can do is we can set a title for the axes. So axes set title. You'll see right here, since I put this on the axes, it's the main title for the whole graph. And if you're going to have a title, you should also label. So we can label our X label, and we can set our Y label. In this case, we're just going to call it X and Y. Keep it nice and uniform, and if we run this, you'll see that we've added a nice X label and Y label. Whoops, where'd they go? And it turns out in this environment that you have to put it before the title. So let me go ahead and put it before the title. And there's our X, Y, and let me run that. And of course, we can also do up our size a little bit so you can see what's going on a little better. So here we have X label X. If you come down here, you'll see our X label and our Y label. We can, of course, change this to X label. You can change this to Y. It can be whatever you want on here, of course. And our title graph. There we go. Run. So here we have our title graph, our Y label, and our X label all set up on our nice little plot. And then before we move on to the next section, let's do one more thing on here. We have a thing called a legend. And we're going to set our AX legend, label 1, label 2 up here. That's the format for it, but let's go down here and actually use it. I'm going to do two different plots. We're going to have axes plot x by x times x squared and x cubed. And if I run this, you'll see it puts two nice graphs on the setup on there. But it's nice to have a legend telling you what's going on. So for the legend, we can actually do axes, since we have the two plots, legend. And on here, we've created an array. And we have y equals x squared, y equals x cubed. You can actually put this as whatever you want. Those are just strings. And then location 2. And let's go ahead and run this and see what that looks like. And you can see it puts a nice legend on the upper left-hand corner. Location 2. We can do location 3 and run it. And it drops it down to the bottom. Location 1. I can't remember where that's at. There we go, upper right. So each one of these is a number that refers to the different locations on the screen. 0, kind of have to play with them or look them up to remember where they're at, but they do work. It just kind of moves around depending on where you want your legend at on there. So on this section we cover the title of the graph, the Y labels, and legends. We're getting into starting to look really fancy here. So we now have something we can actually put out. You'll see the title of the graph looks a little fuzzy. So I might, in a web setup, put the DPI up a couple notches. Maybe put it at 200. 100 might work fine. Just so you know, that's something to notice on here when you're playing with these different things. We had our subplots DPI equals, let's do 200 to see what that looks like. So you can see it now is a lot clearer. It's also larger, so it's a nice little feature you can throw in there with your DPI dots per inch. So the next section is, let's look at some graph features. We're going to look at line color, transparency, size, and a few more things on here. And, oops, I forgot the main title. So we have our figure and our axes equals our plot and subplots. And I'm going to go ahead and do a DPI equals 150 so the graph comes out nice and large and easy for you to see. And let's go ahead and do 3 plots on here. We'll do x by x plus 1, so it's just going to be a straight line. Plot x plus 2 and axes dot plot x plus 3. This looks like we're doing nearest neighbor setup or showing how it located data and putting your lines on there between the nearest neighbors. There we go. So it draws a nice little graph with 3 lines on it. One of the things we can do is we can control the alpha on this. Oops, and you can actually see when they did these lines, it automatically pulls in different colors for your setup. So there's some automatic things going on in there. And a lot of times we do that comma R, where we're going to do color equals red, another notation on here. Let's go ahead and run this. Now we have a bright red line down there. And with the Matplotlib library, you're not limited to red. You can also use one of many different color references, as you see here, with the #1155DD. Which is just blue. And we can do the same thing with another color on here, which turns out to be green. And I can just as easily do this. Green, blue, oops, there we go, blue, and run that. And you'll see here we have red, blue, and green. And what I want to do is I want to make this, we're going to set what's called the alpha on this. And we're going to set this equal to 0.5. So this is halfway see-through when I run this. And it's almost going to look pink because you can see through it. And let's change this just a little bit, just to make this kind of fun. Let's square it. There we go, run it. So now we have this nice square that comes up, and you can see when it crosses it, because I plotted these 2 lines after it and they have no alpha, the red is behind those lines, or in this case pink, because we did the alpha halfway through. So let's go ahead and do this. Alpha equals 0.5, and you know what? Instead of squaring it, let's take it to the 0.5 power. That'll be kind of interesting to see what that does. We'll just go to keep it squared. There we go. And run that. And let's go back and look at this where it crosses over. And the first thing you see right here is on the blue, it's kind of light blue now. You can see how the 2 colors add together. You get almost a purple on there. So I can clearly see where the red crosses the blue line. And then the green just blanks it over because I didn't do any opaqueness, no alpha on there. So this is great if you have lots of data that crosses over and you need to be able to track those lines better. And we'll go ahead and do this 0.5, and we'll run that. Oops, I did equals 0.5. Let me go ahead and run that. And so you can see right here, now you can easily see the red line, how it crosses the green and the blue down here. And if we want to, we can do this as the default is 1, is solid, so we can change this all to 0.8. Let me just do that. Oops, 58.8. There we go. Run. Oops, I must have hit a wrong button there. Let me try that again. I accidentally got rid of a bracket. And let's go ahead and run that. And we come down here and look at this. You can still see where it passes behind them, but the green dominates and the blue dominates because we're now at 80% instead of 50%. And you can do less. That's kind of fun, although at some point the lanes kind of fade. So 0.5 is usually the best setting on there. We have a nice pastel here at 0.3, and you can easily see where they cross over. And just like you can play with the colors, we can play with line width. And let's try DPI 100 and see what that looks like on my screen. Equals 100. And we'll go ahead and just take our AX plot. Let's do 4 of these lines just so you can see how they look next to each other. Real quick here. There we go. And if I run this, they should all appear the same. It automatically does different colors on there. So let's do color equals blue. Forgot my quotation marks. There we go. And we'll go ahead and just make these all blue, just for purposes of being nice and uniform. And then what I want to do is I want to do the line width. Line width equals 0.25. And let's just copy and paste that down here. Let's do equals 1. About 1.5. And let's do just make this equal to 2. Let's see what that looks like. And when we do that, you can see it goes from a very thin line, a 0.5, a 1, our 1.5, and 2, which is twice the width of the 1. And if we're going to do different sizes, we had different colors, we had our alpha scheme. Let's take this whole thing here. Let's paste it down here and do another one. But instead of line width, let's look at styles. And something to note here, you can actually abbreviate this with LW. So line width can also be let's just do everything 0.2. And let's set up a line style. We'll do the first one dashes. And let me just paste that down here, so I'm not doing a lot of extra typing. There we go. Take this out. So we have our dashed. We can do a dash dot. Oops, let's do the dash dot here. And a colon here. There we go. And there's a lot of different options. We'll look at a few more as we go down for different ways of highlighting data. But when you look at this, we have everything as a line width of 2, and now we have a straight line, we have a dash line, or a dot dash, and a dot 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 line. And then another thing we can add on here is we're going to do, here's our X plot, and we did X, let's do X plus 4, so it goes right on the top. I'm going to do color black, line width 1.5, so it's a smaller line. And we're going to take the line and we're going to set dashes. So look how I've changed some of the notation here for my line and my ax plot. So I can set my line comma equal to ax plot, and then I can change the line settings this way. And when I run this, we run that on here, you'll see the 5, 10, 15, 10 creates a series of dashes that are varied in length. In this case, they alternate between a short dash and a long dash. And we can play with these numbers. Curiosity always has me what happens when you play with the numbers. Just to see what they look like, let's do this. Let's paste this down here. I'll do 2 of these just because they're kind of fun to play with. And let's change this from 10 to 3. And we're going to change this one from 15 to 4. And let's run that. And you can see the differences in the lines. Oops, a little bit confusing on there, because I forgot to change the lines are all on top of each other. So let me change that really quick here. And let's run that. And now you can see here's our original dash line alternating. When I change these numbers on the second one, the very end value to 3, you can see now we have dashes of 5. Let's see, I'm going to guess this is a dashes of 5, skip 10, dashes of 15, skip 3, and then it goes back to the beginning. Dashes, 5 dashes, skip 10, 15 dashes, skip 3. And of course the last one we just switched up a little bit. It looks a lot more uniform because I'm using 2 sets of 10. Or if I did something like this and changed it to 30, it really becomes pronounced as far as the distances between them. And instead of 4, let's put 30 here also. 30 by 30, there we go. Really pronounced on that one. And let's look at one more important group for plotting our data. And in this, here's our plot we started with the x plus 1, x plus 2, x plus 3, and did it in blue on this one, 3 or 4 different blue lines. And this property, we want to add the actual plots, so you can see where the plots are on the graph. And for that, we might have marker equals O. And if we run this, you'll see it puts a dot for each of these, and there's 25 dots because we have 25 x values. So we actually have 0, and each of the different values of x, y are then plotted here with the dots. And we don't want to just limit ourselves to dots. We can also do plus sign, that's another option. Dots is most common. I actually like the dots the best. If we do the plus sign, you can see it puts a nice crosshairs or plus sign on there. And we can do a marker. There's a number of different markers you can use. And I think this one was it. S is another one, which is a nice square. And that's actually a good one, S for square. O for period. Okay, that's just kind of weird. So you can see that probably on these markers, another one is number 1. So if we run that, you'll see we now have these little hatch marks. And let's just go with the O on this one. By the way, this works with square really nicely. Some of the stuff we're going to do here in just a second. Let's do marker size equals 2. And change that to 5 and run that. And you can see here it puts a nice little tiny dot versus this size dot here. And this is interesting because it said 2. I thought it would be bigger. But if you do 0.5, it gets even smaller. And let's just do 10 to see what that looks like. Run. That looks huge. So marker size, a lot of these are dependent on the DPI and the setups. There's things that switch around as far as the way the size shows up. You got to be a little careful when you change one setting, it can change all the other markers. And then let's take our square on here. And we had marker size, so we also have marker face. We'll set that equal to red. Of course, I may change so it's up 1 notch. We'll run that. Whoops, must have mistyped something on here. And I did, it's marker face color equals red. And so when I run that, you can now see I have the squares on there with the marker face color. Of course, we can mix and match these. Come down here and we'll make this, let's make this plus 7. And we'll make this size 15. Marker face color equals, and we'll do green, just because. There we go, run. Very hard to actually see what's going on there. Still 25 dots, they kind of overlap. As you can see, they print them over each other. And of course, if we really wanted to make it look horrible, we could just make that really huge. Generally though, you want something a little bit smaller and cuter. We'll just try doing it this way. There we go. That's too small to even see the face. So 4, you can start to see the face on there around 4, and maybe on 8. 8 might be a good number for this. There we go, 8. Again, that all just depends on what you're trying to show and display. So we've covered a lot of stuff here as far as our lines. We've covered opaque with our alpha setting on there. Give us some nice pastels. You can see how they overlap and how they cross over. We covered the line width. Different size on there, different formats for the line itself, and these are all, you can combine all these. So you can have our line width equals 2, line style equals dash. You can bring this down here also to the markers. And then we added markers in, just standard circle, a plus sign, the square, a little tick, which uses a 1. Then we add a marker size and a marker color face, and we combine those. You see we get a nice different series of representations. We also briefly mentioned color, where you didn't have to use, like in here we used color black. Someplace up here, I'd have to find it, we use the actual number for the color, as opposed to, I changed them to red and blue. So you can get very precise on the color, if you have a very specific color set that you need to match your website or whatever you're working on. All of those are tools in the Matplotlib library. So we have one more piece to formatting the graph, so we want to show you, and then we have 2 big sections. We're going to go over the different graphs that they have along with a challenge problem. So let's go in the last section we're going to look at is limits. We're going to limit our data. So this first part I'm just going to paste in there. We're going to create our subplots 1, 2. So 1 row, 2 columns. We're going to do a figure size of 10, 5. This should all look familiar now since we've done a number of them. And we're going to go ahead and plot, and this is an interesting notation you should notice here. Our axes 0, so 1 we've used, instead of, you can just iterate through them, but they're just an array, so it's an array of 0 is still the axes of the first axes out of 2. And we're going to plot x, x squared, x cubed, line width 2. So we're going to go ahead and just plot two graphs right on top of each other without doing multiple plots on here. And we'll set the grid equal to true on here. Let's go ahead and run that. And you can see here are two plots with the x value going across. And I'm going to do something similar. And by the way, so you can just, if you look at it, you can see the grid on there. That's all that is. Easier to spot the data going across. We're going to take the same data for axis 1. So we have our plot of x, x squared, x and x cubed, line width 2. And this time we're going to take our axis 1 and do y limit. It's actually set underscore y limit. This is the y-axis. So it's going to be an array of two values. And we'll do 0, 60. I'm just making these numbers up. The guys in the back actually made them up. I'm just using their numbers. And we're going to set the x limit. And we'll set the x limit as, don't forget our brackets there, 2, 5. So it's the same data going in, but we're setting a limit on it. And let's go ahead and run that. And let's see what it comes out of. And here we have the y limit 0 to 60. So we're looking at just the lower part of this curve here up to here. And we have the x limit 2 to 5. So that starts right here at 2, and you can see very different graphs. This is kind of nice because you could actually put one of these on top of the other if you wanted to draw focus to one part of a graph. Remember how we did that earlier, one inside the other? But just a quick note, you can easily limit your graph and kind of reshape the way it looks quite easily. And we can also add that grid down there if you want a grid. We'll run that and add the grid in there. Whoops, I guess you have to do the grid beforehand. Switch that. There we go. Sometimes the order on this is really important, so you may double check your order when you're printing these things out. It also helps if I change it to 1. So in this case it might not be the order. I wonder if it'll go back here as 1. There we go. So it doesn't matter the order on grid. But you can set the grid for easy viewing here. Nice setup on there. But you can see how we can limit the data. So let's start looking at some other 2D graphs and make this cell a markdown. So when we run it, it has a nice pretty title to it. And let's go ahead and create some data with an NP array. We'll do 0 to 5 on here. There we go. And let's look at 4 common graphs. We'll put them side by side. So we'll do a figure. Our axes equals plot, subplots, 1, 4 columns, and then figure size. Hopefully it'll fit nicely on here. It seems to do pretty good on here. And I'll go ahead and just run that since we're in there. Run. You'll see I have 4 blank plots on here. And we'll start with axes of 0. Let's set title. And we want this to be a scatter plot. A scatter plot just means it has a bunch of dots on it. So here's our axes of 0 dot scatter. Easy to remember. Scatter a bunch of plots on there. We'll do our n, or we can do x or n. There we go. And let's go ahead and do axes set title scatter. Oh, already did that. We're just going to do scatter. That's how you do it on there. That is how you create a scatter plot, simply with the scatter control. And we'll do, let's do the variable x plus, let's throw some randomness in here. Usually scatter plots have a lot of random numbers connected to them. That's why they do them on there. And so the bigger the x gets, the bigger the randomness, so 0.25 times the randomness. And what we should end up down here is with the scatter plot. And you can see as you go up, it just kind of has some random numbers and moves up and down the line. But plots just the points. So if you remember from back up here where we did marker, this is plotting basically just the marker. So it's a scatter plot. Probably less used is a step plot. So for axis 1, we'll go ahead and do a step plot so you can see what that looks like. And this time I'll use our n value instead of x. We generated that n value up here. And so for this we have n times 2, or n squared, n times 2, n squared. Line width equals 2, and if we run that, it creates a nice step up. Let's see, so we've got a scatter plot, we've got a step plot. Let's do a bar plot. And we'll use the same formula, n squared, alignment centered, because you can have them to the left or right, width 0.5, and alpha, if you remember correctly, that's how opaque it is. Let's see what that looks like on there. So we have some nice, you can see here a nice bar plot. It should look very similar to the step plot, but colored in. And we can change the width. Let's see what happens when we do 0.9, run. And if we take width out completely, run that, you can see it starts coming together on there. And we can change the alpha. We can take the alpha out too and run that. So now you have the solid colors. And if we take out the center and run that, everything, you really can't see the shift on here because that's actually the default on this. But these are common settings for the bar graph. Let me just put them back in there. There we go. Alignment, center, and alpha. Now, I can't say I've used the step graph very much. There's certain, I guess, domains of expertise that require a step graph. But the scatter plot and the bar graph, very common, especially the bar graph. And we'll look at histograms here in just a minute. So I use histograms a lot, especially in data science. But this is nice if you have very concrete objects. How many people are wearing yellow hats? That kind of thing. But if we're going to do that, let's go ahead and do the last one, which I see a lot more in the sciences. I'm certainly using the data science, but more like for mapping. I saw a publication on solar flares, and they were discussing the energy, and so filling in the graph gives it a very different look. So we're going to do the fill between. And it's just like you think it'd be. It's fill between, but with a underscore between them. And we'll do x and x squared and x cubed. And we'll do color green and alpha again, in case you had other data you wanted to plot on there. You can see it forms a nice squared coming up here. And also, if you look at the bottom one is your squared value, the upper line is your cubed value, and then it fills in everything in between. If you remember from calculus, this would be if you had like a motor and efficiency, they would talk about the efficiency going up and the loss, and you're looking for the space or the area between the two lines. So it gives you a nice visual of that. And let's look at a few more basic two-dimensionals. So we're going to have our figure size on here. We're going to do a radar chart. To be honest, I've never used a radar chart in business or in data science. I have to find a reason to use one now. So the first line for doing a radar chart, we have to add axes into the figure. And with this actually creates our, let's run it so you can see what it creates. It creates a nice, looks like you're on a submarine and you're tracking the hunt for red October or something like that. And it needs all of these. The polar is the fact that we're doing polar coordinates. 0.6.6 has to do with the size. If you take out any of these things and run them, you get just a box. If you take out the other half, you pretty much get nothing in there. And if you change these numbers, change them a little bit, you can see it gets bigger. They had 0.6 on here. I'll go ahead and leave it as 1 because that's just kind of fun. But that's all about the size on here, the height and the width. And then let's create some data. T equals NP line space. And this is 0 to 2 times NP times pi. So if you remember, that is the distance across, and we're going to generate 100 points. So this is just a thing of data we're putting together. Then we can simply do an ax.plot. And in this case, let's do t comma t, which would be a diagonal line on a regular chart. And we'll give it a nice color equals blue. And line width equals 3. Let's see what that looks like. And we can see here a spiral coming out. And remember, this would be just a diagonal line on a regular chart. What happens if we take this and instead of t times 0.5, there we go. And you can see it slightly alters the way it spirals out. We could do t times 2. Spirals out a little quicker. So it's kind of just a fun. Like I said, I've never used a radar chart. It's a column. But you can always think of radar in a submarine. Kind of looks like one of those, or in an airplane. And none of this would be complete if we didn't discuss histograms. Oh my gosh, do I use a histogram so much. And we'll use our NumPy that we have set as NP to generate, it looks like we have 100,000 variables we're going to set equal to n. And of course we create our figure and our axes. Subplots 1, 2, figure size 12, 14. So we're going to look at 2 different variations of the histogram. And we'll set a title, default histogram, set our title there. And then this is simply hist for histogram, and we'll just go ahead and put in our n in there. And let me run this and see what that looks like. And let's talk about what is going on here. So we generated an array here of data, 1,000 random arrays. It looks like they're mostly between -4 and 4, and then it adds up each one. It says 0, you have 35,000 that are 0, so that's what's most common on here. And we have 20,000 that are somewhere in this range right here between the -2 and, well, it looks like 1 and -2. And somewhere between 0 and 1, there's 30,000 numbers. So all this is saying is this is how common these variables are. And this will point you in so many directions when you're looking at data science to go ahead and run your histogram. So you should always have your histogram, and you can always put limits and all the other different things on your array, just like you did on the other graphs on there. And then we're going to do a cumulative detailed histogram. And all it is a histogram. Let me just do that. And we set cumulative equal to true and bins equal 50. And I really want to highlight the cumulative equals true is important. But we can now choose how many bins we have. In the first one, it kind of selected them for us. In this case, let me go ahead and run this. And you'll see it prints the data out for us. And here's our, whoops, must have missed, oh, there we go. It doesn't help that I put it over the old one. There we go, okay. So now you have your default histogram, and then we have a cumulative histogram. And we should have 50 steps in there. And let's just find out if that's true, not so much by counting them. I'm not going to count them. If you want to, you can count them. Let's just change it to 10 and see what happens. And we see here we have now 10 counts of that. And we could set that for 5 and run that. And then we have our 5 on there. And we go ahead and take the cumulative equals true out, just so you can see what that looks like. And let me run that on here too. That looks just like it did before. I think there's what, 1, 2, 3, 4, 5, 6, 7, 8. They have 8 different bins on here, is what the default came out of. Put that back in there, run. And so now it should look almost identical, and it does. And then we can put the cumulative back in, see what that looks like with the cumulative. And run that. And we can see how that shifts everything over and has a slightly different look. Wait, it shifts it all to the right? No, it doesn't actually shift it to the right. It's cumulative, so it's the total of the different occurrences. And so what that means is, like, if you consider this like for the year of rainfall, we have like day 1, you had a little bit of rain. Day 2, we have more rain. And so if you look at the number, this is 100,000, 35,000. So it's a cumulative detail, the histogram, the occurrence as it grows. And rainfall is a good one, because that would be a cumulative histogram of how much rain occurred throughout the year. And we're going to look at 2 more graphs. We've already looked at a bunch of them. We looked at our radar graph. We've looked at scatter, step, bar, fill in, basic plots. We've looked at different ways of showing the data. You know, we can increase the size of the line, the look, the color, the alpha setting. So let's look at contour maps. Just put that in there. There we go. Draw a contour map. And before we draw a contour map, we need to go ahead and create data for it. And if you have contours, your data is all going to have 3 different values. So let's go ahead and create the data here. We have our, you'd import your Matplot library, your NumPy, so we have our numbers array. And we'll import matplot.cm, and that's your color maps. So you have all these different color maps you can look at. There's like hundreds of color maps. So if you don't want to do your own color, you can even do your own color map. They're pretty diverse. And of course our PLT, our PyPlot. And to generate our different data, we're going to create a delta 0.025, and we'll start with x. And we're going to create an array between -3 and 3 in delta increments of 0.025. And we'll have our y, we'll do something similar, and then we'll create our xy into a mesh grid. Again, these are all NumPy commands, so if you're not familiar with these, you'll want to go back and review our NumPy tutorial. And we'll do an exponential on here, -x squared minus y squared for our z1. We'll do a z2, so we have 2 different areas, and z equals z of 1 minus z2 times 2. So we've created a number of values here. And let me go ahead and run this, and let's plug that in so you can see where those values are going. So once we've set these, we're going to create our figure and our x from our PLT subplots. We're going to create the variable CS. And this is going to be our contour. So right here, CS is our contour surface. And we're feeding it X, Y, and Z. And if you remember, X, Y we created as our X and Y components using our mesh grid. And you know what? Let's do this. Just because it's kind of good to see this. Let's go ahead and print X. And let's print Y. And I always like to do this when I'm working with something that's either is really complicated, in this case is what we're looking at, or you don't understand yet. So we've created a mesh grid. We have x, y, and when we're done with this, we end up with, here's our x, and this set of values, and our y. So these are x and y coordinates. And then we've also created z based on our x and y. So we have x, capital Y, and capital Z as our 3 components. X and y being the coordinates, while z is going to be our actual height, since we're doing a contour map. So we created our contour map from our x, y, and z coordinates. We want to go ahead and put in a C label. Maybe we want to go ahead and do a title on here. We'll put that in our set title, and this is a contour. There we go, contour map. And let's go ahead and run this and see what that looks like. And you'll see we generated a nice little contour map. There's different settings you can play with on this, but you can picture this being you're on a mountain climb, and here we have a line that's represents 0, maybe that's sea level, and then moving on up you have your contours of 0.5 and then -1 and different setups, little hills. I guess if it's minus, that's like a pit. So I guess you're going down into a pit at -5 and -1. And on the other side, you can see you're going up in levels. So here's a mountaintop, and here's like a basin of some kind. And in data science, this could represent a lot of things. This could also be representing two different values and maybe profits and loss. I don't know if I'd ever really do that as a contour map, but I'm sure you can be creative and find something fun to do with a contour map. And then we're going to look at one last map, which is the 3D map. And those can be really important as a final product because they can show so much additional information that you can't fit on two-dimensional graphs. And we're going to cover the Scikit-Learn tutorial, which has a lot of features and all kinds of API in it to explore data and do your data science with. In fact, it's probably one of the top data science packages out there. So what is the Scikit-Learn? It's a simple and efficient tool for data mining and data analysis. It's built on NumPy, SciPy, and Matplotlib, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the Scikit-Learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the Scikit-Learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, it might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a Scikit-Learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wines. So it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine-tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features, dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column. And by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that. And we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default, it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. And we'll go over here to New and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the Scikit-Learn works with any of the 3X's. There's even 2.7 versions. So it's been around a long time. So it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize Pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of Matplotlib. So this is for our graphing. And we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the Scikit-Learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the Sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the Sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage Matplotlib inline. Some of the Seaborn and Matplotlib will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to Pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the Pandas, so if you haven't yet, go look at our Pandas tutorial. A simple read the CSV with the separation on here. And so let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. I'm separated by semicolons. That's important to notice. And when we open that up, you'll see we have Go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see that quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a Pandas, we'll just do wine head, and that prints the first 5 rows of data. And that's, of course, a Pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what Pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma-separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in Pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8 basically, or 1 and 8. We have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a Pandas. So PD, remember, stands for Pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command. And then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. Wine quality, since that's what we're working on. And let's look at unique. Another Pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is bad or good. So we have two qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of Scikit-Learn. That was one of the things we imported, was a label encoder. You can see that right here from the Scikit-Learn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used is fit transform and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combined them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this, you can see right here underneath quality 0, 0, 0. I have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple Pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph so we can take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our seaborn. Seaborn sits on top of Matplotlib. It has a lot of added features, plus all the features of the Matplotlib, and it also makes it quick and easy to put out a graph. And we'll do a simple bar graph, and they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine, and our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off, or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set, or reformat our data set. And we usually use capital X, and that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine. It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from Scikit-Learn. And the actual package was train test split, and we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables, and most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the Scikit-Learn model selection, import train test split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number, so it's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today. There is, and it's not even an Scikit-Learn package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a test set, one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an Scikit-Learn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the Scikit-Learn models we're going to use, we covered a lot of ground here. When you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. and we're looking at the bins. So this would be something you might start playing with. Maybe you don't want superfine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all Pandas we're doing in here. Setting it up with unique labels and group names. Bad, good. Bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up, X-train, X-test, Y-train, Y-test. And that's using the train test split, which is part of the Scikit-Learn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to Markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of parts, moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for Random Forest Classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the Random Forest Classifier from Scikit-Learn Ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there in setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the Scikit-Learn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier, and we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest. So how many models are in here. That makes it pretty good as a startup model because you're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, .fit xtrain, Y train. So we're sending it our features, and then the quality in the Y train, what we want to predict in there. And we just do a simple fit. Now remember, this is Scikit-Learn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our train values, so now we need our test, our X test. So this has done it. This is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build. And then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them, but what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the Scikit-Learn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our Y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out, and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other 2 models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with Y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we called this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X_test. And right about now you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. Let's go ahead and run this, and then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code, and the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90% And down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data. So if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have, maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Pictures. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers, and you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X-train, Y-train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict X test. Let's just put that down here, .predict X test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste, because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling, what's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, naive Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree, there's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see there's in Scikit-Learn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our Scikit-Learn metrics. We're going to import the accuracy score. And I'm just going to do this on the random forest, since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3.58 and so on. And then it is so important. This is where people forget this step. X new equals sc. Remember sc? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an sc, we fit it, and we transformed it, and then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our x new, and then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model right there. Let's go ahead and just grab that down here. And so our y new equals, here's our RFC predict. We're going to do our x new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our ex-new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the Scikit-Learn, our random forest, our SVM, and our MLP classifier. So we had our support vector classifier, we had our random forest, and we have our neural network, three of the top used classifiers in the Scikit-Learn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course, we needed to go ahead and split our data up in our Matplotlib train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our three different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest for cooking. Certainly there are many reasons to be able to go online and scrape different websites. They range everything from pulling out different links to pulling data off of websites. As a data scientist, you might need to get some information off a website that doesn't have a direct API to pull that information. And in Python, we have a wonderful tool. When you talk Python and you talk web scraping, we're talking Beautiful Soup, which is a package you add into your Python that you're running. And we can come over here to the website, www.crummy.com/software/beautiful-soup. You can actually read a little bit about it. Currently, Beautiful Soup 4 is the current version. If you don't remember the full website for it, you can always do what I do, which is go over and do a search for Beautiful Soup official site. And it almost always comes up right at the top, and you click on there and it'll take you to the crummy.com software site for Beautiful Soup. Now, we're going to use our whatever Python interface you want, IDE. I'm going to use Jupyter Lab, which is built on Jupyter Notebook through Anaconda. So when I open up my Anaconda navigator, you'll see that I have my different tools available. Again, you might be using a different editor, and that's okay. You might be in PyCharm or something like that where you don't need to do this. And Jupyter Lab is Jupyter Notebook with added tabs and some added features. It's basically in beta testing, so it's got a few little glitches when you're saving things and moving between projects. But for the most part, it's a great upgrade to the Jupyter Notebook, and you can use them together. So you don't have to, it's built on Jupyter Notebook. So anything you do in Jupyter Notebook, you can open up in Jupyter Lab. And the first thing we need to do is we need to go ahead, in this case I'm going under my environments since it partitions the environments out, and I'm going to open up a terminal window. We have to install some packages in here to work with. Now there's a lot of choices on this. Because of the simplicity, will be using conda install. Now you can use pip install for the same thing, and we're going to install our Beautiful Soup 4. And you have to type out the whole thing, Beautiful Soup 4, and you can use a pip install if you're using a different environment. And I am using Python version 3.6, although according to Beautiful Soup, they also work on 3.7, all the way from 2.7 through all of 3x. Now, according to the Beautiful Soup website, the Beautiful Soup 4 works on anything, you can install on anything from Python 2.7 all the way through any of the Python 3 versions. This just happens to be Python 3.6 because there's a lot of other packages that don't work on 3.7 yet. And we'll go ahead and run this install on here and let it go through its environmental setup. And of course with conda, it goes in there and finds all the dependencies. Pip doesn't do as much as far as finding dependencies, but you know exactly what's on there with pip. So if you're doing a huge distribution, you probably want to use your pip install so you can track what's going on there. With the conda, I like to just let it take over since this isn't a major distributed package going out. Another quick note between pip and conda is that if you start on a project in one of these environments and you're using pip in there, stick with pip. If you're using Conda, stick with Conda. They track the packages, and you can run into some issues where they're not tracking the same packages and something gets overwritten. So it's important to stay very consistent with your install on your environments. And we'll also need to go ahead and install our NumPy environment and our Pandas on here. So go ahead and do that. If you haven't added those packages in, go ahead and install those into your environment that you're working in. And of course, Pandas is just simply install Pandas. And let's just install a couple more packages. In this case, let's get our install our Matplotlib, because we're going to plot at the end since we're going to be collecting data. And for this project, that will be all the packages we'll need. So we can go ahead and close out of our installer or whatever setup you have. And we'll go back to home and we'll just launch our Jupyter Lab, and that will open up in our browser window. Now, if you're coming from Jupyter Notebooks and first time in lab, we can go ahead and just create our first notebook, Python 3. You can also do it under File, Launcher, and you'll see New Notebook. It automatically opens up and we can just click right on there. It'll pop open on the left, and I'll right click this and we'll rename this. We'll rename it just Beautiful. And it is a IPyNB file on there. So that should look familiar because that's a Jupyter Notebook file. This is a new one. Now, I have multiple tabs, and in the past I usually hid this on the other computer, all my notes for the lesson today. But this is my notes going down, and we'll go ahead and just start going through this and see what it looks like to do a data pull from front to end and see how that works as a data scientist pulling that information in from the website. And the first thing I want to do is I want to go ahead and close this side window. That way it looks, get the nice full screen. And we can also up the size a little bit. One of the wonderful things about working in a browser window, just do that Control+ thing. The packages we talked about is Pandas. So we imported our Pandas if you haven't already. That's our data frame. If you haven't done our Pandas tutorial, definitely worthy of the time to go through there and understand Pandas because it's such a powerful tool. This basically turns your data into a spreadsheet data frame. Our NumPy is our number array, so it kind of works with Pandas very closely as far as manipulating data in arrays. Matplot, we want to go ahead and bring that in, our PLT, so that we can plot the data at the end. And this line right here that says Matplotlib inline is for the Jupyter Notebook specifically. It tells it to print that on this page. A lot of the newer versions don't actually require to have that line. They'll still print it on the page. But you should still include that if you're in the Jupyter Lab setup. And then we have our URL library.request. We're going to import URL open for opening up the website. And then we have our BS4, that's your Beautiful Soup 4. We're going to import Beautiful Soup. And then our last one is our RE. That is for manipulating our regular expressions. So when we get to that part of importing our data, we have to do a lot of reformatting so it's something we can use. And the RE is one of those tools. We'll go ahead and run this and just bring all that in. So this is all imported. All these packages are now into our web scraping program we're going to run. Now, if we're going to dive in and pull data, we should have a nice website to pull from. And let's go ahead and we'll use the HubberTiming.com results for the 2018 Martin Luther King race. And if we take this, you can actually just take this, where did we get this from? Well, you can go in here and find the website you're going to scrape from, and you'll see right here it says you just copy that link right in there, that HTTP. And this is the website that we're looking at, and you can see right here all the information that we're looking at. Let's say we wanted to run some statistics on this. It sure would be nice to be able to pull it off of here. And if they don't have a direct API, that means we need to pull it from their website. Some of these will have a download, although if you've ever done it where you have a download click and maybe you're paging through 100 websites. In one case, I was pulling all the different United States bills that are passed to track who voted on them for a project. And you can imagine that there's hundreds and hundreds of those, thousands of these documents that they voted on, who voted on it. It goes through the Senate, it goes back to the Congress. So I opened up a website, pull all the links off of there that match a certain criteria, and we'll look at that in just a minute, how we go through the HTML. And then I had to reformat them, or I could hand download each one at a time, which would just be a nightmare. So it's nice to automate it. In this case, we're going to be pulling up this chart, and we want to figure out how to pull this chart off of this website. And so when we go back into our Jupyter Notebook, I've got my URL, just our name for it. it, and it's just a string. That's all this is. Nothing fancy there. You'll notice that on the slashes, we now have forward//. You can do a single forward, and HTTP is a double forward. This is just how you have to switch it to match setup in there. And then it's going to go ahead and use the HTML equals URL open URL. And that's from our URL library request. So it's opening a link to that website, or at least pointing to it. And if we run this just sets it up. So this is all set up. And then once we've done our setup, let's go ahead and create an object called soup. This will be, and if you remember up here, here's our beautiful soup that we imported from the BS4. And this is the package that we're working with. And so we're going to do our beautiful soup on here. And on this, we need to go ahead and send it our HTML so it knows what it's opening. And then the second part is we have to tell it how the format is coming in. And the most common one for your HTML polls is an LXML setup. And so almost all of them you'll end up using the LXML. There's a few other options. And because this is so common in the newer versions, a lot of times they just leave it out just because it's already on the default. We'll go ahead and leave it in here just to remind us that it's there, and we'll go ahead and run that. And on the newer versions, they actually default it to the XML setup and the HTML. We'll just leave it out and call it HTML. So it's just going to pull from this URL. And when we run that on here, we've now created an object soup that has pulled the website into it. So soup contains the information along with information on that website and what's going on. So let's just go over what we did real quick before we start digging into the actual soup, before we start scooping out stuff. We imported our different modules that we're going to use with our package, specifically the beautiful soup. We did install the beautiful soup. If I remember correctly, you have to call it beautiful soup 4 specifically, so it knows what you're bringing in. And this line right here is very key. From BS4, because that's how it installs the module, we're importing our beautiful soup. And then we found our URL. In this case, we're going to go pull information from the Martin Luther King Dream Run. And then we set our HTML to our URL open URL. And you can see right here we imported that. So here's our URL.request, import URL open. So we're requesting a connection. And once we send that connection into the beautiful soup, it creates an object called soup. And then this one, of course, we chose soup just because it goes with beautiful soup. I guess we could have chosen beautiful. And now we can start extracting information from our website because we've pulled it down onto our computer under soup. Now we can start by looking at the title of the website, soup.title. And if we print title.text, you'll see this a lot in beautiful soup because title contains all kinds of information, and if we want just the text from that title, you add the .text on the end. And you can see right here we have our 2018 MLK Dream Run 5K race results. If you look at the tab, that's the actual title up here, 2018 MLK Dream Run 5K race. That's what the title is on the website. And then you might be curious, what's in title? What's the whole title that it's storing up there? Well, let's go ahead and print it out. Here's print title and print title.text. And when we run that, you can see it has the HTML tags title on it, and then the / title to end it. And so we're really just pulling off this piece of the HTML code, and then we look at the text inside that particular part of the HTML. And earlier I mentioned links. What if you want to get all the links off this page? Well, that would be fun. We could do soup dot, and we'll do find _ put this in bracket, and then quotation marks, we'll go ahead and put A. A is the key find, and you'll start seeing a div and all the different options you have for finding these entities in a website. And then let's go ahead and just print our links, and you can see here that it now shows all the different links in here that are marked by A, because we did a find all A. And then we can also, because this is a little bit hard to pull off the H reference, so we can also add in our find all, fine tune that. In this case, the H reference equals true. We'll actually filter that out. And then finally, we might do a for link in links, and we can simply do something like this for each link. We want to actually find the H reference because we know there's an H reference in it. And if I run this, you can see it just comes through and prints them out one at a time. Some of these are really useful. So you might be looking for something that has HTTPS in it, and you know that's a link running to something else. Or you might be looking for the mail to tag, so you know that's all the mail addresses. But either way, you can easily find all the links in your HTML document that you're paging through. And of course, any packages that have evolved over time time, you can also do link.get hrefs, which should do the same thing as our other format. And you can see it certainly does. We get the same printout up here. In this particular case, we really want to get the data off the page. So let's go ahead and do that. Let's see what that looks like. And in data, let's call it all rows. There we go. Equals. And then we have our soup.find_all. There's our brackets. And then if we're looking for each row in a database, you'll remember your HTML code, we're looking for the tag tr. So we want to find all tr. And we can take this, and let's go ahead and just take all our rows and do a print all rows. And about this time, you're going to guess that we're going to get a huge amount of information just dumped onto our page. And sure enough, we do. If you look at this, it just kind of goes on forever. But this is an array. Each row is considered an array. So because of that, we can do something simply as putting brackets and just print the first. Let's do the first 5 rows. So from beginning to 5. And you can see here's our first 5 rows on here. I sometimes like to just do, let's just do row 0. And we see that row 0 is finishers. Finishers 191. And just out of curiosity, if that's 0, what's row 1? Mel. Okay, so we're starting to see titles going across here. So if we come up here and we do rows, we did what, up to 10? Let's just take a look and see what 10 does again. And just take a look at that information that comes across. Place, bib, name, gender, age, city, state, chip paste, gender, and so on. So it comes all the way down here. We kind of have an ending right here, and then we have 1, and then we actually, it looks like we start to have information. So we have our 1, our 1191, Max Randolph, that must be the name, Mel 29, and so on. You can start seeing how the information starts getting displayed going down. So the next thing we want to do with this, and I'll go back up here and just edit the space we're in so it starts to make a little bit more sense. Keep it all together. And so we want to do for each row in all rows, we're looking at, what information are we looking at? Well, we have our TH up here, that's the header, our TD down here, which looks like the individual information. And we really are looking for the actual data. So we're looking for our TD tags in the rows. And we can do that because remember when it stores the row, it also stores the tags underneath that. So all rows have all the different tags in it. And you can see right here as you print each one of those out. And so when we look at each row, we can create another variable and we'll call it row list. And we'll set this equal to, in this case, row, because we've already pulled all the rows out of soup. So now we want to find for each row, and in there we want to find our TD. And if we go ahead and just print, I'm going to do it, if you notice I changed the indent, so I'm just going to print row list. What this does is the last value to go into row list, our last row is going to print now. And of course make sure you have an underscore instead of a period when you're typing. So row.find_all TD, and if we print the last row, you can see I have all the data coming across here. We have our 191, our 1216, Zuma, Okchoa, I hope I said that right, female, I believe that's age 40, and so on. And then we can take our row list, and there's a lot of things we can do with the row list. But we'll do let's do object, or let's just do cell in row list. And so we're going to look at each cell, because this is, if you look at this, they have commas separated between the different objects. And then we're going to go ahead and print cell.text. And let's just take a look and see what that looks like. And we can see here for each row we get 191, there's our 191, there's our 1216, 1216, our individual who's in the race, and so forth all the way down for those different settings. And let's go ahead and create a new variable up here. We'll call this all, let's just call it data. We'll keep it simple. So here's our data, and then we have our row. We take our row and we break it up into individual cells. So we'll call this data row, and we'll set this empty to an empty row. And we're going to take our cells, tab this, and we know that each cell generates a text. And so what we want to do is I want to take my data row, let's just replace that. Let's take our data row and let's append our cell.text. So I'm going to add each row is going to be a row of the different text on here. And then once I create each row, I want my data, which is going to be everything, to append each row. And here's our data row. And then if we go ahead and come down here and let's just print data. Now, if we were working with large data, we'd be very careful about just throwing all our data on the page. But you can see here, we throw the data on the page and we get finishers, 199, male, 78, female, 113, 1, and so on. And if you look at this, this is the headers on the file. We have finishers, male, female. It's just like some general statistics on the first one. And then we have actually an empty data set, and then we have our data that continues, which the actual information we're looking for. So we have 1, 1191, Max Randolph, male, 29, Washington, D.C., runtime, 1 of 78, and so on here. So we could really quickly get rid of that. A number of different ways to do that. One of them is just to do, we're going to set, if we do data 2 on, we should get rid of everything, but we want to keep Randolph, so make sure Randolph is in there. Oh, we lost Randolph. Let's try 1 on. There we go. There's Max Randolph on there. So we can just simply redo our data on here, and we can do data. Probably want to do it in all rows from 1 on, but I'm just going to do my data equals data 1 on down here. There's reasons to split it this way. In data science, sometimes you don't want to touch the original data in case you need it, in case we do need the first row. So we'll put it down here, and maybe we'll just call this titles. Titles equals data of 0. And so we could do something here where we print, and we'll print up our titles, and we'll print our data. In this case, instead of 1 on, let's go -2. Let's look at the last 2 rows of data. So here we have our titles, and for some reason I just put in finishers of 191. I was expecting a little bit more up there. And we have our last couple people, and they look like the data on these looks just fine on here. Turns out this is just some generic statistics up here. So we'll get rid of titles completely. It doesn't really do us any good. But we know that data comes in here, and we can look at our data and look at the very end of the data too, the -2 to the end. And we can see it pulls the data in pretty good. We don't have anything too funky in here we're looking at. It looks pretty clean. Now you got to be a little careful, because at some point we might have to come back here and clean up the data if we get an error for running data analysis. We might find out there's some unusual characters or something is misset in the data itself. And you also notice that everything is a string. So when we're bringing it in, we might have to do some conversions to test it out and convert them to whatever kind of data format we're working with. So at this time, we want to go ahead and bring in our pandas. And let's go ahead and call this df for data frame. We'll set it equal to, and if you remember correctly, we imported pandas as PD, and that's standard. You'll see that in most code examples where they import pandas as PD, and it is capital D, capital F for data frame. And we're just going to bring in our data. That's what we called it on here. And let's take this and we'll print. Now, when you're working with data frames, you're usually talking large amounts of data. And so you almost never want to print the whole data frame out. We're going to go ahead and do that anyway, just so we can see what that looks like. And you can see in here, it brings in our data frame coming in here. We just have a mess of information. This is our data. Let's go ahead and print df and see what that looks like in the data frame. And this is nice because it organizes it into a very easy to read table. And we have, they set the label 0, 1, 2, 3, 4, 5, 6, and so on. And then we have each row. We have male, 78, none, 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 going across. When we get all the way down here, we'll see Max Randall about number 3. And the first thing this does is this flags me that I brought in a bunch of information up here that we really didn't want. It's from 3 on that we want. And we can clean this up in one of 2 ways. We can try to clean it up under the data, or we can clean it up under the data frame, depending on what it is we're trying to do. And so to fix this, I want to go ahead and just change it up here in the actual data pull-in. We don't need that information. So I'll rerun it, reload our data from 4 on. And then when I run this, we see we have Max Randolph is right at the top of the list like he should be, and we have all the data going down. Now with the data frame, remember I said we don't usually print the whole data frame. We'll go ahead and do df.head. And this prints the first 5 rows. And you can see that we have 13 columns. Here's Max Randall all the way to Theo Kinman. And I usually also print df tell. And the reason I like to do these particular 2 setups, and I'm going to change it just to 2 rows, because you can do that, you can print as many rows as you want, is it's good to look at the first part and the end, because those are usually where you have extra data brought in, something's messed up. And you can also see that we have 190 rows in here. And it comes in with our Zulma, Lisha, and they're both on here on the list. So now we have a nice data frame, columns and rows. We can easily look at it, we can see the setup on here, and we can look at the names and everything. Now, at some point, you might be looking at these individual columns and find different information that needs to be re-edited. If you can, you try to do it with the whole column under Pandas. You can, up in the upper part of the code where you went from cell to cell or row to row, you can look at individual cells. Maybe you find a marker in that cell that's something specific, like remove all colons or semicolons or something in there, or brackets. So there's a lot of options in there. But you'll find that this one actually comes in pretty clean on here all the way down. And the next thing we really want to do is we want to look at the headers. I don't know about you, but it doesn't make any sense to me when I have column 1, I don't know what 1191 is or 1080, need name Kaiser runner. I'm guessing that's column 2 is names. Third one, it looks like male or female, probably age, but I don't want to guess. I want this to bring in my column so I know exactly what I'm looking at. So how can we make Beautiful Soup do that for us? Well, let's take our column headers. We're going to set that equal to our soup find underscore all, and then we're going to look for our headers, our th files. And since we're in Jupyter Lab, in this case Jupyter Notebook, I can just type out column headers. If it's the last variable I have listed, it'll automatically print it. So it's kind of a shorthand. And we can see right here we have place, I'm guessing that's bib, name, gender, age, city, state, chip time, chip pace, and so on. So we have all our headers right there. I shouldn't have to type them all in. And we'll go ahead and do it before. We'll go ahead and do a header list equals our empty array. And then we can do for column in column headers, and we can take our header list and just append. And what do we want? We want the text from the column, so we'll just do column.text. And then if we come down here and we print our header list, let's see what that looks like. If we did it right, we should get a nice list of all the different column headings we want. So we have place, bib, name, and so on. And then Pandas, just because Pandas is so cool, we can simply do df columns equals our header from our header list. We can simply set df columns set to df headers, and then if I print df.head, we'll take a look at that, and we'll see right here it has nicely placed our values on here. Place, bib, name, gender, age, and so on. So very quickly we've created this nice data frame. We have the data displayed in nice rows and columns and easy to read. And then as a data scientist, the first thing we want to know is the info. What is in these columns and rows and headers? And you see right here they all come up with non-null object. There's a big flag. So if I want to do anything with this, these are all coming through as strings or an object. I usually mean strings in this case, that they're a string variable. And we have, you can quickly read through this, 191 entries, date columns, total 14 columns. There's a total of 14 columns in the data, and it shows you all the different names and what type of column they are. And it's probably good also to look at the shape of the data. df.shape, we'll go ahead and just run that. You can see it's 191 by 14, 14 columns, 191 entries. This is more like the way you look at a NumPy array, 191 by 14 for the shape. And remember, this is a variable, so if I put it on, if it's a last variable or last value in the set of cells, Jupyter automatically prints it out. So if you're in a different IDE, you'd want to go ahead and use the print statement on here. And then one of the things you'd want to also go through, we'll create a second one, df2 equals df.dropNA. Now the axes is automatically equal to 0. So a lot of times you'll see something like axes equals 0, comma, how equals any. Axes equals 0 is default. That means we're looking at going down the rows. You could look at the column going across. Let's remove the how any because that's just going to confuse you. The axes is whether you're going down the columns or if you're looking at it row by row by row by row. Or you could be looking at it by column by column by column. This would drop any column and it would drop off the NA in any column. And how equals, and we want any. I always confuse all and any because they both start with A. All means that all of them have to be non-value, where any means that any of them can be there to drop it. So this would drop any column with a null value in it. But we want 0, and it'll drop any value with a null value. And then because 0 is always the default, we'll just leave it out. And then it's curious as to what the shape is now. Did we lose anything? Was there any null values in our df2 that we dropped from the df? And we'll go ahead and run that. And we see 191 and 14. So we didn't really drop anything. But it's always good to check. There's other ways you can also do, are there, let's see, any NAs? You can detect NAs in here. Null values, infinite values, that's another one you got to watch out for. We're working with data that we're going to do something with here in a minute. So you got to be a little careful also in the conversions. Are you going to convert something where people typed in weird characters to describe the data a certain way. So now we've got to this point where we have all our different columns, we have our different data, and at this point maybe you're asking, or maybe the shareholder of the company is asking, hey, can we look at the, based on the chip time, here's our chip time, can we plot that versus gender? How does gender versus chip time compare? And so we can do that. We can take that, and the first thing we look at is we say, hey, well, chip time came in as a string, and that's going to be an issue. Now, there's a number of ways you can change this. One of them is we could go all the way back up here where we created the data and find a way to tag it and say, hey, whenever this cell text, maybe instead of appending this, I noticed that anytime there's 2 colons in it, that's probably a time signature, and let's convert all the time signatures to date time field or whatever. A lot of times you don't get that. You don't get that option. And that's always a question in bringing in data. Whether you convert the data coming in at the beginning, or do you wait till you have it, open it up, and then convert it when you go to use it. We're going to go ahead and convert it after we got it into our data frame. So we have our df2 here. We've dropped all of our NAs. We have a shape. In fact, let's do this. Since there's no difference between df and df2, well, we'll just go ahead and use df2. So let's go ahead and take our df2, and we want to take that specific field and convert it into some kind of numerical value we can use. And let's add another column. A lot of times this is something you want to do is where you want to go ahead and keep all the original columns and just add a new column in there. And this new column is going to be based on the, if we remember correctly, we had chip time. That's what we're going to look at. Okay, we want chip time versus gender. If we go into our pandas, we find out we have pandas to delta, and this is actually time delta. And then we just want to take our df2, and we're going to use the chip time column. So this is going to say, hey, let's look at, let's convert everything in df2 chip time into a time delta format. That's the data type we're going to put it as. And we can go ahead and just run this. And if we go in here and we do info, df2, and we'll keep our, we're going to look at this particular column, but we want to keep it as a data frame. So this is a list of all the columns we want to look at. We'll just do .info on here and run that. And we do an info on that. You can see it's now a time delta 64 nanoseconds. Well, we really don't want nanoseconds. We actually probably want to do it in minutes. So let's take a look at that. And let's take this whole thing, df2. Let's just set the df2. We have our df2. This is a column we're working with here. And we can use the as type property in Pandas. And so we can set this equal to df2. We'll take our same column in here, and we'll set it as type time delta second. So it's still a delta time here. So if I run this, you'll see that it still comes up as, where is it? Oh, it turns it into a float. So we're now at a float 64. So it's a number of seconds in that delta time. And then finally, we want to go ahead and turn that from seconds to, say, minutes. And, you know, there's 60 seconds in minutes. And so now we divide by 60. We still have a float. We have our info that shows us it's a float. And then we can go ahead and just do a print df2. And let's just keep it small. We don't want to look at all our data. We just want to do the head of it. And we run this, and you can see right here where we go to, it'll be the last one. Here's our chip time in minutes. And a lot of times, just to make life easy for viewing, since we're only looking at this particular element, we can do chip time in minutes. And now we just see that, oops, we take off. We'll go ahead and take off our info. Done with that. And we'll run this. And you can see we have our minutes. 16.8 minutes, 17.51 minutes, and so on. It's a float number. Now keep in mind, this is 0.8. That's not 16 minutes and 80 seconds. They can always throw you if you're going through so many numbers you forget. So important to remember that. And we're also going to look at, the other one we're looking at is what? Gender. You want to look at gender to chip time in minutes. And so we can see here under the head, we get male, 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 and a number of different setups. And let's switch this to tail real quick and just look at the end of it. And here we have female, female, male, female, female. So we have two different genders, and we have our chip time in minutes. And if you remember, we brought in our PLT. If you haven't used the plot library, the Matplotlib library, you have a drawing place you're putting stuff on. So we have our PLT. We're going to do a bar graph, and we just want to simply use our df2 gender and df2 chip time in minutes. So that's going to plot the two bars. And to make it pretty, we'll go ahead and give it the X labeled gender, the Y labeled chip time minutes. And that simply is, remember, it always plots X and it plots Y. We have our gender, our chip time. Give it a nice title, comparison of average minutes run by male and female. And if we go ahead and run this with the correct titles in here and everything matches, you'll get a nice graph. We can see here the comparison of average minutes run by male and female. Here's our chip time in minutes. The men seem to be slackers in this particular case. And it's actually, there's a number of studies that show that women tend to have, as far as doing cross-country, there's a lot of women who have a longer endurance than men. So it's not too surprising. But we can see here the average chip time around 70, and for women over 100 minutes. And then another really cool thing we can do is we can describe the data. So df2.describe, this again is a Pandas function, just like info is. And we're going to include NP number, the NumPy number. And if we run that, you'll see here it comes up and it says chip time in minutes, count, it gives you the average or the mean, standard deviation, the minimum, the maximum, all the different descriptive information you're going to want from your data set on there. And just because there's all kinds of fun ways, let's do a box plot to display your information. We can do a box plot where the column equals chip time in minutes. And let's go ahead and run that. Keep mistyping my chip time in minutes. And you can see it puts out a nice box plot showing you the information. We have our different values and floaters. And this is always interesting because this is a nice way of seeing where we have these floaters, one up here and there's two up above, and of course your nice spread on the box plot. And we can also modify this a little bit, and we can add in by equals gender, and then we'll just give it a blank title. I don't know why we're giving it a blank title. We'll just add a Y label on there for runtime. And if we run this, you can see here box plot grouped by gender, chip time in minutes, and now we have our female and male, two different areas, and you can see how they vary. You have your two different your outlier up here, and you can also see how there's such an overlap between the two different values. So if I was looking at this, I'd be like, wow, I really could not draw a conclusive thing on this saying that women's runtime was more in general because they overlap too much. That would be one of the conclusions I'd have to come up with on here. And then we get to maybe the partners come in from the company and say, hey, we'd like to know the age versus chip time in minutes. That'd be something worth knowing on the statistics on this. And the first thought is we can simply plot it. And we can do this. We can actually plot the scatter plot, chip time versus df2 of age. There's our XY coordinates. But if you remember from df2 when we did the info, let's go way back up here, we're looking at a data object as far as our chip time on this and our age. Now we converted the chip time, but we also need to convert the age. And if we do it right here, we just plot it, and it'll actually let us plot it. It shouldn't. It should give us an error, but it does let us plot it. You'll see the ages come up a mess over here because they're converting it to weird float numbers and all kinds of things. So what we want to do is we want to take our age, and we'll just call this age underscore I. So we're going to take our age and we're going to create another column for df2 age underscore I. And the I is just going to stand for integer. It's our own choice of values. There is a number of ways to do this, but we're going to do Pandas to numeric is the best way in Pandas. And the reason we're doing this is that numeric creates a float value. So right off the bat, we want all our stuff converted. It converts it to the least common denominator. So if they're all integers already, you'll get integers. As you can see from here, it's doing some kind of conversion that converts it to a float value. The other thing that numeric does is if there's a null value, or they put in like a blank line or a dash to represent no information, it'll convert it to a null. So it goes from like a string to a null versus just having some kind of made up number that Python somehow created for the graph we have below. And then we want to add our df2 age, because that's what we're converting to numeric, and then we want to coerce it. And there's a couple different options on this, like you can have it where it just doesn't process it in Pandas, but coerce means that if it gets a weird value, that is a null value now. And since we're dealing with errors, this is what happens when you get an error converting it. We want to coerce it. There we go, and put the end bracket on there. And then finally we want to go ahead and round this off. So we'll put brackets around all the way around it, and this rounds off everything in this series. So what we've done here is I've taken df2 age, which is a d-type object, which in this case is mostly strings with a couple of blank ones in there, and we're going to convert it to a numeric, which will automatically go to float. And then we're going to take wherever there's an error, wherever it says, hey, this doesn't convert, and usually that's a blank string. Like I said, I've worked with so many databases where someone puts down none, someone types in space, some types in a dash to mean none, and you get this really weird conversion coming up. This covers all of that in Pandas. So it's really a nice way of just coercing it and saying, hey, if we don't have a number in there, let's make it a null value. And then we're going to round it off. And then finally, let's go ahead and take our df2. Here's our df2, and let's drop those null values. Drop NA. And we want how equals any. So that means if there's any null values in the data set. Now this might get you in trouble because you might have null values in a different column, and so you might lose data that way. At this point, we could also do like certain parts of like drop just certain columns with null values. There's all kinds of other options in here. But we're just going to do how. We're going to just drop any, and we want to do it in line equals true. So that means it's going to reassign it to df2. So df2 now has rounded out, so it's rounded to the integer. We didn't do any places. The age, and it's going to be age I, and then we've dropped all our null values. That way we're not going to get any errors when we try to plot a null value. And it also makes sure that data, by deleting out the rows, because that's what this does, it automatically does axis 0, which is your rows, axis 1 is your columns. By doing this, it automatically removes all the rows with null values. So it just cleans out the rows. And then when we go ahead and plot this, we see we have a nice clean data, and we have age all the way up to 70. So we have our chip time set, and then our age going across, and it makes a nice plot that you can easily show for display and for and you can easily show that to your shareholders or whatever group you're working on. It makes a really nice and quick, easy display.
And now Anjali is going to explain how you can become a Python developer. Following that, Richard will cover 50 hand-picked interview questions that you might face in your job interviews.
A very warm welcome to this video on how to get a job as a Python developer. The job of Python developer is one of the most sought after in the market right now. And for that very reason, it might not be that simple to land this job. So in today's video, I'll give you 12 tips on how you can land this job. So let's begin. Tip number 1, build your own GitHub repository. So go on GitHub, create a repository and add all your files, all your Python codes on there. So it doesn't matter if it's a big project or some small piece of code where you just took some input and made some manipulations, displayed it. Every work counts. Learn a bit of GitHub version control. So not only do you upload your file once, but you can make modifications to them, rework on them, make it better, upload it again, showing your progress. Now this GitHub repository basically becomes your resume as a Python developer. The recruiters can look directly on here instead of you sending them zip files or even Jupyter Notebooks. Everything is now available online and they can access it from anywhere through any machine. So this really shows that you're not just writing code for yourself, but you want to share this with other people. And that's very important. Tip number 2, make sure that your code is readable. So when you're putting your code out in GitHub, as I mentioned previously, you're writing this code not just for yourself. So if people want to learn from your code, they want to view your code, it's necessary that they understand this code. And of course, there are a few guidelines to follow which makes your code more readable. The most important one being you follow the PEP 8 style guideline in case of Python. So the PEP 8 style guideline is basically some conventions that you use, and that mainly talks about indentation. So in case of PEP 8, you have a 4-space indentation. Tabs and spaces, there's maximum line length, which in case of PEP 8 is 79 characters per line. The line breaks that you need to put blank lines. For example, every major class or every major function needs to be separated by 2 lines, 2 blank lines. The source file encoding string quotes, white spaces in expression, trailing commas, naming conventions, and so on. So again, very basic thing, if you're having a variable, make sure the variable name shows what the variable stores, what it is used for, and it's not just some vague name such as var1, var2, and so on. Tip number 3, create a good documentation. Again, this helps with the readability and the understandability of the code. So one of the main things with creating a good documentation is having a README file in your GitHub repository. The README file should contain details regarding your project, what your project does, the various libraries used in your project, and so on. So this is a great help to anyone who is trying to learn from your code or implement them in a different way. Now here we have a screenshot of the README file created by Raymond Hettinger. It's present in his GitHub repository. Now, who is Raymond Hettinger? Well, that brings us to our 4th point. Raymond Hettinger, like another guy, Kenneth Reed, these are some of the very popular personalities on GitHub. They have a very unique style and a very neat and organized style of coding. And one of the great ways to develop your own coding skill is to look at other people's code. Now, when you're looking at other people's code, it's important to remember that you look at code which is of your own skill level. So if you're an
intermediate coder, make sure you look at someone's GitHub repository who again codes on the intermediate level so that you're able to connect with that code. You could probably write the same code, but he or she writes it in a better manner. Now, these are some of the people who have great GitHub repositories. You can definitely learn a lot from them. Tip number 5, read books on Python coding. So you might know already quite a bit of Python. In fact, if you're looking for a Python developer job, there's a good chance that you are an advanced coder, but nothing beats books. Here are some of the very popular and well-renowned books for Python. Fluent Python, Automate the Boring Stuffs with Python, and so on. Now, Fluent Python is a great book to start with. What it does is it gets your Python concepts really strong. So now you'll have not only great skills, but also the perfect way to portray these skills. Tip number 6, grow your Python skill set. Of course, you can never stop learning, keep learning. And some of the very important things when you go for a Python developer job is to make sure that you know how to work with some of these Python libraries. In fact, make sure that while you can cover most of these libraries, there are certain ones that you have completely mastered. Some of the very popular libraries with Python are NumPy, SciPy, Matplotlib, TensorFlow, and so on. So learn these, master them, create projects around them, and finally put these all up on GitHub for everyone to view. Tip number 7, it's never enough to just know a language. You must know how to apply it. And with Python, some of its most important and popular applications are in the field of AI, machine learning, and data science. So master AI and machine learning with Python. Learn the various algorithms that these fields use and implement projects on them. As you can see here, we have 2 of the algorithms with machine learning. That's linear regression, k-means clustering. Neural networks is an algorithm used with deep learning. So make sure you have some of these applications up there in your repository. This displays your skill not only in Python, but also in other fields. And both of these going hand in hand just increases your value. Tip number 8, take freelancing projects to start off with. So far, I mentioned how you write your own code, you create your own projects. Now that's not enough. Take up projects by companies. Now these may be non-paid, they may be really low paid. Does not matter as long as you have something to show off. So you have a project under your belt that really pays off. Now some of the websites you can go to for freelancing works are Freelancer, Upwork, Twago, Truelancer.com, and so on. So this really shows to the recruiter that this person did not just learn Python, but he or she is always looking at how to implement them, how to use them. Tip number 9, make open source contributions. So you have your own GitHub repository, that's great, but now look into others' repositories. See if there's some value that you can add, and if you can, definitely go for it. This shows not only your skill, but also that you're a team player. You want to add value to work that is already existing, and that is a skill that's again really valued in organizations. So some of the popular ones include pipenv, which is the Python development workflow for humans. There's also Chatistics, where you can convert your Messenger and Hangout chat logs into data frames. Then you can solve your traveling salesman problems using self-organizing maps. And there's also a Python to BPF converter. So these are great places to make your contributions. In fact, we have the links for some of these in the description below, so please check them out. Tip number 10, start a blog and talk about what you have learned. So having your own personal blog will add a lot of credibility to your profile. In your blog, you can definitely mention where you started off from. That is, at a beginner level, what all did you know, how you took on your journey to where you are now, what materials you used to collect information, and what projects you took on, how you went about this, mention any papers you wrote, and so on. All this again becomes another profile for you. The recruiters can have a quick look at your personal blog and have a good idea of what kind of a learner you are, what kind of a coder you are, and if you have done everything right, this could create a great impression on the recruiters. And if you have done everything right, this will create a great mark on the recruiters. So here's a screenshot on Ned Batchelder's blog on Python. It'll give you a good idea as to how to create a blog and how to go about it, so please check that out. So here's a list of all his blog posts. He has 227 blogs just for Python, and he writes on various topics. For example, here we have a screenshot of, is Python interpreted or compiled? In fact, you can even include some of your personal views on Python, on the learning process or the learning curve of Python, and so on. Tip number 11, follow a daily schedule for practice. So just because you think you have mastered the language Do not put it aside and let it collect dust. Take out some time every day, write code whether small or big. Make sure that every aspect of Python is at your fingertips. And finally, tip number 12, keep your resume and profile updated on job portals such as LinkedIn, Indeed, Glassdoor, and Career Builder. Look out for Python developer job roles on these sites and Google Jobs, Simply Hire, Dice, and more. A recently updated resume always captures the eye of the recruiter. So these are some of the tips you can follow to bag that Python developer's job. If you're new to Python and require some help in gaining the skills to attain that job of a Python developer, you've come to the right place. Just go to our website, Simplilearn.com, and in here we have just the course for you. In fact, we have a number of courses for Python, but you can start off here with Python training course. This course covers everything A to Z for Python, and it's pretty much all you require to get that job. So before you take up the course, you can definitely go through everything that it covers, the objectives, who should take up this course, the prerequisites, what projects are covered under the course, and also the subheadings of the various topics covered.
Certainly the questions we're going to ask in here are very general with a few specifics towards data science, since that's the main direction that Python's going in. And you'd want to expand your questions for your interview depending on the domain that you're using the Python in specifically. Let's dive in and get started with some Python interview questions. Number 1, what is the difference between shallow copy and deep copy? And you can see with shallow copy we have object 1, which has child 1, child 2, child 3, and so on, and object 2, which has child 1, child 2, child 3. A deep copy creates a different object and populates it with the child objects of the original object. Therefore, changes in the original object is not reflected in the copy. Copy.deepCopy creates a deep copy. Shallow copy creates a different object and populates it with the references of the child objects within the original object. Therefore, changes in the original object is reflected in the copy. Copy.copy creates a shallow copy. And you can look at this. If we make a change to child 1, it's only a pointer. So if you make it in object 1 and a change to child 1 in object 1, it will also make that change in object 2. Number 2, how is multi-threading achieved in Python? Oh, this is a good one. With multiprocessing and multi-threading, this question is actually asking you, do you know the difference between multiprocessing and multi-threading and how multi-threading works? Multi-threading usually implies that multiple threads are executed concurrently. The Python global interpreter lock doesn't allow more than one thread to hold the Python interpreter at that particular point of time. So, multi-threading in Python is achieved through context switching. It's very different than multiprocessing, which actually opens up multiple processes across multiple threads. So, multi-threading. Discuss the Django architecture. So the Django architecture, and the first thing to know is that the Django is a web service, way to build your web pages basically. And so when you look at the architecture, you can see here we have a nice model drawn out where the user initiates the Django, which initiates the URL, which initiates the view, what they're going to view, and you have your model and your template. So the model of data, whatever data model you're pulling, goes into the template and then goes back up the pipeline to the user. And the important thing to note is there's a template, the front end of the web page. This is what they're going to see. There's a model, the back end where the data is stored. So you can keep the template and the looks and everything looks the same, but you can swap out the underlying information that goes into that template. Then you have your view, which interacts with the model and template and maps it to the URL. And then the Django serves the page to the user. So your Django grabs it and says, okay, thank you for the URL, and here you go, user. What advantage does NumPy array have over nested list? So NumPy is a module you import. Almost always see NumPy, import NumPy as NP. NumPy is written in C, such that all its complexities are backed into a simple to use module. Lists, on the other hand, are dynamically typed. Therefore, Python must check the data type of each element every time it uses it. This makes NumPy arrays much faster than lists. I would also add in that NumPy has a lot of additional functionality that you don't have in lists. So there's a lot of things you can automate in the NumPy. Quick flip over to our Jupyter Notebook. Any IDE will work. If you're going to do a set of interview questions, taking a quick look at code is always important. We have our import NumPy as NP. We'll go ahead and import time. Here's our list sub for I in range of 100. And what we're doing is we're going to time it. So we're going to create a list. Then we're going to create a NumPy zeros array. And you can see here, look how quick you can create this NumPy zeros array. Here we are appending 1 0 at a time for a regular Python list, and here we are with NumPy. They're all zeros, and they're all of type integer. I believe it's either float or integer on this. I'd have to actually do a type on it. And then so if we take in and we create a TL1 time equals time, and then we do for I in range of 100, for j in range of 100, L of I j equals L of ij plus 5. So we're just doing a simple calculation on our array and subarrays. This is an array of arrays. And we'll do the same thing with TL2. TL2 time.time, TL1 equals, so here we have our final time on that. And then we'll do this with an array op, and this is what I really love, a equals a plus 10, and then you can just print it right out. So you can see right here with the NumPy array, we're doing the same thing. If I run this, our time is significantly different. Here we have 0.09 and 0.003. So you can see that the time drops significantly when you're running this on a NumPy array versus a list array. Also important to note, these times aren't going to be, they'll change each time I run it depending on what I have running in the background. So there we go. Number 5, what is pickling and unpickling? Amazes me how many times I pickle and unpickle something. Converting a Python object hierarchy to a byte stream is called pickling. Pickling is also referred to as serialization. Unpickling, converting a byte stream to a Python object hierarchy, is also called unpickling. Unpickling is also referred to as deserialization. So if you just created a neural network model, you can now save that model to your hard drive, pickle it, and then you can unpickle it to bring it back into another software program or to use at a later time. How is memory managed in Python? Number 6. Python has a private heap space where it stores all the objects. The Python memory manager manages various aspects of this heap like sharing, caching, segmentation, and allocation. The user has no control over the heap. Only the Python interpreter has the access. You have a nice little diagram here. Here's your program. There's your interpreter. We have our heap, memory management on the garbage collector going off of there. Number 7. Are arguments in Python passed by value or by reference? Arguments are passed in Python by reference. This means that any change made within a function is reflected on the original object. So you can see here def function of L of 0 equals 3, L equals 1, 2, 3, 4, function L, print L, and you're going to get 3, 2, 3, 4 because we passed L in there, so it's a pointer. Here we have def function L equals 3, 2, 3, 4, L equals 1, 2, 3, 4, function of L, print L. Because in this function I have assigned, instead of operating on a piece of L, the list, I've assigned a whole new value to that list, or L. It then at that point will create a new object. So if I make changes to the object, it's going to change it in the outside the definition. If I use a variable and I assign it a completely new value, like L equals 3, 2, 3, 4, that will not show up when you're outside the function. Number 8. How would you generate random numbers in Python? To generate random numbers in Python, you must first import the random module. The random function generates a random float value between 0 and 1. The random range function generates a random number within a given range. And you can see here 1 is the lower end, 10 is the upper end, and step 2. So it would be 1, 3, 5, and so on as far as the options in the random generation. Number 9. What does the double forward slash operator do? In Python, the forward slash operator performs division and returns the quotient in float. For example, 5 over 2 returns 2.5. To do a double forward slash operator, on the other hand, returns the quotient in integer. For example, 5 double slash returns 2. 5 divided by 2 and you drop the 0.5. Number 10. What does the is operator do? The is operator compares the ID of the two objects. And you can see in here where list1 equals brackets around 1, 2, 3, list1 equals list2 equals true. And you have the double equals in Python, of course. And you can do list1 is list2, where list2 equals 1, 2, 3 is false. List2 is not the brackets 1, 2, 3. It equals it, but it's not the brackets. And if we do list3 equals list1, then list1 is list3 equals true. Number 11. What is the purpose of pass statement? The pass statement is used when there's a syntactic but not an operational requirement. For example, the program below prints a string ignoring the spaces. And so here we have variable equals Simplilearn. We've added 2 spaces in it. For I in variable, so it goes through each I. If I equals space, do nothing. Else, print I, and then we'll have the end equals bracket, bracket, and they'll print out Simplilearn. Now, of course, you would probably write this if I does not equal blank space, print. But this would be another way you could do that if you need a placeholder for that first logical set or that first area. And you can also do a function like this. You could do function, whatever your def function name, brackets, colon, pass. So it goes into the function and does nothing, but it's a placeholder. Number 12, how will you check all the characters in a string are alphanumeric? Python has an inbuilt method, isAllNumber, which returns true if all characters in the string are alphanumeric. And so you can see here, ABCD, 1, 2, 3, isAllNumber, output equals true. And the second line, ABCD, the @ symbol, 1, 2, 3, the pound symbol, isAllNum, output equals false. So really you just want to know about isAllNum, all numerical, alphanumerical. Number 12, how will you check if all characters in a string are alphanumeric? So here we go. If you know isAllNumber, which returns that the characters in the string are alphanumeric, one can also use regex instead. And so we have Boolean RE match. What's important about this is to note your capital A dash to capital Z, A lowercase to dash to Z, 0 to 9 means that that array includes all of those, the way they have it written out, plus a $sign, and then we have what we're comparing it to, the string we're comparing to, the ABCD 1, 2, 3. And so we can do an RE.match, and if it matches, if all these things, if all the different entities in that array matches the first one, we get an output true, and if not, an output false. Number 13, how will you merge elements in a sequence? Sequence. There are 3 types of sequences in Python. There's lists, tuples, and strings. Python, of course, makes this easy. If we have a list 1 and list 2, and list 1 is square brackets 1, 2, 3, list 2 is 4, 5, and 6, we can simply do list 1 plus list 2. And our output is 1, 2, 3, 4, 5, 6. If we have tuples, your tuple is the curved brackets designates it, and again, just add them together. Same thing with strings. We have Simplilearn, S1 plus S2 equals Simplilearn. Number 14, how will you remove all leading whitespace in a string? Python provides the inbuilt function lstrip to remove all leading access from a string. And you can see here, space python dot lstrip, leading strip, Python. And you can also do strip, which relieves leading and ending. Of course, there's also the ending set. Number 15, how will you replace all occurrences of a substring with a new string? The replace function can be used with strings for replacing a substring with a given string. Syntax, string.replace old, new, count. Replace returns a new string without modifying the original string. Hey John, how are you, John? ? Replace John with capital JOHN 1. And then you can see right here, hey John, how are you? And since we designated with the 1, just says we're only going to replace one of these. 16. What is the difference between del and remove brackets on lists? Del for delete. Del removes all elements of a list within a given range. Syntax, del list start to end. Remove. Remove brackets removes the first occurrence of a particular character. Syntax, list, remove, element. And we see a nice example over here. If we delete the list 1 to 3, it will delete the first, in this case B1, 2. It doesn't do 3, remember that. 1, 2, so it will delete B and C and you end up with a D. Where if we do remove B from the list and we have an ABBD, it's only going to remove the first B. Number 17, how to display the contents of text file in reverse order. Open the file using the open function. Store the contents of the file into a list. Reverse the contents of the list. Run a for loop to iterate through the list. Number 18. Differential between append and extend. Append adds an element to the end of the list. You can see right here we have a list 1, 2, 3, 4, and we append 4, and we end up with an output 1, 2, 3, 4. And extend adds an element from an interval to the end of the list. And we have here list equals 1, 2, 3, list.extend 4, 5, 6. Output is 1, 2, 3, 4, 5, 6. So if you want to append an array to the end of another array, you want to use the extend. Number 19, what's the output of the below code? Justify your answer. This is a great interview question because these are the kind of things that come up when you're proofing code. Def, add to list, value, and list. So we have value in and a list in, or list equals an empty, in this case, an empty list. List.append value, return list. List 1 equals add to list 1. List 2 equals add to list 1, 2, 3, empty bracket. List 3 equals add to list A. and then we want to print them. List1 equals, and you can see the formatting. We have our placeholder, list1, list2, and list3. So when it prints list1, we get 1, comma A. And what you want to notice here is that list1 and list3 are equal. Why are they equal? Well, when we passed the information to the add to list, we passed value without passing the list equals brackets, without passing a second value. What this means is that list, as we have it, if you don't have a list, it'll start off with empty list, which we append the 1 to. The second one, list 2, we appended a value to an empty list. So it's only going to be 1, 2, 3. It doesn't matter what the list was before, we've already assigned an empty list. And then list 3, here's the tricky one. We're adding A to the list, but because we didn't designate the list, list is a shared value. In other words, it doesn't reset it. And we end up with list1 equals list3, 1, comma A. Default list is created only once during the function and not during its call. Number 20. What is the difference between a list and a tuple? Lists are mutable while tuples are immutable. And you can see an example down here where I have list equals 1, 2, 3. Square brackets denote it's a list. List of 2 equals 4, and I print it out and I now have 1, 2, 4. If I do the same thing with the tuple, I get an error, because you can't change the tuple 1, 2, 3 into 1, 2, 4. You have to completely reassign tuple to a new value. What is docstring in Python? Docstrings are used in providing documentation to various Python modules, classes, functions, and methods. And so you can see here we have def for a function, add AB, and this is a docstring. We have the triple brackets on there. You can add carriage return in that so that you can go multiple lines. And it says this function adds 2 numbers. And then sum AB returns sum. And so we have down here 2 different ways of accessing this function. Output, accessing docstring method 1, this function adds 2 numbers. Accessing docstring method 2, help on function add in model main. This function adds 2 numbers. And so you can see the code down here has 2 very different end values. The second one is basically a help menu. There's our help menu. Number 22, how do you use print without the new line? The solution to this depends on the Python version you are using. In Python version 2, you can do print hi and then you add a comma afterwards. Print how are you? And you have hi, how are you? In version 3, print hi, comma, end equals, and it'll add a space on the end there. You can put different characters in there, but generally you just want to put a space on the end. Print how are you, and now we get hi, how are you? Number 23, how do you use the split function in Python? The split function splits a string into a number of strings based on a specific delimiter. So we have string, split, delimiter, comma, max, the maximum number of splits. The character based on which the string is to split by default is space. So here we have an example. We have a variable red, blue, green, orange, and we want to split it by commas, and we only want to do the first 2. So if we print the list now, you'll find it has red, blue. It only split it the first 2 times, and then it gets to the third one and just groups them all together, green and orange. If you leave the 2 off, it'll split the whole thing. Number 24, is Python object-oriented or functional programming? Python follows object-oriented paradigm, and you should really know in depth what they mean by object-oriented paradigm if you're doing any interview for scripting languages. Python allows the creation of objects and is manipulation through specific methods. It supports most of the features of OOPS, which has inheritance on a polymorphism. So you have an object and you can inherit all the traits of that object and then add new traits in or alter some of those traits. That's what object-oriented means. Python follows functional programming paradigm. Functions may be used as first class object. Python supports lambda functions, which are characteristic of functional paradigm. So you can set a variable to a function as opposed to setting it to an object. Number 25. Write a function prototype that takes variable number of arguments. Here we have def function name list. So we could have, in this case, whatever the list is, def function. The asterisk denotes that we're going to take multiple arguments of a variable, and then we can do for I in var, print I. So if you send function of 1, you'll end up with a function 1, 2, 5, 6. It'll actually print those out one at a time. The first one just prints out a 1 because it only sent 1 variable. The second one will print 1, another line 25, another line 6. Number 26. What is asterisk args and asterisk quargs? Args used in function prototype to accept varying number of arguments. It's an iterable object, def function args. And you can imagine it's just a basic list. So if I add the numbers a comma b or a comma b comma c, it doesn't really matter. It will have that number of objects in it, whatever I send to it. And there's other uses for it, but that's very basic. Quargs, I can actually tell it what I want to send. So used in a function prototype and to accept varying number of keyworded arguments. Both are iterable objects, so you can go through them one at a time. And the def function quards, you can now set like color equals red, units equal 2. So you'll see that, especially in machine learning, there's a lot of they'll have inline equals true, that kind of thing. Number 27. In Python, functions are first-class objects. What do you understand from this? This means I could return a function. It could be one from another function. I could create a function and treat it just like an object. I can assign it to a variable. I can pass them as arguments to other functions. Number 28. What is the output of print name __ name? Justify your answer. The double underscore name double underscore is a special variable that holds the name of the current module. Program execution starts from main or a code with 0 indentation. Thus, double underscore name has a value double underscore main double underscore in the above case. If the file is imported from another module, then double underscore name double underscore holds the name of this module. Number 29. What is a NumPy array? And we briefly touched NumPy array compared to a list earlier in processing speed. Now let's go ahead and look at some of the more specifics. A NumPy array is a grid of values, all of the same type. So if they're either all float, all integer, all string, and is indexed by a tuple of non-negative integers. The number of dimensions is the rank of the array. And the shape of an array is a tuple of integers giving the size of the array along each dimension. Number 30. What is the difference between matrices and arrays? A matrix comes from linear algebra and is a two-dimensional representation of data. It comes with a powerful set of mathematical operations that allow you to manipulate the data in interesting ways. Now, an array is a sequence of objects of similar data type. An array within another array forms a matrix. Like we said here, two-dimensional, so if you have an array of 3 by 4, that would be a matrix. Number 31. How to get indexes of n maximum values in a NumPy array. Of course, the first thing to do is to import your NumPy as NP. You don't necessarily have to use NP, but that is the most standard use of NumPy. We create our array equals an np.array of 1, 2, 3, 4, 5. And then if we want to get our indexes of n maximum values in a NumPy array, we can do, one way to do it is to take our array, sort it, then do -n colon. That means we're going to do, once you've sorted it, you can do -n. N would equal then the number of indices, so it's not the actual letter n, colon. And really this is about understanding this notation, that we can sort it, so it goes from lowest to biggest, and then we can get the top values for n indexes. And then we have our final set of brackets with the -1 on there. Number 32. How would you obtain the resulting set from the train set and the test set from below? And let's go ahead and look at the two different variables. We have train set equals an array of 1, 2, 3. Test set equals a NumPy array of arrays. We have 0, 1, 2, 1, 2, 3. What's important here is that one, it's a NumPy, so that leaves A out, and then we're stuck with 3 other options, and I'm going to say that D is out, none of these. And let's look at np.concatenate versus np.vstack. Concatenate would put one set after the other, so you would end up with, probably give you an error, because one set is 1, 2, 3, and then we're going to concatenate array 0, 1, 2 and array 1, 2, 3, the array of arrays onto the end of that. What we really want to do is stack, and by the way, you can actually switch, there's variables you can put into concatenate obviously that can change this, so you could use the concatenate with a lot of fudging around. But really what we're looking for is VStack. V stands for vertical versus the HStack, which is horizontal, and if we do a VStack we can simply do train set comma test set and stack them together. And so we have C, resulting set equals np.vstack train stack test set. Both option A and B would do horizontal stacking, but we would like to have the vertical stacking. Option C does this. Again, you could add the axes in and use the concatenate to stack it the correct way. Number 33. How would you import a decision tree classifier in Scikit-Learn? We have scikit-learn.decisiontree import decision tree classifier. From Scikit-Learn ensemble import decision tree classifier. And we look at these and they're all import decision tree classifier. That actually last part happens to be correct. And it's really just a vocabulary knowing where is the decision tree classifier stored. What module is that a part of? And it is, of course, part of the scikit-learn.tree. Number C. Number 34. You have uploaded the dataset in CSV format on Google Spreadsheet and shared it publicly. How can you access this in Python? What's important here is to know that we can read stuff with Pandas. So we don't show it here, but you can. There's actually a number of ways to do this. What's important here is to know a couple things. One, we have our link generated from the Google Docs and spreadsheets, and then we can do a string.io request get link.content. So there's our source. And then finally, we know that Pandas can read a CSV. There's obviously many ways to read a CSV, but data equals pd.read_CSV source. Number 35. What is the difference between the two data series given below? Below we have df name and df location, colon, comma, brackets around, asterisks around name, comma, where. And then we have df equals pd data frame, AABBXXUU, comma, 21, 16, 50, 33, columns equal name and age. So let's take a look and see what they're looking at. We have, just glancing at the questions, they want to know, is it the original data frame or is it the copy of the data frame? And you can see here that 1 is view of the original data frame and 2 is a copy of the original data frame. 2 is a view of the original data frame and 1 is a copy of the original data frame. Both are copies, both are views. And if you're working with Pandas, you know that unless you specifically in certain things tell it to do it inline, and a lot of functions don't allow you, that you're always taking a slice and it is always a copy. So C, both are copies of the original data frame. Number 36, you get the following error while trying to read a file, temp.csv using Pandas. Which of the following could correct it? So here's our error. Trace back most recent call last, file input, line 1 in module, Unicode encode error. ASCII codecs can't encode character. Ooh, I hate it when that one comes up. And we have 4 different entries. We'll go ahead and just pretend that D doesn't exist unless we really can't fit it into one of the other answers. And the first one is PD read CSV has our file compression equals gzip. Well, gzip is just an unzipping and you actually get a zip error on there. The second one is dialect equals string. Again, not an encoding or coding setup. And then we have encoding equals UTF-8. Well, that would be the encoding error, switching it from the character code. There's UTF-8, there is Unicode. That's the most common two that it goes between. So really this is about understanding the difference between a UTF-8 coding and a Unicode and the error that comes up quite regularly with that. Number C, encoding should be UTF-8. Number 37, how to set a line width in a plot given below. So looking at this, we have import Matplotlib, pyplot as PLT, and you should know your way around this, how to do a plot in there. PLT.plot 1, 2, 3, 4, plot equals show. And so this is a little bit of a vocabulary test. The vocabulary is it width equals 3, line width equals 3, LW equals 3, or something else. And the vocabulary word that we're looking for is LW equals 3, which stands for line width in pyplot. Number 38. How would you reset the index of a data frame to a given list? So this is a vocabulary challenge in understanding what reindexing is. Reindexing, as we have the different values here, we have the first one, which is reset the index. Well, we're not really resetting the index. Reindex number B means we are double checking our indexes to the column and to the main index, and so the values match correctly. Where reindex like now brings in a new index outside of our data frame to a given list. So this is coming from external, and thus the vocabulary word like is our key word, that it's external, and we have a data frame to a given list. Number 39. How can you copy objects in Python? The functions used to copy objects in Python, we have copy for shallow copying and copy deep copying for deep copy. Number 40. What is the difference between range and xrange functions in Python? Well, this is a good one. We have matrices and arrays. With a matrix, the range returns a Python list object. Xrange returns returns an xRange object. And with arrays, an xRange returns an xRange object. xRange creates values as you need them through yielding. The key here is that xRange returns the values as you need them. So it actually processes it post, like if you have for x or for a variable in xRange, it is processing them as you need them, 0 to 9. It doesn't create an array 0 to 9, it just hands you 0, then 1, 2, 3, 4, 1 at a time. Number 41, how can you check whether a Pandas data frame is empty or not? The attribute df.empty is used to check whether a Pandas data frame is empty or not. And so you can simply create we have down here import our Pandas as PD. We create our Pandas data frame equal to an empty array, and is df.empty comes out as true. One of the catches you got to remember with these vocabularies is with empty along with some other Pandas setup, whether you need the brackets or not at the end. Number 42. Write the code to sort an array in NumPy by the n-1th column. This can be achieved using argsort function. Let us take an array x, then to sort the n-1th column, the code will be x to colon n-2.args_sort. So let's see what that code looks like. We import NumPy as np. We'll create our array, our NumPy array, which is 1, 2, 3, 0, 5, 2, 2, 3, 4. So we have 3 different entities with 3 different columns in there. And we go x of x, and so we take x of all the rows, first entity, or in this case it's actually the second one because it's 0, 1, 2, .argsort. So that would be the second entity, or -2 would also be the same. You could also do, instead of 1, you could also do -2 there instead of the 1. Argsort, and then we get an output of the array 1, 2, 3, 0, 5, 2, 2, 3, 4. Number 43, how to create a series from a list, NumPy array, and dictionary. So we'll go ahead and import our NumPy, our Pandas, and have my list. And you can see here we have my list equals list of A, B, C, D, E, F, G all the way through. So my list now makes a list of that. For array, we have np.arange to 26. My dictionary will create a dictionary with zip my list, my arguments. So I'll just use the NumPy array we just created with my array to go into the dictionary. And the solution is simple with the pd.series my list, pd.series my array, pd.series my dictionary. So it's all about knowing the dot, capital S-E-R-I-E-S. Don't forget that capitalization. Number 44. How to get the items not common to both Series A and Series B. And you can see here we have, instead of Series A and B, we have Series 1 and 2, and we have 1, 2, 3, 4, 5, 4, 5, 6, 7, 8. The solution is we take a Pandas series, we have a series U equals a Pandas series, NP union 1 dimension, Series 1, Series 2. So we can now make a union of them. We now have Series 1 Pandas series with an intersection, and then we can remove one from the other. Series U is Series U dot is in Series 1. So if the union is not in the intersection, then you know it's a unique value. A little bit of logic going on there and playing with 3 different terms to get the answer we want. 45. How to keep only the top 2 most frequent values as it is and replace everything else as other in a series. So again, we're working with Pandas, because if you're talking series and data frames, that means we're working with Pandas. So we're going to import Pandas as PD. We'll go ahead and create our Pandas series. We're going to do that by creating a NumPy random state 100, so 100 in the NumPy one. And then we have our Pandas series. You can see here we're random integer, NumPy random.random integer 1, 5 by 12. And so the solution for this is we go ahead and we've created a PD dot, remember the capital S series solution. We're going to print the top 2 frequencies, and that is our series dot value counts. And then we take series values count dot index of up to 2. So we're going to take everything up to 2. And then we'll do the series is in. So if it's not in the first 2, then it's going to equal other. And this would be something you'd want to write down on paper. If it looks confusing, take a moment, pause the video, write this down, and see if you can figure out how the logic came together and try to throw yourself a couple other little logic puzzles like this. Number 46, how to find the positions of numbers that are multiples of 3 from a series. And in here, we're actually going to use a NumPy to solve it. The first part, series, lets you know it's going to be a Pandas series. And if we come down here, we have np.argwhere, so this is a vocabulary question, series with, remember the percentile 3 is a remainder, so if the remainder equals 0, then we're going to generate that string where the object divided by 3 equals 0 has no remainder, so that we know it's a multiple of 3. Number 47, how to compute the Euclidean distance between two series. And this one's really cool because we have our Pandas series, P and Q. And what I like about this one is they give us two solutions you can go with. And really you should kind of know both. The first one would be, yes, you know what the Euclidean distance is. And that is we can take the first series minus the second series squared. And then sum them up, and then we do the square root, which is the same as taking the power to 0.5. Doing the power to 0.5 is easier than doing the square root. So a lot of times you'll see that as a switch, but you could have also done the square root and used the math in there. So there's solution 1, you should know your Euclidean distance. And then solution 2 is the NumPy solution. So we have np.linalg.norm. That's how we're going to compute our Euclidean distance. P minus Q. Very elegant and very straightforward and easy to compute. Number 48, how to reverse the rows of data frame. So here we have our data frame. We're going to create a NumPy array by 25, reshape it 5 minus 1. And this creates a 25 by 25 data frame. And so our solution is to do the df location. And this is just understanding how steps work. The steps, you have your colon, colon, minus 1. So we're taking all the rows, all the columns, minus 1. So we're stepping minus 1 going the reverse direction. And then we're just going to use across all the different columns on there. Let me say that again. The first colon is going to be your row. Starting row, stopping row, step minus 1. That's all this is about, is that step minus 1, comma, and then all the columns. 49. If you split your data into train test splits, is it possible to overfit your model? And the answer is yes, is definitely possible. One common beginner mistake is retuning a model or training new models with different parameters after seeing its performance on the test set. My favorite example of this is you have your script put together and you keep hitting the rerun button until you get the answer you want, not taking the answer it first gave you, or running it over an array and recording all the answers to see how they vary. Number 50, which Python library is built on top of Matplotlib and Pandas to ease data plotting? The answer to this is Seaborn. Seaborn is a data visualization library in Python that provides a high-level interface for drawing statistical information informative graphs.
I hope this helps you in your interview. With that, we've reached the end of this complete Python course. I hope you enjoyed this video. Do like and share it. Thank you for watching and stay tuned for more from Simplilearn.